reports. One was supply chain report, where we discussed potential of various Indian companies in, services, specialty chemicals, paints, to come at par with, requirements of semiconductor manufacturing industry and be part of the supply chain ecosystem. Second report we talked about was the semiconductor market demand in India itself. So as per this research report, the market demand in India in 21 is about $27 billion. This is the consumption demand, not the procurement demand. And this demand will hit about $65 billion by year 2026. This is again very unprecedented demand, supported by growth in various industries, which is telecom, which is led by 5G in coming 3-4 years, then smartphone, which is the largest contributor to this growth, and also the information technology, consumer electronics, and automotive and industrial products. Now, one important point to understand here is among the various category of semiconductors, such as processors, memory, connectivity, power, etc., the largest contribution to this market is processors. And that's where, the angle of AI that we are discussing today comes up. So all the AI algorithms or all the deep learning algorithms, for whatever application you talk about, eventually they have to run on a processor. Whether it's a CPU or GPU or microcontroller, that doesn't matter, but it has to run on a processor. And processor demand, hence, will continue to be very strong. And of course, the processor with AI accelerators or GPUs will become more and more important. Today and in coming years, every business function would be infused with AI. An enterprise application will need ability of running AI from the data center, but at the same time, variety of other application would be running AI at the edge. In this slide, I'm just covering some of the business functions like human resources, talent acquisition. Already AI is playing a big role of, parsing and resuming, separating the resumes, and also scheduling interviews with the candidates, etc. Marketing, sales. Already when we go and book airline tickets, automatically AI is able to figure out the demand and supply and, do the dynamic pricing based on, the demand and supply. Information technology and security, cyber security, fraud detection, AI is playing important role. Manufacturing AI is starting to play important role, including the manufacturing of semiconductor. In customer service, we all use net banking and various other portals, and we see AI-enabled chatbots or natural language-based bots or virtual assistant playing a big role, and the product development prototyping. If you talk about industrial AI revolution, in variety of application, whether it's manufacturing, this source of this data in my slide is from NVIDIA. Manufacturing, it is assumed that, by in next 5 years, it would be a huge $2 trillion worth of industry based on AI. Agriculture, another 164 billion. Transportation and logistics, semiconductor and electronics, warehousing and logistics, aerospace industry, automotive industry, especially led by autonomous vehicles, and then metals and mining. All these with AI will add huge economic value for different industry verticals. Looking at India market specifically, in government-led smart city initiatives, there's smart traffic management, smart parking, public safety and security, smart lighting. Those are the areas for AI to play a role. In education, we are already seeing smart classrooms, smart attendance system, and student engagement. Analytics running through video is a good example of AI. Then in the railways and transportation, we are seeing smart video analytics at the airports, then smart displays, media servers, ticketing kiosks, etc., all having a potential for AI to revolutionize how the consumer interacts with the systems. Some of the other application that we are seeing in India that is already using a lot of AI, one is robotics for warehouse automation. As we all know how the e-commerce market is growing in India, that's spurring the demand for very large size warehouses. And these warehouses with millions of SKUs, it's humanly impractical for a person to go figure out where to pick the goods and where to bring it to the invoicing point. All this is done by automated guided vehicles which run a lot of AI algorithms through the video, and they are able to, fulfill all the requirements. Then drones for agriculture, GIS mapping, delivery, and defense are running all AI processor-based algorithms. Intelligent video analytics. In the past, for smart cities, we all actually just had the dump video being, recorded in a place. In case of incidents, we were going back and looking at that video. But now with AI and smart video analytics, real-time alerts can be raised, and also the automated number plate recognition and also automated toll booths will eventually remove, long queues at the toll booths. Same way, Industry 4.0 or smart manufacturing with machine vision will do a lot more tighter quality control with AI in coming days. And these are the applications we are already seeing booming in India. So in nutshell, AI is playing a role worldwide and also playing an important role in India. So the time is very apt that our Hyderabad chapter has started this summit starting last year. And I wish all the best to the conference for next 2 days. And before I close, I also like to thank all our sponsors for this event, which have helped us to basically, organize an event of this stature. Thanking all our sponsors, naming them Micron, Qualcomm, AMD, BrainChip, Indie, Ignitarium, Cadence, and Moschip. And thank you also once again to Venkata, Kamal, and Satish, all our Hyderabad chapter members to take the initiative to organize this conference. Thank you. Over to you, Kamal.
Thank you, Mr. Vivek, for your concluding remarks, and also thanks to the IESA team to organize and support this AI Summit. With this, we conclude the inauguration session with sincere thanks to Shri Jayesh Ranjan ji, Mr. Venkata Simadhuri, and Mr. Vivek Tyagi ji. Let us change gears and move to our first technical session. The theme of this rest of the morning session is impact of AI on the semicon industry. Please note that if you have questions during the talk, then feel free to type in your question in the Q&A section in your viewing platform. We will try to take as many questions as possible, depending upon the availability of time. The first in this session is a visionary talk on the future of computing by Dr. Ivo Bolsens, Senior VP and CTO AMD. Dr. Bolsens is a Senior Vice President and Chief Technology Officer of the Adaptive and Embedded Computing Group, AECG, in AMD, with responsibility for advanced hardware and the software technology development, including future architecture, direction, and the software stacks to enable emerging opportunities in the field of machine learning and high performance computing. Dr. Bolsens also leads the AECG open source program office, and he is responsible for the university program XUP to create a thriving global ecosystem for the AMD technology in academia. Before the acquisition of Xilinx by AMD, Dr. Bolsens was SVP and CTO of Xilinx in charge of research and development and advanced development. Dr. Bolsens joined Xilinx in June 2001 from Inter-University Microelectronics Center, IMEC, an international research center based in Belgium, where he was vice president, design of information and communication system, leading the R&D of digital signal processing system for video applications and wireless communication terminals, as well as the development of compilers for DSP processors and system-on-chip design software. During his tenure at IMEC, he and his team spun out 3 successful startups in the field of SoC design tools and wireless systems. He serves on the advisory board of IMEC, the engineering department of San Jose State University, Santa Clara Universities, and the Department of Electrical Engineering and Computer Sciences at UC Berkeley. He is also a board member of Evo Nexus, a startup technology incubator. Dr. Bolsens holds a master's in electrical engineering and a PhD in applied science from the Catholic University of Leuven in Belgium. Please welcome Dr. Ivo Bolsens.
Thank you very much for this kind introduction, and thank you for inviting me to share my vision on the future of computing. Let me start by sharing my screen. So in the next 20 minutes or so, I would like to take the opportunity to give you some insights on how we in AMD look at the future of computing. And of course, AI plays a very important role in that. So if you look at the requirements for computing, they're driven by several megatrends in the industry. And high performance computing these days is applied in just about every industry you can imagine, from manufacturing and biotechnology, right through nuclear physics and the discovery of gas and oil. And much of this is driven by the availability of an exponentially growing amount of data that is created by the Internet of Things, which means that everything is connected and every device is turning into a kind of a data generation point that can be tracked and that can translate data into insights and learning by applying high performance computing on the data. So high performance computing has gone kind of from a fringe application to really mainstream, and even medium-sized businesses are able today to benefit from the speed and the flexibility and the scalability that comes with the on-demand computing power that has been made available that you could only imagine to have at your disposal a few years ago. And now all of that is, of course, also based on a foundation of technologies such as machine learning. And that, of course, in itself requires a lot of compute and processing a lot of data. But also, secondly, another important trend that we see in the industry is the blockchain technology and the peer-to-peer nature of blockchain technology and its distributed ledgers will also help to move computing closer to where the data is being generated and avoid bottlenecks in round trips between the cloud and the edge. So you create actually a trusted environment that supports distributed computing. Now, if you think, where it all started, it's probably fair to say that the personal computer brought computing to the masses. But then, starting from the PC platform, computing has split into a direction, into the mobility direction and the infrastructure trajectory. And compute has evolved to become ubiquitous and distributed on the one hand at the edge, and on the other hand, concentrated for massive performance on demand in the cloud. And so today's solutions require, in many cases actually, a combination of computing to be made available as a total solution covering both edge computing as well as cloud computing. And actually, edge and cloud computing have definitely different figures of merit. Whereas the cloud computing in the data center is mainly based on transactional computing, where you want the computing to be as fast as possible, and also where you want to create technology that can scale out. In many cases, you want sometimes problems to be dealt with in the computing in the data center with thousands, if not hundreds of thousands of processor nodes. This is very different than the computing as we see it deployed on the edge. Computing on the edge has other figures of merit, such as, for example, real time and determinism. Think about, the car who becomes kind of basically a computer on wheels where real-time and determinism is very important. You want to make sure that when you press your brake, that every time the car reacts exactly at the same way. You also want that your computing is real-time, because in many cases you're working in a constrained environment that if your computing is too fast, it means you're wasting power. If you're too slow, it means that your system doesn't work. And then finally, latency is another figure of merit, that is really an important component that is less relevant when you're dealing with the cloud. Latency means that, when you initiate a certain action, that the consequence of that or the result of that computing is done within a certain time. Now, a good example of an application where you see computing being spread between the edge and the cloud is, for example, in retail, right? In retail, you will have, at the one hand, the endpoint computing devices that are in many cases close to cameras, and that will, for example, allow you to have frictionless checkout of the goods. You have some local data center that takes care of, point of sales, that takes care of inventory management and the likes. And then you have at the background, you have the cloud or the enterprise infrastructure that might run overnight machine learning algorithms to deal with new inventory recognition, new products that are being brought in, and the training for the AI systems that take care of the checking out of the products to make sure you can bring in these new products. So this is a good example of where you see two things. First of all, AI that is becoming pervasive in these applications. And secondly, also the kind of the spread of computing from a really an endpoint in a camera to computing in a data center. Now, it goes without say, if you try to understand where computing is going and what are the requirements of computing, AI is a very important driving force that reflects what needs to be established from a technology perspective to support the demand of future AI applications. And one of the first observations is that when you look at AI has basically been made possible because we have now an abundance of data. And that, in order for these algorithms to be efficient, one of the things you see is that the amount of data and the amount of parameters that these AI algorithms deploy and need to be efficient is growing exponentially. And that implies that a very important aspect for future efficient compute applications is that you have efficient ways on dealing with the data. It means dealing with the storage of the data, dealing with the movement and the transfer of the data between the compute components. And as you can see here, the latest recommender systems, for example, from the hyperscalers, these days have more than a trillion parameters in their algorithms. Just to give you a good idea how that is growing exponentially. Now, besides that, data is an important component of the challenges that we have to deal with in order to continue to handle the requirements of future algorithms in AI. The other important component is, of course, the growing complexity of the compute and the arithmetic itself. So what this chart, for example, shows is that in the last 10 years, if you look at the training algorithms that are being deployed by the hyperscalers for machine learning, the complexity of the compute of these training algorithms doubles every 3.4 months. This has been going on for 10 years, and probably the expectation is it will continue for a while. Now, we all know that what made computing to become so pervasive historically has been the evolution of Moore's law. Now, if you look at Moore's law, we all know that Moore's law is basically stating that the capability of semiconductor devices and compute devices is doubling, every 2 years, plus or minus. So clearly, there is a lack in terms of, the kind of capabilities that Moore's law can provide you, and the kind of evolution that you see in the requirements of AI algorithms, state-of-the-art AI algorithms. So the question now is, okay, are we in trouble now, as we all know that Moore's law is being challenged, is slowing down, and that there are less and less people that can benefit from Moore's law. So the question is, how do we make sure that we can continue to develop the technology to feed into that ever-increasing demand for more efficient memory and storage and data transfer and more efficient compute that in the past we got almost for free, by the improvements of Moore's law. And there I would like to quote basically another law, which is Kurzweil's law, which is also referred to as the law of accelerating return. And what this law says is that actually Moore's law was just an episode, in the evolution of our technology progress, in the sense that technology always makes that IT systems are continuing to show exponential growth in capabilities, because technology feeds itself, and you build on the previous improvement to continue to increase the capabilities. Moore's law was just an episode. The exponential growth of compute capabilities is already dating back from the early 1900s, when basically computers started. And the expectation is that we will continue to see that growth in capabilities of compute systems. However, the technology that will allow us to do that is going to change. We have been very comfortable in relying on Moore's law. Moving forward, there is new technology coming towards us. There is DNA-based computing, neuromorphic computing, quantum computing. There are no clear winners there, but there is no doubt that we will see substantially new technologies that will fuel this evolution of computing. Now, if we look at a little bit more in the near term, what is happening, when we look at the capabilities that today's CPU vendors and compute providers are working on to continue to support that ever-growing demand in more compute. There is, first of all, of course, a lot of people say Moore's law is that. It's not really that. It's slowing down. It's becoming very expensive. So there is still a component of scaling, however, not anymore to the extent that we have been used to, and not anymore giving us the return as we used to see in the past. People are working on new devices, new structures, new kind of transistor-like structures. But what I would like today spend a little bit of time on is some of the two big changes that we see in our industry that is providing the essential device technology, to support the growing demand in the immediate future to improve compute capabilities. And that's heterogeneous integration. You will hear me say the word heterogeneity quite often. Heterogeneous integration and domain-specific compute architectures. So what I mean by that is, first of all, heterogeneity is basically enabling to extend the Moore's law, I would say, which was a law that was relying on 2 dimensions into the 3rd dimension. You see 2 examples here how gradually we moved into that direction. If you look at our EPIC CPU, flagship CPU, you will see that you see different chiplets in there, different dies. Some of them are compute dies. The large die you see there on the left is basically the I/O die, and there are different technologies, they have different capabilities. And that was the first step into kind of building heterogeneous chips. Recently, we announced in AMD, through 3D stacking, where, for example, we dealt with some of the challenges of the data storage and the data transfers, where we integrated basically, 3D stacking cache memory on top of the compute devices. A second important component is domain-specific architectures, where basically what you start seeing is when you look in this specific case, as I said, a car is a computer on wheels. When you look at all the different, compute-intensive functions that are happening in an autonomous car, what you see is that the kind of arithmetic characteristics, things like, the data precision of the arithmetic, the way how the data is being stored and being moved, is very different for the different algorithms that are being deployed in such an autonomous car. And so that leads to basically architectures that have components of programmable compute fabrics that have different characteristics. So you will see that these different functions are being mapped either to more traditional CPUs, to really large, multi-core data flow compute engines, to kind of fine-grained programmable logic engines. And so you see that heterogeneity kind of creeping into the chip architectures that becoming the heart of the compute engines for autonomous cars. Now, this was an example that came out of the embedded space. When you look at the data center, you see the same type of consequences. You see the same type of trends where basically, there are two things that are happening in the data center. First of all, the traditional CPU-based compute nodes are now augmented by heterogeneous accelerators, which are domain-specific. And secondly, what you see is that these different compute capabilities, be it heterogeneous accelerators, or be it traditional CPUs, are disaggregated in a system, where you have basically a collection of CPUs, collection of accelerators, collection of data storage, and depending on the workload, you will assign different parts of your data center to the workload. What's becoming very important in this is the whole networking that is driving the data communication, and it's tailoring the data communication to this. This leads us to a new trend in the data center, which we refer to as the composable data center, where you basically are now being able to allocate resources for specific workloads, resources in terms of traditional CPUs, storage and memory devices, accelerators, and you basically create a dedicated connectivity data transfer fabric to deal with a specific workload and a specific application. This is what we refer to as the composable data center of the future that will allow us to really scale out and create efficient compute. So both in the embedded and edge computing, as well as in the cloud, we see the trend of heterogeneous architectures, and we see the trend of basically customizing the architectures or to specific domains. So computing is basically becoming pervasive and is, has to be high performance at all aspects of the application, going from the endpoint to the edge data center to, at the end, the cloud. And the kind of figures of merit of the compute are different in the endpoint, for example, the efficiency and the power consumption, the resource utilization is very important. On the cloud side, it's more about the scaling out of your compute towards a large amount of compute devices and be very efficient in terms of how you handle the data. Now, all of that has to be made possible by a software environment that, at the one hand, shields the complexity of these heterogeneous and domain-specific architectures towards the domain, shields that complexity from the domain experts. So you see basically a bifurcation of two software flows. One software flow that focuses on the productivity of the domain experts. And that software flow is being created by frameworks such as frameworks for AI, like TensorFlow or PyTorch, or frameworks for people working on image processing or database solutions. But then under the hood of these frameworks, you have specialized backend software tools that basically are being deployed or being used by, I would refer to it as ninja programmers. Ninja programmers, really people that are programming close to the metal, that are really using very efficient compilers for different components of your heterogeneous platform, and that will then provide these capabilities as libraries to the domain experts who are shielded from the complexity of these heterogeneous platforms. So in a nutshell, I hope I gave you a little bit of an insight in where we are going in terms of, first of all, the exponentially growing need of compute and data storage and data transfer, and how we will deliver that by providing heterogeneous architectures that are a composition of high-end CPUs, GPUs, data flow, SIMD machines, and even programmable logic and FPGAs. So with that, I would, I don't know if there is time for questions. Thank you very much for your attention.
Thank you, Dr. Bolsens. A couple of questions that I can see from the audience. I would put that to you, if it's okay with you.
Sure.
Yeah. So first question that is there is, how will the technology scale to keep up with the compute and memory demand for the next decade? And how affordable it will be for mainstream?
Yeah, that's a very, very good question, of course, and that is keeping many people awake, I think. As I said before, I think we will continue to see scaling. Now, scaling will become more and more challenging, especially from a cost perspective. But I think it will remain, at least for the next decade, still a very important tool in the toolbox to improve the capabilities of compute devices. However, it has to be augmented with new capabilities, so new memory technologies, new compute architectures. So the traditional cranking the same architecture and make it available in the next technology node and just expecting that suddenly everything goes twice as fast, those days are over. So that is this is a challenge, I think, for the compute architecture, but it's also a challenge for the software, because the software and the compilation technology now becomes much more complicated, because you will have to deal with very specialized architectures, and you have to be able to kind of hide, the details of these architectures for the software people. They are not necessarily expert in all these domain-specific architectures. So there is definitely a big challenge from a software perspective to unleash that full potential of these new architectures to the software people.
Thank you, Dr. Bolsens. So we would end this talk At this time, I want to thank you again for this visionary talk, and I'm sure attendees got inspired by the future of computing that you have shown to them. Thank you very much, sir, and you have a great evening.
Thank you so much. Thank you.
It is also the time for our next session. The next session is a panel discussion on the future of AI semiconductors. AI has now become a common phrase in the semiconductor industry and is no longer just a buzzword. Let us see what panelists have in store for us. We have an excellent panel with experts from industry and academia. This panel discussion will be moderated by Mr. Prabhat Sahu, VP and General Manager, Intel. Mr. Sahu is Vice President of the Network and Edge Group and General Manager of the IoT Engineering Group at Intel Corporation. He leads the worldwide engineering team responsible for product design and development across IoT, Intelligent Edge, AI, client and networking product. Industry veteran with more than 30 years of experience in the field of semiconductors, including 16 years in USA. Prabhat experienced multiple technology revolution and delivered 70 plus groundbreaking innovative products and technology worth more than $100 billion. Prior to rejoining Intel in 2016, Prabhat held leadership roles at Qualcomm, Sun Microsystems, Rocket Networks acquired by Cisco. At Qualcomm, as a vice president, Prabhat led the India Design Center with his strong presence in industry and academia. Prabhat is a well-recognized speaker at prestigious engineering conferences and associated with multiple technology enabling initiatives in India and worldwide. Prabhat is a passionate advocate of diversity and inclusion, and his team at Intel was conferred with Global Diversity, Inclusion, and Social Impact Achievement Award in 2021. Congratulations, sir. Please welcome Mr. Prabhat Sahu to lead this panel discussion. Mr. Prabhat Sahu.
Thank you, Kamal. Very kind of you. Good morning, good afternoon, good evening, everyone, depending on where you are right now in the world. And hope all of you are doing well. Artificial intelligence and semiconductors are probably the two most talked about agenda as we speak. And we are going to discuss really how to bring these two things together in this panel. And I really have five very, very illustrious panelists to share their perspectives. Just want to give a little background on this subject, why this is important. So the world, as we know, is moving to a complete and comprehensive, smart and connected world, unleashing a wide range of applications that touch and have a positive impact to every human being on the earth. We are all moving to a world where humans and machines will coexist, where there is high focus on productivity and automation, and where quality of service is critical, and where security and privacy are absolutely essential. Two key technologies, artificial intelligence and communication, 5G and beyond, are the pillars of this new world, based on the foundation of a robust cloud edge device continuum. As per ABI research, this AI and 5G are expected to enable a $17 trillion economy by 2035. And this whole system will necessitate a strong interplay of semiconductors, platforms, software and systems and technology. And they will funnel a whole world of applications like automotive, industry 4.0, robotics, telesurgery, financial systems, metaverse, etc., etc. Now, semiconductors are the critical foundation on which this revolution will embark upon. The global semiconductor market is expected to grow from $500 billion US to $1 trillion US by 2030. And the AI semiconductors are expected to grow the fastest. As per McKinsey, AI semiconductors are expected to grow at a CAGR of 18% over the next few years, outpacing the non-AI related growth by 5 times. While there is significant growth, significant opportunities and challenges remain for the future. Currently, there are many ways of serving these AI needs. You have CPUs, GPUs, ASICs, from simple to massively complex, FPGAs, etc. And there are debates ongoing about the future. The best neural network computer is hardly 1% of the human brain currently. We are basically at the infancy of this great revolution. We are pushing the technology envelope as never before. One of the chips from Cerebras, or one of the systems of Cerebras, has 1.2 trillion transistors through the wafer scale integration. The demand for compute power for AI is doubling every 3 months. So this is quite challenging and complex. And the semiconductor agenda need to look at 4 key aspects: compute, storage, memory, and networking to propel these revolutions. We are looking at how to effectively program and use these semiconductors and marry them to the rich world of applications. Also, to address this, there are new technology emerging: neuromorphism, silicon photonics, quantum computing, etc. Some of them show early promise of having a leap over traditional semiconductor designs. So, we have a very interesting and complex problem, as well as opportunities at hand to shape up AI semiconductors in the future. To discuss and debate about this, I have 5 very distinguished panelists today to share their thoughts and perspectives. It's my pleasure to welcome and introduce the panelists. First of all, I would like to welcome and introduce Subhashish Mitra. Subhashish Mitra is Professor of Electrical Engineering and of Computer Science at Stanford University. He directs the Stanford Robust Systems Group, leads the computation-focused area of the Stanford System X Alliance, and is a member of the WuSci Neuroscience Institute. His research ranges across robust computing, nanosystems, electronic design, automation, neurosciences. Professor Mitra's honors include the Harry H. Good Memorial Award, Newton Technical Impact Award in EDA, the University Researcher Award, the Intel Achievement Award, which is Intel's highest honor, and the US Presidential Early Career Award. He and his students have published over 10 award-winning papers across 5 topic areas in technology, circuits, EDA, test, verification at major venues. Welcome, Professor Mitra. The next illustrious panelist I would like to welcome is Dr. S.K. Nandi. Dr. S.K. Nandi is a professor of computational and data sciences at the Indian Institute of Science at Bangalore. He is the co-founder of a fabless semiconductor company, Morphing Machines Private Limited, set up in partnership with Indian Institute of Sciences. Over the years, he has graduated 24 PhDs, 22 MSc Engineering, and over 100 master students who have worked their theses in the laboratory. His current research addresses important issues in microarchitecture and compiler optimizations for power and performance in many core processors and runtime reconfigurable SoCs. Professor Nandi has over 175 research publications in international journals and proceedings of international conferences that highlight his research contributions. Welcome, Dr. Nandi. Next, I would like to welcome Sundar Ramlingam. Sundar Ramlingam is Global Director, AI Consulting Partners at NVIDIA. He has a strong technical background, and his areas of interest include deep learning, big data analytics, IoT, and automotive solutions. In his current role, Sundar leads a team that works closely with global system integrators to build AI-based joint solutions and platforms. His role involves working with these organizations and ensuring that they build an all-inclusive AI ecosystem to enhance the business in the artificial intelligence, big data, and IoT space. He has more than 20 years of experience in solutions involving visual computing, AI, and high-performance computing. Welcome, Sundar. Next, I would like to introduce and welcome Kaushik Raghavan. Kaushik is the Director of AI, ML, and Data Sciences, driving the AI roadmap for technology development, advanced packaging, volatile and non-volatile memory nodes at Micron Technologies operations in India. He has successfully delivered AI solutions across the semiconductor business spectrum, both within the startup and enterprise ecosystems. His areas of expertise include composite metrology, recommender systems, predictive and prescriptive modeling, SPC, stochastic modeling, and computational optimization, leading to 75 plus innovations, including patents and publications. Welcome, Kaushik. Last but not the least, I would like to welcome Michael Shebanov. Michael is CTO at Alpha ICs. He has been holding leadership positions at Cadence, Tensilica, Samsung Research America, Tesla, and NVIDIA, driving multitude of research and development efforts on configurable CPUs, next-gen GPUs, and processor series across multiple architecture families. While a graduate student at UC Berkeley, he was one of the original developers of HPS, the superscalar dynamically scheduled processor architectures. He holds 47 patents in graphics, processor design, and disk controller areas. Welcome, Michael. It's great to have all of you in the panel, and let's look for a very vibrant and energetic panel discussion, really how to bring this AI and semiconductors together. Will be great to hear all of your perspectives. So first of all, I will ask each of the panelists, starting with Professor Mitra. You heard about, how the AI semiconductors, they are shaping up the world. So in your perspective, what challenges and opportunities do you see in shaping of the future of AI semiconductors? And any ideas you can share with us where we should be investing to make this a very promising agenda? Let's start with Professor Mitra.
Okay. Thank you very much, first of all, Sambit, for your kind introduction, and thanks to the organizers for inviting me on this panel. Boy, that's a deep question, and I think we could use up the whole hour talking about that, but I'll try to keep it short. So, I consider AI or machine learning in general as belonging to the class of what I call abundant data applications, processing a lot of data, for useful purposes. And while, there is an insatiable need for that kind of computation, what's really happening is that progress in kind of underlying hardware technologies is stalling right at this moment when the world needs more and more compute. And why are the underlying hardware technologies stalling? We already have what we call the memory wall. Up to 90% of the energy and execution time could be spent trying to access shuttling data back and forth between the compute chip and the memory chip. And moving forward in the next 10 years, we are going to see what I call the miniaturization wall. We are already at, depending on who you talk to, 3 nanometer technology node or something like that. And, how far are we going to go? Maybe, 0.5 nanometer technology node, which is coming in, in the next 10 years. So the real question is, how do we achieve, for example, 1000x improvement in compute performance in spite of all these major walls that we are facing, because that's what is needed to satisfy the world's needs for compute. And I can get into details, but I will kind of pause over here and let others speak. That's what we need to think, that what should be the technologies. And when I mean technologies, I just do not mean that it would be just the basic transistor technologies and device technologies, but we have to think holistically end to end. And I kind of talk about 3 things, like very dense 3-dimensional integration, and then you can think of this mosaic of these 3D chiplets that are put together on interposer or something like that. And then the third aspect of that is co-design that connects the underlying technologies all the way to the applications and the algorithms. And I think this would be the key components, but we can get into details later.
Excellent, Professor Mitra. I completely agree with you that the memory wall and the miniaturization wall, which, as you put it appropriately, are really two big walls. And I also agree with you that disaggregation, chiplet, 3D strategy, and hardware software co-optimization, all these are great points to invest into. Excellent. I'll go to Professor Nandi. Professor Nandi, you want to share your perspectives?
Thank you, Sambit, for this invite, and it's a pleasure to be with all esteemed members here. And I would very much, to start with, agree with Professor Mitra. He said it all, and what I would add is just dwell on certain specific aspects of this in this domain. So, as Professor Mitra already said, AI is getting pervasive and is increasingly penetrating almost every aspect of our life. And in this age of digital transformation, every gadget is AI enabled, which empowers the user with the right information at the right time in the domain of his or her interests. The point to note is that at the core of such gadgets is a system on chip catering to heterogeneous workloads, including AI workloads, okay? And in a connected world, the challenges and the opportunities with regard to such SoCs are manifold. Just to highlight a few, AI-enabled SoCs will demand high performance at low power, and of course, it will have to address the issues coming out of memory wall and the miniaturization wall. AI compute, as in IoTs, AR, VR, Industry 4.0, and automotives, they are predominantly reactive, and they need to meet both low latency and high throughput requirements, which ideally would require domain-specific architectures within the SoC. So the opportunity is more, in my opinion, in terms of architecting domain-specific architectures on demand, on silicon, that incorporates these combination of new technologies. To me, the need is that of post-silicon realization of domain-specific architectures on a SoC, or to put it simply, it is going to be more of runtime reconfigurable processing on the future SoCs. So, in brief, what I had to say.
No, very nice. I really see that the things that you talked about, the heterogeneous workloads, that is reality. I mean, if AI and 5G are coming together, that means you have to support both those type of critical workloads along with the other workloads. And domain-specific architectures are definitely springing up. And I think, Mike, you have worked in startups as well as AI companies. And so what's your perspective, Mike?
Yeah, thank you. First off, thanks for the introduction, and thank you for the panelists to allow me to join in talking with all of you. I think, I'll focus on more, maybe on the lower end. I'm really excited about our feature blended technologies. There's a lot of applications, I think, coming up in the robotics, manufacturing, transportation, agriculture, and actually engineering, like in mechanical engineering, generative design. Doing something which, I think that AI at the edge has the potential to, revolutionize a lot of things outside electronics. I think they can probably do things a lot beyond what people can do. I think we have a lot of challenges that come with that. I think probably the biggest one is all these new applications require new software, and software is now a moving target. And I think trying to find the right computer architecture to fit a moving target is really difficult. General, purpose computers are shown to be best at adapting to changing software demand, but they also have a lot lower efficiency. I think we see in the industry right now a lot of, angst or uncertainty as to whether, what's the right mix of general purpose versus fixed function. I think, as you said, actually, the other thing would be, a huge challenge on the semiconductor manufacturing industry. If we do see this explosion in different application areas, there'll be this demand, huge demand for new chips, and can we satisfy that demand? So my perspective.
Very good, Mike. I think that's one of the key problems you mentioned is this software is moving so fast, and architectures and design take time. So how do the architectures and designs cope up with the changing software is definitely a critical problem to solve. I would go to Sundar. Sundar, do you want to share your perspective with so much of experience that you have in the AI space and application space?
Absolutely, yes. First of all, thanks, Sambit, for that very nice introduction, and thank you, organizers, for having me here. It's a pleasure and honor to be here in this esteemed panel. So, AI computing is a very, very unique field, as we all know. And back to the basics, what is the most complex thing that needs to be done when it comes to AI computing? There are two things here. Number one, the enormity of the data that needs to be handled, and the complexity of the models. The dimensionality of the models keep on increasing. The number of hyperparameters to be tuned, we were talking about tens of thousands, then it comes, then became millions, and now we're talking about when it comes to NLP and ASR, it comes to billions. And I'm sure it will only keep on growing. So basically, the complexity of the models that need to be handled and the enormity of the data. In order to do this, there are two major players. I mean, once again, very basic thing. One is the hardware and another is the software. For this question, I'll restrict my answer only to the hardware aspect of it. If we are able to build a chip that can do that can provide an engine that does the accelerated computing in a very elegant way. I mean, typically the GPUs, which sits next to a CPU, which takes off the load from the GPU and does all the background processes without too much of back and forth communication happening between the CPU and the GPU, or rather without much of latency that happens between them. And very importantly, a networking component that also works in unison with the CPU and the GPU, that is able to offload several of the aspects that the CPU does today. For example, ensuring the security of the data that comes in, ensuring that the right distribution of load happens, things like this. So networking plus a parallel computing engine, which is the GPU typically, and the CPU, which is very essential and which is the backbone of any computing environment. If all of them can sit together in one die and they are able to do their respective work that they are supposed to do, that is really going to catapult the way computation has been working and it's going to work. So I feel that purely from a semicon perspective, the happy marriage between these three components is what we are going to see in the future. Obviously, there is a lot of software involved in this. These things don't work without the right frameworks in place, which possibly I'll touch upon when I pose the next question. Thank you.
No, excellent, Kosik. I think that's what the world is moving to meet the world of applications. We need the CPU, we need the GPU, we need networking, we need other kind of accelerators. So how do you orchestrate and how do you offload and seamlessly and again bring them back together is the key thing. And very nice, Sundar. Kaushik, your perspectives, please, with so much of background and experience with Micron. It'd be great to hear your perspective.
Yeah, thank you very much for the opportunity, and it's indeed it's a pleasure and a memorable moment to cross shoulders to be on the virtual days, some of the best accomplished leaders in this field. So I really thank the opportunity. To be able to speak up in this eminent August audience itself is tough, and to go last is it's completely tough because most of the points have always been beaten out. But the fashion for the hour or the trend for the hour is to have a sequel which talks about how it led to this, right? The prequel has become the sequel in any movies that we talk about, Bahubali 1 and Bahubali 2 and Pushpa the Rise and Pushpa the Beginning, right? So we may need to take a step back. As Sambit rightly started, 18% value proposition through digitization. We are talking about an organization which could be a $10 billion organization to 12 billion, already talking about $2 billion value proposition. And that in itself can be more revenue generating than most of the Fortune 1000 companies, right? So in this world, we are actually in a data-driven economy, right? And if data is the new oil, memory is the monetization strategy. And if we reflect back on how it all started, when the need for to get into collect more data, there was a data tsunami that came in by expulsion of more sensors coming in, and we started collecting more data. And the OEM, I'm talking about manufacturing aspect of it, right? OEM started generating more and more sensors, and the rate at which the sensors started really exploding from 1 hertz to almost 1000 hertz. And then came in the IoT sensors. Today, IoT sensors are generating anything between 8K to 20K hertz of data that's coming up from the asset, and asset monitoring and unscheduled downtime. All these are perennial, what we call as occupational hazards part of it. But the biggest crux of it, right? If you look at the equipment, the electronics and semiconductor, the flavor of our AI summit itself comes on 5 cores: AI for semiconductors, and we talk about digital transformation, healthcare, and autonomous driving, and the EDA and systems and design. So for these 5 vertical solid pillars that constitutes the electronics and semiconductor ecosystem, the bottom line is memory. To enable what we call, the memory actually became the enable for data ingestion and data collection strategy. So what happened? We started packing more transistors, and at some point in time, we ran out of area. We started building Manhattans. We went to like from 36 layer to 64 layer to 176 layer, and now the memory which became the enabler has become the memory which is the bottleneck. So now there is an inherent need to be able to access even the last binary transistor, and to be able to get that faster, because we can't really wait for anything in future. For example, back in the days, we used to plan for a cab booking 3 days in advance, and we exactly know these are the specific times. Today, if someone is going that 7 minutes later, it's going to arrive, we don't want to wait for it. And that is the future order. How do we achieve that? In this entire ecosystem, as Sundar rightly said, the compute and the memory and the data, and can we have the software, hardware, and the firmware to be able to have the right happy marriage, then we could actually take it to the next level. So now memory, who is the bottleneck, can become the memory, the solution. And that can be achieved through proper collaboration and proper at every manufacturing level. So if you look at the abstract space, we have ASIC and the NAND in one end of the spectrum, and we have the DRAM on the other end of the spectrum. And the in-compute memory, or we call as a future as the near-term memory. How do we build the cold memory and the hot memory in the right combination to be able to have faster, cheaper, and also cost economical access? And most importantly, it should be near real time.
No, very, very good, Kosik. Actually, we are. I wish we saw the trailer of the movie that we talked about. Unfortunately, we could not see the trailer, but the movie we are watching is a great movie. So, and I completely agree with you that really memory is critical, and Professor Mitra also alluded to that memory bottleneck. So hopefully, you, Micron, and the rest of memory companies are doing active research. You mentioned in-memory compute and near compute memory, HBM memory, all these different type of memory technologies to really see how we resolve the memory bottleneck. So great points on the memory bottleneck, miniaturization bottleneck, offloading accelerators, software playing a big role, heterogeneous workloads, domain-specific architectures. Really great opportunities, challenges, both need to be addressed. But what I feel is that the way we are going will go somewhere, but I'm not sure whether it will solve the entire problem, because today the best neural computer is only 1% human brain, and the world cannot wait till our neural computers match the human brain or more. So we have to really move at a great pace. So that means we have to look beyond traditional silicon design. And while we will solve these opportunity challenges that come up, but we have to think above and beyond. So that takes me to my next question. Is there are lots of new technology, new nanotechnologies, brain-inspired computing models, silicon photonics, etc., which are showing some early promise of going or enabling us going beyond the traditional semiconductor design. I'll ask first this question to Professor Mitra and then Professor Nandi. Do you think any or many of them will take off and have a significant leap over traditional semiconductor designs for AI? If so, when do you think it will happen and how will it happen? Professor Mitra, I want to start with you.
Okay, the when and the how, if I knew the exact answers to that, then I would not be here, right? So, but let's kind of start with the big picture. So yeah, there are individual approaches, for example, that are showing promise, as you said, and we don't have to go through the laundry list. But I think one really important aspect that's often missing in this field is what I call the multiplicative benefits. So ultimately, when you want a really large benefit, and you need to make sure that all these individual advances that are happening at these various layers of the stack, if I might call, they actually multiply out. So for example, if you think of new transistor technologies or new memory technologies, right? If you think of new integration technologies and couple them with, advances, for example, in domain-specific accelerators or even algorithms, you need to make sure that those things actually are working, hand in hand with each other. And this is kind of what I meant by co-design. And only that can give you multiplicative benefits. I'll just pick one example just as a case in point, right? And this is a chip that we built. This appeared in VLSI last year, last June. What we wanted to do is we wanted to build a non-volatile compute at the edge for edge AI, as many of our distinguished panelists talked about. And yeah, it was a domain-specific accelerator. But we said that in addition to inference that most people talk about, we would do training at the edge. And even if you consider incremental training at the edge, which is like you got a 5-year-old in that neural net that had its weights kind of trained offline, and then the 5-year-old is now learning. So the weights are getting tuned. If you used a stochastic gradient descent, which is our conventional training algorithm, try to use that on a non-volatile memory at the edge, you will run out of battery and you would have your lifetime less than 1 year, right? So what did we have to do? We actually had to innovate a new kind of an algorithm for training, which is called low-rank training, that would preserve the accuracy of conventional training, but at the same time, it would drastically reduce the number of writes into the memory. And in actual hardware, we were able to demonstrate 300x better energy delay product compared to traditional stochastic gradient descent running for 10 years at 20 samples per minute. So this is an example of what I call multiplicative benefits. Similarly, we talked about 3D integration, and Kaushik talked about, for example, going 3D NAND, I have a lot of respect for those kinds of innovations, but that's 3D NAND is an example of building a skyscraper that has 100 floors, but only one elevator, right? What you actually need to really address the memory wall that I was talking about, if you want 100 floors, you need probably 1 million elevators. So the elevators go back and forth between compute and memory very quickly, right? And doesn't really matter how much 3D integration you do. Somebody talked about how the algorithms are changing. So it's like you're always chasing, which means that if you give somebody a lot of compute and a lot of memory, they will actually come up with a model that needs even more compute and more memory. So that means that now you have to think about how you put many of these 3D chips together to give the illusion that as if you have a single chip with a lot, like where memory is easily accessible at a very quickly. So these are the things that we have to think about. But one really important point I want to make, because probably this will be lost in the whole discussion, is that we are talking about domain-specific accelerators and so on and so forth. But if you think of our design methodologies, it takes 2 years to build a chip today, right? With like too many people. So the question really is, how do we really improve design productivity by at least 10x? And to do that, we have to revolutionize design verification because that can be 80% of design productivity. So we cannot forget that point as well. And it's not just our technologies. I'll shut up here, let Professor Nandi speak, and we might come back to some of these points.
Sure, great points. Professor Nandi, please go ahead.
Yes, Professor Mitra, I cannot agree more with you. And I would rather move to a different direction in the sense that, given that there are a host of new technologies that are going to come around in the coming time, that are in the horizon, and they'll soon become a reality, the issue is perhaps that these sort of semiconductor designs with these new technologies for AI needs to be system aware, meaning what is that ultimate system they are getting into. So AI workload will become a component in the whole system. When I say AI workload, I mean the hardware and the software combined. And they will have to meet requirements of latency, throughput, and power, which could be very stringent, especially in emerging applications in the domain of Industry 4.0, ADAS in automotives, integrated modular avionics, and stuff like that. So such systems need to have very close interplay between software and hardware, which Professor Mitra already alluded to as co-design. So a lot of effort needs to be steered towards development of the software stack for the system, including incorporating new algorithms and new AI models. Again, the key here to me is going to be domain-specific architectures in a software-defined chip. So it is a software-defined chip architecture that is going to drive the next generation of processes. And it is this software-defined chip which should take advantage of the new technologies. In fact, I see chiplet-based design as one of the upcoming technologies to look at.
Very good, Professor Nandi and Professor Mitra. I definitely see that algorithms and taking a system perspective are definitely critical elements. A lot of the, as you both mentioned, a lot of the pre-processing can happen in software compilers or other software things, and the chiplet strategy is definitely. And I think Professor Mitra, as you said, the EDA, absolutely. If you have to keep up with the AI demand, we need to build our chips faster. So this is an action for all the EDA companies to really see how they can come up with 10x or 100x more productive tools. So great points. But I do feel also that, and I know many of us and many of you are also doing research in the topic in all these biologically inspired neurons or silicon photonics, to biologically inspired neurons, because traditional mathematical way of is pretty complex and pretty huge runtime. So to look at how we mimic the brain, the way it operates, and the silicon photonics hopefully can enable to some extent the memory compute interchange if possible. So I know a lot of research going on. We are in very early stages. So all good points, but we need to definitely keep continuing doing this active research in all areas: software, silicon, EDA, as well as fundamental research. Now, since there have been a lot of focus on software and how software can and software and hardware need to work together and be co-optimized. And so my next question is, I see this whole world of application growing, and we discussed that in the panel also. And then the semiconductor designs are happening and they're also growing. To get the best out of it, we need to see really how do we marry these semiconductors effectively and also interoperably to the world of applications that are growing so significantly. Any thoughts about it? I'll go to Mike and then Sundar. Mike, any thoughts? Really, applications and semiconductors, how do you marry so that you get the best out of the whole thing?
think I'm honestly, I'm not quite sure I know. I think, as I mentioned before, I think that, the probable exposure into fields outside electronics is probably inevitable. I think trying to develop AI architectures that span that breadth, and the pressure that we have on, cost, performance, power, is a really huge challenge. I think deployment's a challenge. I think a lot of customers outside of electronics kind of expect an appliance sort of delivery model. I think semiconductor guys, we keep thinking chips, right? But chips, most people don't want to buy chips. They want to buy boxes that have chips. So how you build those are kind of interesting. I think another area, you say marrying, software tools for non-data scientists and non-programmers. I think, we'll talk about it later, but it's very difficult to scale expertise in this area, right? You can't have a small group of people trying to support the rest of the world. We have to figure out a way to make it easier to use. A possible direction I've seen, like, again, I'll focus on tiny ML, which is almost like a hobbyist perspective on it, right? Where people they're not really experts, but they know how to get things done, small, cheap appliance like things with, turnkey software. That may be a way of dealing with it. And I think that's kind of the biggest marriage problem. I don't really see it as a chip delivery problem. I see it as a software problem still.
I see. Great. Sundar, do you want to add anything?
Absolutely, yes. Thanks, Samit, again. So several of the functionalities that are mostly driven by software today, if the semicon can incorporate that at the hardware level, the combination is going to help a lot. I'll cite some specific examples. See, functionalities like quantization, the ability to mix precisions. Say, for example, can I mix FP16 and FP32? And for that matter, even integer 8, for me to accelerate the process, obviously, without compromising too much on the accuracy. That's always there. It's not that nobody is going to accept if the accuracy falls down by 10% and I run it faster. No, nobody is going to accept that. So, thanks to the enormous academic work that is being done by several institutions, we have 2 esteemed professors here. These are areas where multiple things that are being driven by software is also getting adopted at the hardware level. One more example which I could cite is video encoding and decoding. Video encoding and decoding. Can the hardware enable that, and can the hardware help the software in doing it much faster and much more efficiently than what is being today? That's going to open up a lot of things, and it is happening today. It's not that something that I'm talking which is purely futuristic. It is happening today, but there is a scope for making it even better. Accelerating sparse matrices, right? We are all talking about huge matrices, multi-dimensional matrices, tensors and all. And the biggest problem, or the biggest pull down is how do I accelerate, how do I identify sparse matrices and accelerate that? It is all done by software. It was done by software until recently, but hardware is catching up today. How do I accelerate sparse matrices? There are hardware functionalities that are helping to do that. So to sum up, things like quantization, mixing of precisions, sparsity acceleration, video encoding, decoding, etc., which can hardware aid the software, and can software aid the architecture of the hardware. That is something which is coming up in a big way. And the end result would be to build an elastic ecosystem, an elastic compute ecosystem, where all these things coexist: a CPU, a GPU, and any other compute environment, any other environment, which are able to coexist, and one software layer that sort of permeates across this complete compute ecosystem, and be able to serve multiple use cases as microservices to very large number of users, tens of thousands of users, hundreds of thousands of users simultaneously, is the need of the day. And these things are coming up in a big way. And I feel that it's going to be even better in the days to come.
Thank you, Sundar, and thank you, Mike. Really great. I think what I am capturing is, I think things that we are doing today in software, as we learn things in software, we need to start putting them into hardware to get that better performance, better efficiency, lower power. That's great. And also what we are doing in hardware, we need to enable our kind of programmable hardware so that new software can use the hardware more effectively. And the third piece, which you both mentioned, is that we can't look at these things in silo, silicon separate, software separate. We need a set of experts, which is probably rare today, who can marry the two, who understand a certain amount of silicon design or product architecture and the software, and marry the two. And that's the talent we need to develop. Great insights. And now next question I have, we talked about it, that the AI semiconductors are really pushing the frontiers of technology, in all aspects, whether it's the number of transistors, power, performance, storage capacity, latency. I mean, I've never seen any other silicon really push the envelope so much. So the next question I have for Professor Mitra and then Kaushik. How do you think this technology, or the technology walls that we see, will be able to cope up and still deliver to these demands? Professor Mitra, we'll start with you.
So I always joke about this thing. So if you get a room full of people that are experts in technologies, semiconductor technologies, and you ask them what would be the best technology or set of technologies to accomplish something, AI compute in this case, there would be a lot of debate, and there would be only one answer where everybody would agree on, which is my technology. Okay, but of course we're not going to do that over here, right? So I won't get into any specific technology choices and things like that. Of course, I have my favorites, right? But instead, I would like to pitch this thing, and I think this is an important aspect. 60 years back, Kilby, did the integrated circuit, and and the world changed. I think 60 years later today, I think there is another such great opportunity, for something like that. And what did Kilby really do? And what he did was that he brought the stuff that was outside, like to inside, in some sense, which is like individual transistors, capacitors and things like that. And there was criticism about all that. You can read his Nobel lecture. So I think today there is this is the right timing for another opportunity, which I also call a new IC. And in this new IC is not about an integrated circuit, but what I call is an interconnectivity continuum. So, as technologists, we often talk about transistor technologies, or, transistor density, performance, and so on and so forth in silos. Similarly for memories. But we rarely talk about the interconnectivity between these various components. And the scales of interconnectivity has to be spanning a continuous line. It's not like, on chip and off chip, which is kind of the state of the art today. So we have to think about, obviously, a dense interconnectivity on chip, inside a chip. But we also have to think about, how these various components would connect with each other, along the scales of connectivity. And that must match the software and the algorithmic demands. In the previous discussion, we were talking about how the hardware architecture and the software has to match. I would go one level further and say how the algorithms have to match this, this interconnectivity continuum that I'm talking about. It's just beyond software. It's the algorithms. Versus, I know that there is a later discussion about, teaching. But if you think of how we teach algorithms today, we still talk about time complexity of algorithms versus, these aspects of technology and their interactions algorithms will be drastically different moving forward. I will keep it at this high level unless people have questions, and I would let Kaushik, maybe get into more details.
Absolutely, Professor Mitra. And before I get there, you spoke beautifully about the power of algorithm, right? Reconnecting back to our earlier example of, building the 3D NAND, 3D structure, 100 story where we pack everyone in every story, and then, there is only one elevator. Algorithm today can change the face, the way in which each and every transistor behave. Even if they are at the 100th level, they can behave as though, they are at level 1. Everybody is at level 1. That's the power of algorithm. We need a strong pre-silicon AI algorithm to be able to accelerate the whole 9 yards to bring it to the post-silicon SoC, right? So let's take a step, little step back, right? 2 decades back, when I started my career, people were talking about 90 nanometer technology, and I couldn't even comprehend. I've seen about half a micron I can comprehend visually. Beyond that, I can't. And half the periodic table got already eliminated, by it can't sustain the speed and the compute complexity of that technology node. And then they said, oh, next one is going to be, maybe we should try 65 nanometer technology. At that point in time, I thought I may have job for the next 3-4 years. That would get me, enough, bandwidth, because I love mathematics. So I thought I'll just get enough bandwidth before I could actually start learning some more computation and software and do a transition from algorithm to software. But here we are. Today we are talking about a consistent 7 nanometer technology and looking at a future 3 and possibly a 0.5 nanometer technology. This was made possible not just by the 50 people in the group, but rather 500,000 people over the last 5 decades who have always come together and rolled up and come back and solve the problem for in terms of capacitor packing, yield, and looking at every density, bandwidth, cost, size, scale, latency. So these are all old dimensions, and they still continue to play a role. But there is a new dimension, the new order of the world, which has literally taken the critical priority among all of them, the power consumption, right? This I'm sure, all the PhDs and we were able to come back and solve it for the next technology node, but at what cost, at what level? What are we going to do about sustenance, and what are we going to know about our future nodes, which is our next generation and the third generation? Can we achieve everything at a much lower consumption? When I say power consumption, there are 2 aspects to it, right? At a micro level and a macro level. Micro level, we are looking at 1 billion edges, and probably, as Sambit talked about, it could be 1 trillion edges in future, which needs to consume less power and an extended battery life than the million edges that remained 2 generations before. At a macro level, the AI workloads will tax the data centers to the point that the electricity demand will actually account for 10% of the global power demand. Okay, this is done by the research study published by Applied Materials. So even at MIT, there was a research where they looked at certain deep level algorithm, and that algorithm and the computation took the power consumption for that algorithm and the number of carbon dioxide that could have generated was actually comparable to the lifetime carbon dioxide emission of 5 cars. Of course, that could be a US car. If I look at my BMC and PTC cars or the trucks in India, it could be much higher. See, at this most important thing, if we place our consumption and sustainability around and try to look for other aspects of the pre-silicon AI digitization and algorithm advancement, then we will have a much better integration in compute memory. And this today is definitely a significant opportunity. So the memory that became the enabler and memory later became the bottleneck has now in the right driving seat to become the solution for this future. It could be near-term memory, it could be high bandwidth, in-compute memory, it could be the advanced packaging that we talked about, the emerging memory, it could be the HRAM, or it could be a perfect union of all these put together, right?
Very good. Yeah, great, Kaushik. Professor Mitra, I learned a new concept. I'm going to think about it. Is that don't think about connectivity, interconnectivity within a chip or die to die. Think connectivity between chip, die to die, software, algorithms. So maybe there is an interconnected continuum that we need to all think and shape up. And Kaushik brought up great points. While we're thinking about this connectivity, let's solve the problems of power and sustainability, which is going to hit us very, very, very bad if we don't take care of it now. Great thoughts, great insights, a lot to think about. Now, probably my last question, I'm running out of time. In the past revolutions I've seen, the PC revolution, smartphone revolution, or data center revolution, many players have come together. And, initially there was a lot of noise and chaos, but they started coming together and shaping up the revolution, which has done pretty well, actually, I would say. And now this AI revolution, AI, if you combine with 5G and edge and cloud to edge to device, it's by far the biggest and the most complex revolution. And the whole world needs to come together. So the next question I have for Mike and Sundar. So which players need to come together and how will they interplay to step up this revolution? And how will these operate in this cloud edge device continuum? Mike, let me start with you.
Okay. Yeah, I'll have to again beg ignorance. I'm not dead sure of the top part of it. I view the stack. I think, we're talking about algorithms here, and I agree with that. My training as a computer architect, you started algorithms, and it has a much bigger effect on the overall performance of the system, and certainly down to the transistor level. But anyways, I think, what I've seen in computers, the whole industry is approach. Generally, we start off with general purpose computers, and we eventually migrate toward fixed function engines over time. I think Sundar mentioned like video codecs, right? I think when video codecs were started, we used general purpose computers for that, but nobody in their right mind now would use a general purpose computer to do a video codec, right? It's all fixed function, and it's driven by cost power trade-offs, right? I think in designing GPUs, internally when we architected them, we kind of had this rule of thumb that, fixed function was typically 10 to 100 times more efficient than programmable logic in doing its job. But the problem with fixed function is that the minute you move outside of what it can do, you're dead. So I think, who are the players? I'm at the risk of being a broken record. There'll be lots of different people coming with different applications they want to get done. The market's going to be solving that with general purpose computers. Are GPUs the right general purpose computer? I don't know. I haven't designed them. I think if you compare, the computers that we're on right now that we're talking on, the CPUs are very sophisticated. And the software stack above it is very sophisticated, multi-threading and all that. The AI engines that I'm familiar with talking to people can't do that, right? I've talked with a bunch of different customers, and, some of them are just screaming, saying, I'm not going to run one network at a time. I'm going to run lots of networks, different networks at the same time. And none of these engines really are good at dealing with that problem. So I think that the parties that are going to get together is going to be the whole stack, right? From algorithm people down, through operating system applications, operating system, software development systems, the traditional architects like me, chip developers and so forth, down to manufacturers. I think all those people have to get together. Where it will actually go, I have no idea. So.
Great points, Mike. Any thoughts, Sundar?
Yes, Sambit. So if I may take the liberty to change the word from player to technologies, which technology should I'm sure that is what was meant. Sambit, like I said earlier, it's important that few things which are working in silos, which don't talk to one another, namely the main processor, the GPUs, which take up all the AI computing workloads, and the CPU that has the very important backend work like orchestration and memory management and OS level management and things like that. And very importantly, high performance storage and networking, they go together hand in hand. Because however powerful the compute engine is, unless the data is fed at the right time, it's not going to help, and vice versa is also true. So the ability of these technologies, namely the main computing, the accelerated computing through GPUs, and very high performance networking, and the ability for very high performance storage, which is able to pump the data at the right time without much latencies, is something which needs to come together. And it is happening. It's not that I'm not trying to say here that these things are not there today, but I feel that there will be a lot of convergence of these technologies in the future, not only from a semicon perspective, but also from a software perspective. Now, looking at it from a different lens, the ability of the computing frameworks to identify these things and be able to support such convergence is also very important, because the framework should be able to do that. I mean, otherwise, your models are not going to fit in the right way. Your data is not going to be read in the right way if the computing frameworks, the software frameworks don't support that. And very importantly, the ability to orchestrate this and be able to balance the load from an orchestration and load balancing perspective, which sort of encompasses all these technologies and creating one common compute elastic ecosystem. That's very, very important. That is able to serve the needs of both training, AI training, which deals with the very large data and very, very complex models, and also the ability to deal with very, very high performance needs of AI inferencing. I mean, if you take a large retailer, we're talking about tens of thousands of cameras. We're taking a smart city, maybe thousands of cameras. All of them have to be deployed in unison. So the ability for all of these technologies to combine together and work in unison is something which I know the technology is very, very firmly marching towards.
Very good, Sundar. Thanks, Mike. Thanks, Sundar. Really, what you are all saying, that we need multiple technologies to come together at an unprecedented rate, I would say, that we have never seen before, to come together and address this and start converging some of them. And really, how do we orchestrate this whole thing? You know, you have cloud, you have galaxy of edge, and then we have billions of devices. How do we orchestrate this, and how do the hardware and software and algorithms interplay? Definitely a lot to do there. So
excellent summary. Yeah, excellent summary.
Sure.
Thank you.
Thank you so much. I'm at the end of the top of the hour, so you know, lots of key points came out. There are definitely walls that we need to break, and it's not just only a silicon play. It has to be a silicon, software, systems, algorithms, like we say, interconnected in a continuum, as Professor Mitra said, and then we need to continue to advance technologies. We need to see how do we generate chips faster, but at the same time also rely on algorithms and software to take advantage of these chips properly, and extensive collaboration is key. And we hope that somebody does some good research and comes up with, I would say, taking the leap kind of technologies, whether silicon photonics or neuromorphism or something that you know, kind of becomes a disruptive, but for the right reasons. Okay, so thank you all, the panelists. Wonderful ideas, wonderful perspectives. And it was really great pleasure talking to you all. I learned a lot during this process, and appreciate it. Thank you all.
There is a question. Yeah. There is a question, Sambit. I do not know whether we take questions.
Oh, okay. Yeah, I asked if there was any question. There was nothing in few minutes back. But Kamal, go ahead.
Yeah, so I know a lot of questions were answered.
We should make it very brief. Jeff is in the call, and we are all eager to listen to Jeff as well.
So I know a lot of questions were answered, but let me briefly ask this question that we were discussing about. AI is causing problems for the semiconductor industry. So what is the best possible way to use AI only to solve the problem? Only to solve this problem.
Okay.
Which does not cause the problem.
Any of the panelists, Professor Mitra, you talked about the EDA industry, how EDA can solve AI chips, but others can feel free. But Professor Mitra, do you want
to? Quick input from my side is, I mean, if I read the question further, which are the fields in semicon industry that are taking advantage of machine learning and deep learning? Very importantly, the quality control and inspection using advanced video analytic techniques. They are used to find out very, very minor or very small defects that could be there in a chip. So that is the area where deep learning is used.
Excellent point, Sundar. Anybody else? Professor Mitra, you want to talk about EDA?
No, I think we're at the top of the hour, and I think I was going to mention something like that. So that's a great answer.
Okay.
Yeah.
Anybody else?
Essentially in the manufacturing world, right from the development to low volume manufacturing to high volume manufacturing to the yield enhanced entity, the shift left is a functional element that is as powerful as post-silicon in-compute memory power, right? So when we shift left, we use AI to shift left to be able to create a design that can be manufacturable, and can I do it with less silicon footprints on the floor, also containing to sustainability. So this way we could actually look at creating an advanced chip that can actually go back and drive a hardware or another compute power. Can it go into a graphics card? Can we go into other? So AI for semiconductor manufacturing can actually result in AI powered semiconductor chips. So it's a win-win.
Yeah, I'm looking for AI system to generate my RTL within a week, So anyway, anyone else? Great points. Anyone else wants to?
To have the best of RTL, you need to have a good RTS, return to site, because collaboration is the key.
Yeah, absolutely. Anyone else before we wrap up? Thank you all. It was really a great pleasure and honor for me to do this panel. Thanks, Kamal, for this opportunity. Thanks, IESA Summit, AI Summit, for this opportunity. Really appreciate it.
Thank you very much.
Thank you, everyone.
Thank
Very
you.
interesting
Thank you.
discussions, very interactive. And I want to thank all the panelists, and thank you, Mr. Prabhat Sahu, for leading this panel. So thank you once again.
Thanks a lot.
Okay, so it's time to move to the next session. It's a keynote address on AI software by Mr. Jeff Gehlhaar, VP and Head of AI Software, Qualcomm. Mr. Jeff is Vice President of Technology and at Qualcomm, and currently leads the AI software team for Qualcomm. The team develops the Snapdragon Neural Processing Engine, SDK, Qualcomm AI Engine Direct, and AI software for the AIC100 server products. The team also contributes to Qualcomm's efforts in applying machine learning to computer vision, automotive, speech, audio, power management, and other domains. During his 30 years at Qualcomm, Jeff has worked on a variety of projects encompassing software for embedded systems, hardware bring-up, and software engineering. He is a holder of several patents and is a graduate of Jacobs School of Engineering, UC San Diego. Please welcome Mr. Jeff Gehlhaar.
Thank you very much. Let me go ahead and share my screen.
And Jeff, if you can also switch on your video if possible.
Yeah, it wouldn't let me do that a second ago.
Thanks.
But let's see if
Yeah, I can see you now. Thanks.
Okay, give me 1 second here. I'm sorry. I'll be right back. I'm sorry.
We'll wait for Jeff to rejoin. Yeah, welcome back, Jeff.
Sorry about that. Okay, well, we'll get AI to fix this up at some point here in the future, I hope.
Absolutely.
Okay, I judge you can see my screen now.
Not yet, Jeff.
Interesting.
Yes, can see now. Please go ahead.
Okay, sorry about that. Okay, well, thank you again for hosting me. I appreciate the opportunity to share with the audience, I think this morning in most of the world. And I wanted to begin, you know, what I hope to do here is to highlight the impact that AI has had on the semiconductor industry, but more from the point of view of devices and applications rather than, say, the panelists in the last discussion that I caught a piece of discussing you know, applications of AI specifically to the development of semiconductors. Now, one thing I wanted to share with the audience is Qualcomm has been at the research and development of AI for over a decade. And I've personally been involved in it for most of this time. And of course, I won't take you through every point here, although we'll highlight a few as we go forward. You know, we started, interesting in the previous discussion about, you know, neuromorphic computing. We started looking at spiking neural networks back in, say, the mid-2000s, and then progressed towards common, ordinary, let's say, current neural networks. And as a consequence of deep investments in R&D, AI research, some acquisitions, and a lot of hardware and software development, I'll take you through what that sort of historical investment has led to, and then consequentially, what we can now see is the future of the applications of AI and semiconductors together for the industry going forward. Just to frame the specific enhancements when we look at hardware and software, and we'll drill into the AI engine itself in a minute, but you can see over the course of every year for the past 5 years, we have been making enhancements to our AI engine, which is really at the heart of the application of AI in Qualcomm's portfolio, and I will talk about the breadth of that application. But starting with mobile, we're now in our 7th generation AI engine, and the way to think about it is that we're roughly doubling the performance of the total number of tops, or the total peak performance of the device, generation over generation. Now, you can well expect that that may not continue at that pace, but the underlying message really here is incredible opportunity to bring power performance to not just handset devices, but as you'll see, a very large category of intelligent connected devices. Now, the reason that we're here is because we developed technology for mobile first, and that's really key to enabling what we'll discuss as the connected intelligent edge. So the combination of 5G connectivity and frankly, you know, local area connectivity, Wi-Fi, Bluetooth, all of our connectivity technologies with AI really is what's going to power the connected intelligent edge. Now, if we look at our latest flagship Snapdragon 8 Gen 1 SoC, what we find is the most advanced process nodes are being used. 4 nanometer process nodes enables very high, as you can well expect, very high densities and a tremendous amount of capabilities. And I'll showcase some of those capabilities in a second. But it's more than just the SoC at the heart of it. It's up to 50 other chips that make up the complete solution, including RF, power management, codec, quick charging, 3D sonic fingerprint. It's really this incredible ecosystem of semiconductor supported by software, and then I'll spend a lot of the time discussing applications here that are at the heart of Snapdragon 8 Gen 1. And when we look at it in summary, and I'll hit on a few points here, but focusing on the AI components, again, it's our 7th generation AI engine, 4 times the performance of the previous generation at 1.7x better power efficiency, including our 3rd generation sensing hub. support, and we'll highlight this with a lot of ecosystem partners, but support with Google Vertex NAS, a lot of ISVs and solution providers that we partner with that provide solutions in conjunction with our handset OEMs and other markets. But as we'll highlight also, incredible performance in camera, in CPU performance, in 5G modem and RF, all packaged together on a very, very sophisticated single SoC solution. Now, an important thing are use cases. So you have all this incredible AI performance packed into this SoC, but what can you do? And so this is really where the algorithms, the networks themselves, the use cases for the end customer or end application, and the software really start to come together. Now, this is an example of a lot of AI-powered use cases that we find on mobile handsets and really on Qualcomm applications, in lots of markets. And it ranges from games to content creation to security to platform management, so battery life and latency. Even now in the modem itself, we're applying AI, right? So there's just an incredible number of use cases. Many of them, are in a mobile handset, of course, are customer focus, customer engagement, your camera, your voice, and so on. And I'll go on to highlight that in a moment. So a good example is a partnership that we have with Hugging Face. Hugging Face is perhaps the industry leader in providing NLP models and NLP technology, so natural language processing in a whole variety of mechanisms. And we worked with them to bring this onto Snapdragon 8 Gen 1. And specifically in the case of something like sentiment analysis, so this is language models that can understand intent and tone and language. And by moving their models from the CPU to the dedicated Hexagon AI processor, we get a 30x improvement in power performance. So that's a tremendous amount of gain. And what it really means is the ability to move things into a real-time context on a mobile device. So let me kind of illustrate, how that might work in a use case. So I'm sure, like all of us, you get hundreds of emails or hundreds of text messages and WhatsApp notifications every single day. So here we have an illustration of, over the course of a day, a person's getting a lot of messages, right? And these messages contain all kinds of data and text and context, right? So processing them on Snapdragon 8 Gen 1 in the Tensor processor, the network takes these things, parses apart the text, analyzes the text, right? And ultimately, makes categorizations. Is this urgent? Is it something that's low priority, and so on? And then you can, instead of just having the raw text, you can have an organized way to have your text appear, categorized for you, so you can focus on the most important things. And then you can even interrogate it. So using additional natural language processing, you can say, for example, what time are my meetings, right? So this is the kind of use cases on mobile devices that this 7th generation AI engine really is able to power, to enable for the end customer. And it's really bringing that highly performant silicon and software together in order to enable these kinds of use cases. So to highlight that, it was alluded in the bio, my team focuses principally on the software enablement on our SoCs. And that includes the Qualcomm Neural Processing SDK, the industry's first really developer-oriented SDK for AI solutions, industry standard TensorFlow Lite and TensorFlow Lite delegates, and the Android Neural Networks API. All of this built on a common substrate with the goal of providing the best power performance access to our hardware, whether it's the Hexagon processor, whether it's the CPU or the GPU, and we enable access to all three of those IP blocks. But it's also to bridge the gap from the developer end user case, whether it's an application developer, a handset OEM, and so on, to enable them to bring their most powerful AI use cases onto Snapdragon 8 Gen 1 and really take advantage of that very advanced silicon that's sitting there on the SoC. And in conjunction, of course, we provide tools to help in the optimization process. So things like quantization tools to take a network trained in, say, 32-bit float and move it to int8, where you're going to have the best power performance. So with that as a background, I want to take you through some additional markets where we see AI, having a very strong impact. Together, we think we can enable a world where everything is connected intelligently, and I'll take you through kind of how we think about that roadmap. Now, we have a single technology roadmap that scales to address all of our growth sectors, and the reason we can do that is because mobile is winning. Our mobile heritage and our DNA in mobile puts us at the forefront of high performance, low power for on-device intelligence and making sure everything's connected wirelessly. And not only do we have leadership in AI, but camera, graphics, sensors, and so on, along with connectivity. So this really puts us in a position where we can take this innovation that we're doing for mobile and scale it out from low complexity devices like earbuds all the way up to the digital platform of future automated vehicles. So this is really what I want to focus on is, what are these market opportunities for AI in semiconductors when we really think about a system solution for these markets. So because of this heritage in mobile, because power performance is so important in all of these markets, and because connectivity for the connected intelligent edge is also so important to connect all these devices together, we're uniquely positioned to grow this footprint that we have in mobile across multiple significant markets. And so this is really where we're seeing this incredible expansion from mobile handsets into a lot of these other markets. So for example, automotive, we'll talk a little bit more about that. Consumer IoT, so let's say things like VR headsets and always connected PCs, and industrial IoT, robotics, smart cities, and so on. But maybe leading with the most interesting, maybe largest market for us in some ways, we've become the preferred partner for the digital chassis of the future, right? So taking our technology, really the way to think about it is the car is becoming a fully digitized platform, a connected digital platform, and our complement of solutions, our cloud connected digital platform for automobile, including telematics, connectivity, computing, driver assistance, and ultimately autonomy. This is what's going to allow automakers to deliver connected, intelligent experiences that are safer for the occupants, safer for those around the vehicle, and really enable this immersive digital experience. You can think about it, we have connectivity of cloud, of car to cloud, car to car, that the cockpit or the driver's presentation, the dash, is becoming a digital cockpit and an entertainment hub, that we want vehicles to talk over 5G to each other and to the infrastructure. And maybe the most significant part is our ride platform. Taken together, this represents like a 10x increase in our addressable market for future silicon in vehicles. So it's a very significant growth market for the industry as a whole, as cars become digitized, and for Qualcomm specifically. Now, when we look at Snapdragon Ride, this is an integral pillar of the Snapdragon digital chassis, okay? Introduced in 2020, it's already making a really big impact in the market. So our vision system on a chip is being integrated with the Arriver vision stack, and that along with additional stack for drive policy from Arriver really is powering that whole digital digital environment around the car. So it's front and surround view cameras for advanced driver assistance, for automated driving, and then drive policy stack. We provide a very sophisticated silicon and software platform around Snapdragon Ride that really is at the heart of powering the next generation of automobiles. And we're really excited because you really cannot build these vehicles without bringing incredible processing to all of these cameras, and then processing all of these cameras and LiDARs and sensors with AI. You really need AI to be at the heart of all that, which is what makes it so incredibly exciting for us. Now, another great opportunity that people will be really familiar with, and this is the convergence of mobile and the PC, right? So the way to think about this is that same mobile architecture that powers the handset in your pocket, that lets you run video games and so on. That's at the heart of the always connected, 5G connected, all day battery life device. Think of the PC as like a very large scale smartphone. And now we're starting to see AI applications. So for this segmentation that's being done with me in this background, this kind of application is being done more and more seamlessly in these always connected PCs. And we're happy to see Qualcomm silicon at the heart of this winning transition as devices transition to ARM as a core architecture. We have a new ARM team with Nuvia. We've got advanced mobile-oriented GPUs. We've got our AI processor. This is really where the extension of the low-power, high-performance pedigree that we've built in mobile is really translating to a market that we're all very familiar with. I want a PC that stays cool, is really light, runs all day, is always connected. This is what's possible now. And then adding AI to that, then again, you can power content creation use cases, you can power video conferencing use cases, photography use cases, and so on. So really excited about the opportunity in the always connected PC market. Particularly when you add artificial intelligence to it. And maybe the last segment to highlight that, again, is very exciting, very commercially oriented, is XR. So the majority of today's XR devices are already powered by Snapdragon, and we've added the Snapdragon Spaces SDK to enable development on these platforms. And we're happy, of course, to share that Snapdragon XR2 was named one of Time Magazine's best innovations. So really exciting that we already have an established foothold here with XR, and excited that as you combine this with 5G, as you combine this with additional AI processing, as you combine this with these immersive digital experiences that consumers want, the partnerships that we're building, as you see here on the screen, is just an incredible amount of opportunity for the semiconductor industry, for AI software running on that silicon to provide the next generation of experiences to end customers, and for industrial and commercial applications as well. So I want to wrap up by saying I hope I've been able to share with you the critical importance of AI as a driver for the semiconductor industry. We started out, like I mentioned in the beginning, 10 years ago, with this idea that we could do something with spiking neural networks. And what happened in the industry was this emergence of these more traditional, CNN-based and now transformer-based neural networks. And in the process of getting better at running those things, we have developed, and the industry as a whole have developed, the capacity to run very powerful networks in power-constrained devices. And in getting better at that, what we've really done is created just a lot of different opportunities for that basic model to be applied to the digital cockpit, to be applied to industrial IoT, smart cities, home entertainment, VR experiences. I think the opportunity to leverage semiconductor innovation and software maturity as we get better and better at delivering software solutions to enable these networks to run on devices like the devices Qualcomm creates. Really incredible. I think we'll look back, over the course of the next decade and say, wow, we were just at the beginning of this massive explosion that we like to call the connected intelligent edge. So with that, I'd like to thank you for your time and happy to take any questions.
Thank you, Jeff. So there's one question that we can take that I got from the audience. So I'll lead that. Qualcomm talks about intelligent edge. What do you envision more should happen to realize this?
Well, I think more. I hope I painted a picture that we're well underway and on a good track for this. I think it's there's a couple of things. I think innovation. I think the creativity that the end entrepreneurs are going to bring with this capability, right? It's hard to imagine all the possibilities. Having forums like this where we can share what the capabilities of a platform like this are, and then sort of let people spark their innovation. I think when we look at when we first put position reporting into mobile phones, I don't know that we ever anticipated something like Uber or Lyft and Didi and all these kinds of platforms to emerge. I don't think we ever imagined that food delivery via mobile devices was going to be, a saving characteristic of the pandemic, right? So I think what we really need to do is create these solutions. Of course, we want to work with key partners, but then some of it will just come organically through innovation.
Thank you, Jeff. So we'll end this session here. So I want to thank you, Jeff, for a very interesting keynote, and I'm sure many of us will take inspiration from you. Thanks again, sir.
Thank you, and I hope you have enjoy the rest of your conference.
Thank you. All right, so let's move to the next session. Is also a keynote, and another very interesting topic titled "The AI Transformation: Driving Ethical and Sustainable Semiconductor Solution to Enrich Life for All." What an interesting topic. And our keynote speaker is Dr. Naga Chandrasekharan, Senior Vice President, Technology Development at Micron Technology. Dr. Chandrasekharan leads Micron Global Technology Development and Engineering efforts related to the scaling of current memory technologies, advanced packaging technologies, as well as investigating emerging memory technology solutions to support Micron's future requirements. He also manages mask technology development, corporate characterization labs, advanced modeling, and data analytics and R&D fabrication operations at Micron headquartered at Boise. He was appointed to his current position in 2019. In 2001, Dr. Chandrasekharan joined Micron as a CMP development engineer, and since then has held a series of positions of increasing responsibilities in process and equipment development across multiple R&D process areas, leading manufacturing and technology transfer efforts, integration of new business units, and development of solar, LED, and display technologies. From 2007 to 2008, he also served as Fab Engineering Manager for IM Flash Singapore operations. He most recently served as Senior Vice President of Process Research and Technology Development. Dr. Chandrasekharan has authored several keynote publications and patents, and he has served as an invited panel speaker at several conferences. He has also received several awards, including GRE Plus T Outstanding Young Manufacturing Engineer of the Year awarded by the Society of Manufacturing Engineers in 2003, and Engineering Manager of the Year awarded by the American Society of Engineering Management, ASEM, in 2018. Dr. Chandrasekharan earned a bachelor's degree in mechanical engineering from the University of Madras. He earned both a master's and a doctorate degree in mechanical engineering from Oklahoma State University and dual executive MBAs from the University of California, Los Angeles and the National University of Singapore. Please welcome Dr. Naga.
Thank you for the kind introduction. As I start my presentation, some of you might be reaching out to a search engine to learn more about Micron or the speaker. Some of you might be turning on the transcript facility in the Zoom. Some of you might be getting ready for lunch and looking for what to order based on a smart app algorithm that's suggesting you what to eat. Irrespective of your profession or where you are, a majority of us are exposed today to AI and ML solutions in our day-to-day life, and that's the reality. The world is changing around us, and AI ML is playing a transformative role in shaping the world ahead of us for the next century. And in this talk, I want to share with you how semiconductor technology solutions are playing a pivotal role in enabling this transformation, enriching life for all. Hello, everyone. Good morning. My name is Naga Chandrasekharan, and I have the privilege to work and represent Micron Technology in this conference today. I want to thank all the conference committee members for providing me with this opportunity to come and share my thoughts with this in this key forum. If you look around us, whether it is at home or at office or on the go, everything is changing around us, and the main objective is to improve the quality of life. If we are at home, we are exposed to AI ML solutions either through software-enabled new capabilities or hardware solutions. Most of our homes and the devices are smart technology today, and they talk to us on a regular basis, and they suggest how we can enable smart homes and more energy efficient homes. Workplace has changed post-COVID, and AI has enabled increasing collaboration at workplace. AI solutions are also being used as a knowledge management tool while protecting our IP. How do we share our knowledge with everyone and at the same time keep our IP, intellectual property, secure and intact? One of the industry that has seen a transformation because of AI ML is in the automotive industry. We call cars as data centers on wheels. The amount of data that automotive today generate, store, process to make real-time decisions is significant. We actually can live in a car today in terms of not just a place to sleep, but also entertainment, infotainment. The amount of information that's in a car today are significant. It's not just our day-to-day life and some of these luxuries that we enjoy. The human life today is very thankful for the advancements that's being made in medical industry. AI ML is playing a significantly transformative role in the healthcare industry in being able to diagnose diseases faster, and precision medicine, which we thought was a dream a century back, is now becoming reality because of availability of data, faster compute power, and improved algorithms. Healthcare industry and the medical professionals are the ones who are going to benefit the most in terms of using AI ML solutions. Now, all these new applications, the new solutions that we are seeing around us generates a lot of data. This data now has to be stored, moved, and processed in real time. Here I'm showing a graph from a 2015 paper where they used 3 primary areas to show the amount of data that was being generated. Astronomy is seen as an area where huge amounts of data are generated on a regular basis. And as we all know, many of us load our videos and our talks onto YouTube, and that's generating significant amount of data. And genomics, starting 20 years back when we actually decoded the human genome sequence, there has been a lot of progress in this particular area as well. So 3 areas, and in 2015, they were generating a fraction of an exabyte worth of data every year. It was projected in this paper that over the next 10 years, by 2025, the astronomy and the YouTube-based data sets would grow by 1 to 2x, a factor of 10 to 20 in terms of the total data generated. But genomics is an area where the data growth is going to be exponentially higher than any of the other areas. And this goes back to how data and AI ML are going to change how we live our life and the quality of life in solving the most important problems from healthcare to agriculture to future generations' well-being, genomics is going to be a key area that's going to be benefiting by AI ML and also generating significant amount of data. Now, all this data has to be processed. When we talk about data, it's information. And we know information gives us knowledge, but knowledge doesn't lead to wisdom all the time. The new semiconductor solutions and the AI ML solutions have enabled new business models and new ways of generating data. For example, with 5G and the mobility, we are always connected. We don't see anybody without a smartphone today. We want to get access to information all the time, and everything has to be available to us at our fingertips everywhere. We use cloud to store our data, and most of our processing is done in the clouds. Not only cloud, but our devices are becoming power hungry, memory hungry, and we are now able to get more data on our devices. And we want to process this data at edge so that we can make faster decisions instead of having to move data to the cloud, doing the compute and bringing it back. All these new business models or the new ways of generating data and processing them is only giving information and it's feeding to our knowledge. But in order to gain wisdom, we have to be able to make decisions. Knowledge is knowing and wisdom is doing. Making the decisions comes only with AI ML. So the key question is, can AI ML drive enough intelligence from the data so that we can make real-time decisions? For a machine learning solution, we need fast storage that can provide the data to the system so that AI ML can learn from it. In terms of inference algorithms, they need state-of-the-art GPUs to be able to process the data. We need high-performance memory and high-bandwidth memory that can handle big volumes of data, process them fast, and provide us with the intelligence. And all these solutions now require new forms of memory and storage so that AI and ML can derive wisdom from the knowledge that we all have. And this is where memory is playing a transformative role. As I mentioned, you need to provide huge amounts of data and at a faster pace for machine learning to happen. And training data requires significant amount of fast storage. We need faster compute, and we also need to be able to process this data without eating into huge amount of power in these systems. So what's happening is the memory hierarchy that I'm showing here in a triangle, the semiconductor memory technology hierarchy, is going through a transformation in order to enable AI ML solution. In this triangle on the top is what we call as hot memory. This is where the data that is needed for the compute is kept, and it is able to provide this data with the lowest latency so that computation can be done at a faster pace in order to make the decisions. At the bottom of this pyramid is storage, a pretty archival storage in terms of hard disk drives that come at a very low cost per gigabit, but they are also very slow. So you can use this for mass storage of data, but it's not fast enough for the algorithms to be able to consume the data and provide decisions. So in the past, a decade back, what we had was DRAM, which is the fastest memory solution, and then NAND, which provides you the lowest cost storage solution. But this memory hierarchy is now starting to expand and at the same time converge. What we are seeing is memory and storage is starting to converge in terms of their certain capabilities that feed into some of these applications that I highlighted earlier. But at the same time, a DRAM, a one-size-fits-all, or a flash storage one-size-fits-all doesn't meet the needs of this new evolving landscape of AI and ML. We are now seeing high bandwidth memory at the top of this pyramid, which is providing a huge bandwidth and high amount of data to the compute. And we have our DDR5 that's able to operate at very high performance, but also reduce the power so that our data center customers don't have to pay a huge amount of cost in terms of energy that they use. And then the storage itself is starting to bifurcate into a fast storage and a low-cost storage. And the fast storage could be feed into the machine learning applications that I mentioned, where you have to provide huge amount of training data at a very faster pace. So memory technology solutions are now paving the road ahead for AI ML to further progress in being able to handle vast amount of data, real-time processing of this data either at the cloud or at the edge, and being able to generate sufficient knowledge and wisdom for all of us to gain from the data that we are generating. Eventually, it's a circle. New applications come up, we generate data, the data needs to be processed, decisions made, creates room for new applications, and we generate more data. So this data cycle is now feeding a new economy that we call data economy, and memory solutions is what's enabling this today. Now, the next generation of data centers themselves are configurable for workloads like natural language processing, where it can become memory intensive. We could structure some of these solutions by making them more composable into how much memory and storage we are providing into these racks. Micron memory has a wide range of solutions, starting from the NAND solutions to the DRAM that I talked in the pyramid, in the memory hierarchy. But there are also several emerging memory solutions that are developed in the space of latency and cost. This graph here shows latency on the x-axis and cost on the y-axis. And we provide the industry-leading DRAM and NAND solutions that are able to provide the fast storage for machine learning applications, and for inference algorithms, the fastest memory solutions and high bandwidth solutions. But also some of these new emerging memories come up, which are able to provide an advantage in terms of neural network-based algorithms, where we can have weights assigned, and these memories can function in a much more efficient manner, either it is in latency or in terms of power reduction capabilities. So Micron, with its wide range and portfolio of solutions, either in bandwidth or performance or power or cost, is now able to provide solutions for AI ML applications, which can now be composed into the data centers based on the needs of our customers. So I just talked about how our life is changing and our entire ecosystem is changing because of AI ML and the data that we are generating as a result. I also mentioned how memory technology, which is Micron's core business, is enabling AI and ML to provide these advanced solutions to the customers, and memory is now paving the way forward for AI and ML to advance. So memory is key for this whole ecosystem to evolve. But how can AI ML itself help memory technology continue to scale? One is cost. We need to be able to provide continued cost reduction roadmap. The second is bandwidth and the overall capacity of these memory solutions. We need to be able to provide higher bandwidth solutions and be able to provide these high performance, low latency solutions, but at the same time reduce the overall power, whether it's a mobile phone where we don't want it to be power hungry and drain the battery fast while we are doing some of these computations on the edge, or whether it is a data center environment where we want to continue to reduce power. We need to be able to continuously scale our memory solutions for performance, power, bandwidth, and cost. So conventional way of technology development alone cannot get us there. And the question is, the AI ML industry that memory is enabling, how can it in turn enable us to continue to scale our memory solutions to benefit the overall ecosystem? I'm showing an example here where a traditional yield curve over time. In the semiconductor technology industry, yield is extremely critical. And we start with a very low yield or also zero yield in the beginning. And over time, we try to solve the problems, whether it's defectivity or device problems, and continue to improve the yield. And at some point, we reach the surface. Going from zero or negative yield, we now get positive yield. And then the race starts. We continue to improve our yield, eventually leading up to maturity. Many of the semiconductor companies today use ML as a way to avoid excursions or find correlations so that we can understand how different parameters affect our yield. so that we can accelerate this yield journey. And that's where today's ML is focused. But what we really want to do is to be able to take AI and move the curve to the left side. We want to make sure our starting point is same, but we can now achieve the mature yield much faster. And in order to do that, we also need to be able to transcend between technology nodes. We cannot do it only for a particular technology node. We need to be able to take our information and our knowledge and be able to turn it into the wisdom that I talked about in making decisions, so that every technology node treadmill, we are able to accelerate this yield curve faster. And that's where the biggest transformational value of AI comes in for the semiconductor industry, is we can solve our technology problems faster by depending on some of the AI solutions that we are able to generate. We have hundreds of equipments in our fab. We use thousands of materials in order to make these semiconductor chips, and there's process variability within our operations. How can we take all this information and start building models that are now able to provide decision-making information for us that will move our yield curve to the left? Equipments today in a semiconductor factory provide terabytes worth of data. The materials, their incoming properties, we can use this information to derive and say what affects the semiconductor chip performance. And process control and variability control can be a significant factor to improve our yield. So using AI models to be able to predict how a new node would behave and be able to develop our solutions earlier will help us to achieve the end goal of providing best semiconductor solutions to our customers. It's not only the technology development phase, but also once we develop, how do we provide better insights into the overall manufacturability of these devices? So I talked about AI from two perspectives. One is a software solution, but we can also have hardware-based solution. We are able to put many sensors and new devices into our factory on the tools and be able to collect these signals and predict the performance of these tools, either from an availability perspective or before the tool goes down, how can we interdict and be able to fix the tool, or before a process deviation might happen, how can we predict this occurrence and be able to solve it so that our wafers are not scrapped. So using IoT and getting data from the sensors and building them into our models can provide improved manufacturing capability for the semiconductor industry. So we now can take our AI solutions and be able to provide better yield faster and be able to reduce our waste within the factory. But AI solutions can also help us build better products in a sustainable way. The overall bit growth for DRAM and NAND will continue to increase over the next decade and several decades to come. And as we produce more and more bits, we want to be able to do it in a sustainable manner. And there are two sustainability aspects to it. One is, are the products more sustainable, but also are the operations more sustainable? In this slide, I'm showing how the product sustainability can serve our customers as well as the overall environment. Micron is working on technologies to develop lower power consumption devices. In our DRAM, for example, here I'm showing a 1-alpha DRAM node, where we were able to reduce our energy per bit by 13% generation over generation. Also on the low power DRAM devices, we were able to improve our power consumption by 20%. These directly go into energy efficiency solutions for our customers, and they generate less heat, whether it's in a phone or in a data center, and that reduces the cooling cost, which eventually helps the overall environmental sustainability. Now, how do we get here? I talked about the vast range of applications earlier in the presentation, and these applications can now have different workloads depending on the customers and the product and how it is being used. In understanding these workloads, we can now optimize the devices and the performance from a system level to be able to generate better power efficient solutions. So working closely between end customers and the device manufacturers and using AI to identify the different workloads and how to better optimize the system, we can generate these sustainable product level solutions. And not only product, but also from an operations perspective. The semiconductor factories today run hundreds of thousands of wafers every month. It is using significant amount of energy. I talked about the hundreds of equipments, and they all consume huge amount of energy. There's usage of water in a semiconductor manufacturing process. We use chemicals and different gases that can result in emissions and waste. So how do we drive improved environmental sustainability? It is paramount that semiconductor technology manufacturers not only are driving the AI ML solutions and new semiconductor chip technology, but we need to make sure we are doing it in a sustainable manner for the generations to come ahead of us. So Micron's investing heavily in this area, where we are adding IoT sensors into our tools, into our facilities, and we are collecting data from these sensors and using algorithms to suggest how to develop sustainable processes so that our overall operational efficiency can be improved. For example, by having sensors that are looking at the reaction efficiency of the gases and making sure if there are unreacted gases, we are able to inform it to the process and optimize the process so that we can reduce our emissions. We can come up with better energy solutions by driving a Pareto of where the energy is being consumed across the tool. We can optimize our water and waste by understanding and collecting the data first, looking at trends and being able to use algorithms to predict how the waste is going to happen in future and then drive process development to improve it. So when I look at semiconductor technology and how AI ML can help, it can help us in developing better process and equipment technology. It can help us in driving better long-term roadmap for semiconductor chip solutions. It can help us in develop better products that are driving sustainability. And above all, it can make our operations more sustainable so that we can have sustainable technology development effort. And we are doing all of it. So when we look at semiconductor technology, it's not just silicon and materials and equipment, and AI can play a big role in driving this technology forward for the next several decades to come. So what are the challenges? That all sounds very good, but what are the challenges today in driving this? There's a challenge of data availability. The semiconductor manufacturers have huge amounts of data that's generated either by the equipment or the measurements on the wafers themselves. Now, this data is not available for everyone to be able to provide better algorithms and solve these problems. The second is data complexity. The data has several layers, and these data now have to be parsed, whether they are at a system level or at an equipment level or from a materials manufacturer. All these data come in different forms, shape, whether it's a data engineering problem or also the data connectivity problem that needs to be solved. But the bigger challenge beyond this availability and complexity comes to the talent and the privacy and trust concerns that exist today in how we handle the data. From a privacy and trust, we need to be able to have better partnerships in how we are sharing this data between partners with the trust, but also being able to protect the IP. So some form of encryption technology that allows us to share the data more freely so that we can develop better algorithms and gain insights, but at the same time also not be worried about our intellectual property. On the talent front, especially for this forum, I wanted to highlight how India can play a major role in terms of semiconductor technology enablement. As I mentioned, when we talk about semiconductor, which is capital intensive, energy intensive, it has huge amount of infrastructure requirements, and all of this could be seen as barriers in enabling a silicon-based technology development platform. But time has changed, and semiconductor technology development is not just about touching silicon. That is still the core. That is the foundation of enabling a semiconductor chip technology. We need to have process knowledge, and the process knowledge involves individuals understanding device physics, how to drive different processes in building this semiconductor technology on a silicon wafer. We need to understand the equipment. We need to understand plasma technology, or we need to understand the water flow. We need to understand the valves and the MFCs that are used, how they play a role into making the technology more stable. We also need to have development expertise. It's decades of development knowledge that has gone into developing these complex nodes of DRAM, NAND, or compute that we develop in our semiconductor factories. All of that comes from silicon. But now if you look at how AI ML plays a role, the process knowledge now generates huge amount of data. All the design of experiments that we run or all the work that we do on silicon, we are generating huge amount of data from our inline measurements or electrical measurements. And once again, this is information that gives us knowledge. But in order to drive that into wisdom, we need to have advanced analytics capability. And this is where AI can play a big role. Equipment understanding. Equipments provide a lot of data for us today. But how do we predict what should an equipment roadmap be 10 years from now? We need to be able to connect the equipment data with our process data and have advanced algorithms that can actually detect what parts of the equipment are affecting the end performance on a silicon wafer and be able to now drive this advanced equipment roadmap forward. And then from a development expertise, this is the knowledge that is residing in hundreds and thousands of engineers' mind. How do we collect all this knowledge and be able to turn it into our wisdom so that we can predict how a next node or 2 or 3 nodes from now will work? And this is where we can combine our AI ML-based approach along with physics-based solutions and now be able to develop models that are not only dependent on the data that we have today, but take the fundamental physics-based understanding and combine it with the empirical data and able to predict the future. And this is where India has a huge talent base. The Indian workforce and the education system allows us to have advanced analytics capability in our students. They all have good computer skills and can write codes. The physics is a strength of the workforce in India. Now, if you combine these three, how can India provide solutions for semiconductor technology so that we can create a great marriage between the silicon solutions and the India solutions, which is the AI ML-based solutions, and be able to make better semiconductor technology for future that's going to drive this roadmap of AI ML and make all our lives better in a sustainable manner. In order to do that, we need better partnerships. We need to be able to work together. We need to be able to guide each other with the best intent that's going to develop this technology for all in a sustainable manner and provide a better future for generations to come. I want to thank everyone for your attention. And I once again thank the organizers for this opportunity to be able to share some of my thoughts today. Thank you very much. And I'll be happy to take any questions.
Thank you, Dr. Naga. I think you answered a lot of questions, and it's a very important aspect of our industry we sometimes ignore. So there's one question which I see somebody has asked. You spent a lot of time talking about the product sustainability. And I think you also mentioned about the data privacy as maybe indicating towards the ethical way of using that. So can you throw some more light on how AI is driving ethical semiconductor solutions?
Yeah. That's a very good question. So there are, for example, I've talked in the past about, in the DRAM case, rowhammer is a well-known mechanism that can open up some vulnerability in our end product solutions from security perspective. And AI could look at different cases, different use cases as to how potentially a hacker might get access into our DRAM solution. It can look for different sequences, different ways in which the data gets accessed into the particular cells. It can look for algorithms and different methodologies by which someone could get access into a DRAM and be able to test them and provide a guideline for DRAM manufacturers, which can then be used to develop software solutions to counter. We can also build in some solutions at the silicon level to be able to counter these methods by which someone could get access into a DRAM solution. So AI could play a role in looking at the different workloads and different ways in which the memory technology is being used for these applications and look at it from a security perspective and provide suggested solutions for us.
All right. Thank you so much, Dr. Naga. Appreciate you participating and throwing a lot of light on this important aspects. Thank you so much.
Thank you very much.
Okay, our next section is a demo from a startup, and I would request Sridevi Garu to host this session. Thank you.
Thank you, Kamalji. It's indeed an honor and pleasure to introduce startups to IESA AI Summit. I'm a startup evangelist, and there are so many startups in India and abroad which are disrupting the scene, and they're having so many use cases. And one such interesting startup today, which has sprung out of IIT Kanpur and is revolutionizing the medtech world, is Life and Limb. And today amongst us, we have Mr. Nishant Agarwal, who will tell us more about his company. Let me introduce Nishant to you. He's a very dynamic young entrepreneur. He's the founder and CEO of Life and Limb. He completed his MS in research from IIT Kanpur, where he began his journey with his thesis project on building upper limb prosthesis. Life and Limb is a medtech startup which innovates, designs, and engineers bionic devices that are cost-effective, state-of-art, and custom-built for each user. This device empowers the user to live life to the fullest. This team, Life and Limb team, has experienced team members, mentors, and advisors from IIT Kanpur. We as a country, given the demographic dividend we have, student startups are disrupting the way we look at how we do entrepreneurship. And now, Nishant, we would like to know more about you and your startup. Over to you, Nishant.
Thank you so much for the wonderful introduction. Let me just quickly share my screen and share the snippet of the startup. Welcome to Life and Limb. We are a medtech company incubated at IIT Kanpur's Incubation Center with the aim to make the biomedical devices and empower the people to live to the fullest. Why another prosthesis? More than 25,500 amputees are reported annually in India, and less than 10% could afford to use a myoelectric or electromechanical prosthetic hand. This is where we started, and this is how a lab-tested prototype of a myoelectric prosthetic hand looks like. As you can see, the thumb is articulated as well, and all the fingers are actuated using electronic systems. Now, coming to the features of the myoelectric hand, our product is called Bionically, which has 14 grip patterns, and different segments of the product are being planned to build. First, for the armed forces, where different camouflage patterns or khaki colors can be introduced. Second, it can be user customized, mimicking the human skin color tone. We are using additive manufacturing techniques like multi-jet fusion and DLP printers to achieve the same. Coming to the features of the prosthetic hand, it is light in weight, it is water resistant, it has customized user design where we can use the 3D printing technique and 3D scanning to anatomically mimic the human hand. It has IoT enabled interface, and it has 14 grip patterns to achieve the activities of daily living. On top of it, it is better, faster, and stronger as compared to other prosthetic devices imported in the country. And we are providing color and design options as well. We have been cohesive from the design phase itself. And as per the ISO IEC directives for the class 2 medical device, any device should be charged outside the body, whether it is a mobile phone or any other biomedical appliance. We have been able to do this where we have a detachable palm, which can be pressed, rotated, and removed from the forearm shell of the prosthetic hand. And thus, USB microcharging can be exposed only when it is removed from the stump of the body of the amputee. We have a number of patents in the pipeline for the mechanical and electronic system of the hand. Our user journey is simple and is divided into 4 steps. First, we take the 3D scan of the residual stump as well as the physical measurement of the stump. Second, it is digitally modified in a CAD environment. Third, it is sent for 3D printing using vendor companies. And fourth, we meet the user again in the clinical settings with the help of prosthetists to fit the hand. Post that, we take regular feedback from the user on the fitment as well as the functioning of the prosthetic hand. Since a lot of efforts of ours are invested into building the electronics of the hand, this is the first part of the electronics where we have developed the control system of the hand, where we started with a hobby project of where we are using Arduinos and other things. Then it is a two-layer design, two-layer PCB design, where we have the control system all-in-one charging port as well as the microcontroller. Then we subsequently reduce the size of the PCB boards to fit into the palm of the hand. So on April 22, this is how the control board looks like. And we are highly supported by the Center of Excellence IIT Kanpur Incubation Center for Research Facility. Similar iterations were done for the EMG sensors or electromyography sensors or muscle sensors of the hand. As you can see, a number of iterations were done, starting with the in-house developed PCB board to the miniaturized electrodes or sensors. And we have been supported by a number of vendor companies as well as the research center at IIT Kanpur for development of the thinnest electrodes or sensors which can be directly used in the prosthetic hand. Otherwise, we were importing those hands from Russia and Canada. This is a short snippet of how the EMG sensors and control board looks like. As you can see, it has a flexible housing which can be mounted onto the stump of the amputee, thus contouring to the anatomy of the human hand. It will give better extraction of the signals. It is a surface EMG sensors or completely non-invasive. And on the right, you can see how the electronics of the electronic board of the hand looks like, which is made in-house. We are supported and recognized by a number of agencies. We are getting design support from Autodesk Foundation. We have been featured by Dubai Expo, Polygon Labs India, and various ministries for the prototype development. We have a CSR grant from Citi and Fortiscap, and we are supported by American Society for Mechanical Engineers on developing the product. Meet the team. I am Nishant Agarwal, founder and CEO, leading Madhav and Mayank on the technical side, along with Prachi, co-founder and CEO, leading Sachin and Shivi on the technical side. Plus, we are backed by highly experienced mentors and advisors from IIT Kanpur as well as industry. Thank you so much. We are life and limb. We are making bionic market by innovating the accessible, affordable, and aspirational products. If you like what you saw and heard, please reach out to me. My email ID is nishant@lifeandlimb.ai.
That was very brief and quick, Nishant.
Thank
so
you.
There's a question from one of the audience. Can you throw some light on the competitors as of now available in the market and how you are different from them?
Yes. So there are multiple number of companies who are making myoelectric devices. First, there are people from Germany who are exporting it to India, and it costs around 25 to 30 lakhs. And second is there are homegrown companies, 3 or 4, who are making myoelectric prosthetic hands, but they have limited functionality. In terms of comparison to what we are making and what they are doing, we are cost effective, and we are also making sure that none of the components are imported, and that is why we can bring down the bill of material of our product.
Okay, can you name 1 or 2 of them?
First is RoboBionics, second is Aether Biomedical, which is based in India. Second, the leading industry is the industry leader is Autobox, which is based in Germany.
Okay, that's really nice. So thank you so much for joining us today on behalf of IESA. I would like to thank you for giving your time and talking to all our audience. Thank you.
Thank you so much.
So dear audience, that's all for today's first session. Again, stay tuned and let us all connect at 3 p.m. IST, Indian Standard Time. If possible, please log in 10 minutes early. There are quite a few interesting sessions and panel discussions. You can go through the agenda for that. Thank you. Stay tuned.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
Today, I'm proud to launch our AMD Ryzen 6000 series mobile processors that deliver leadership performance, battery life, and much, much more. We have so much new technology in the 6000 series. It starts with an updated Zen 3 Plus CPU core optimized specifically to deliver leadership performance per watt for notebooks. And I know this is one the community has been requesting. For the first time, we are bringing RDNA 2 graphics to our notebook APUs. The RDNA 2 graphics upgrade brings a massive increase in performance compared to our prior generation, and is the same graphics IP powering the latest generation consoles, high-end gaming PCs, and Teslas. For increased performance and greater power efficiency, Ryzen 6000 APUs are built using TSMC's 6nm process technology. And to enable our partners to build the ultimate notebooks, we paired our leadership mobile processor with the latest in memory and connectivity technologies, including low-power DDR5 memory, USB 4, and Wi-Fi 6E. And the performance is just amazing. Ryzen 6000 powered notebooks feature our fastest Ryzen processor ever. With boost speeds up to 5 gigahertz, we're delivering an average of 1.3x faster performance compared to the 5000 series across a wide range of compute-intensive benchmarks. And with an RDNA 2 graphics built in, it's a massive leap, double the performance.
Today, we are introducing the AMD Radeon RX 6000S. This series is specifically built for thin and light gaming laptops. These GPUs are optimized for power efficiency and enhanced with new performance per watt technologies, pushing high performance in the most compact devices. 20% thinner, weighing less than 4.5 pounds. Last year, we introduced the Radeon RX 6000M series lineup for traditional gaming laptops. This year, we're growing the offerings. We are introducing faster performance graphics solutions with faster memory and higher game clocks. And we are also expanding the reach of the models in this series with a new discrete GPU. This new GPU is built on 6nm technology designed for low power gaming. Today, we are announcing a whole lot of new AMD Radeon mobile GPUs to bring the best experience to every gaming laptop. For our desktop gamers, today we are introducing a new 6nm GPU that brings RDNA 2 graphics to even more gamers. The AMD Radeon RX 6500 XT. This graphics card has the fastest sustained GPU clock rates ever at over 2.6 gigahertz includes 16 hardware array accelerators, 16 megabytes of infinity cache, and supports the full suite of Adrenalin software features.
With AMD Advantage, we're working to raise the bar of what defines a great gaming laptop experience. We've partnered with OEMs to design best-in-class gaming laptops by providing them with the design framework that ensures the premium performance delivered by our Ryzen CPUs and our Radeon GPUs is felt through all aspects of the laptop's experience. There are 3 key things to know about AMD Advantage laptops. First, we've amplified their gaming performance by optimizing AMD's CPUs and AMD's GPUs with our smart technologies. Second, they come equipped with high refresh rate and premium quality FreeSync displays. And third, we focus on each model's cooling, acoustics, sleep and resume times, battery life performance, and hundreds of other design decisions, making them truly built to game.
Today, I'm excited to announce that we are bringing 3D chiplet technology to market in our Ryzen CPUs. The Ryzen 7 5800X3D is our first Ryzen processor with 3D V-Cache technology. It features 8 cores, 16 threads, up to 4.5 gigahertz boost, and a large 64 megabytes of 3D cache to go with the 32 megabytes of 2D cache. The 5800X3D drops right into existing AM4 motherboards and delivers a significant boost in gaming performance. Looking at the performance in 1080p gaming, we see a significant increase in performance in many games with the 96 megabytes of L3 cache. Across the entire suite, it delivers an average of 15% more frames per second than our previous fastest gaming processor, the Ryzen 9 5900X. And when compared to the competition's best gaming processor, we're proud to say the combination of the Zen 3 core and AMD 3D V-Cache once again makes Ryzen the fastest gaming CPU in the world. Zen 4 is the next big step. Built on 5nm process technology, Zen 4 will extend our performance and performance per watt leadership in desktop PCs. For the very first time, let me show you our next generation Ryzen processor. This is the all-new 5nm AMD Ryzen 7000 desktop processor. It's currently running in our labs, and the performance looks incredible. And just as we did with Ryzen 6000 mobile, our next-gen Ryzen desktop processors will be paired with next-generation memory and connectivity technologies to deliver the ultimate experience. In addition to the new Ryzen 7000 CPUs, we're introducing an all-new AM5 platform. AM5 features an LGA socket and includes a support for PCI Express Gen 5, DDR5 memory, and much, much more. Now let's see Ryzen 7000 and Zen 4 in action for the first time. What you're seeing is 1080p gameplay footage of Halo Infinite running on a pre-production 5nm Ryzen processor. To give you an idea of why we're so excited about Zen 4, you can see beautiful gameplay at very high frame rates. And I can tell you that all of those Zen 4 cores are running at 5 gigahertz during this demo. This is the next generation of gaming and PC experiences from AMD.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akida Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. an engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akida chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akida development environment for free at brainchip.com/developer. Unlocking the future of AI. Brainchip, Akida.
Five years ago, Advanced Micro Devices was in trouble.
Ooh, AMD, Advanced Micro Devices, very painful day for this stock.
AMD it's still surviving, but
yeah, surviving.
Not by a lot.
The chipmaker was bleeding money, drowning in debt, facing a possible bankruptcy, and its stock was trading around $2 a share. Lisa Su then became the company's first female CEO, faced with leading a daunting turnaround.
I was really excited to become CEO, but of course, a little bit scared like anyone taking on a new job.
After getting a doctorate in engineering at MIT and nearly 2 decades in the semiconductor industry, Sue was ready for the challenge. She laid out a plan to focus on microchips for gaming consoles, data centers, and platforms like virtual reality.
The most important thing for us as we thought about what AMD would look like back in 2014 is what are we good at? And what we are good at is making high-performance microprocessors. And that meant actually saying that we weren't going to do some things. At the time, mobile was a very, very exciting field, but it wasn't what we were fundamentally good at. And so we really focused on our core. And I know that sounds simple, but actually it takes a long time to build a sustainable product roadmap.
That's the thing about the semiconductor industry. Developing a new product takes years. AMD bet that the products it was developing today would be a hit with customers years down the road.
The first and probably the biggest bet is on the future generation of data centers. So it has room for 2 of our servers. We're all generating tons and tons of data every day. Like from all of your devices, we have all of this data. And the truth is, we're actually using just a fraction of it because we don't have enough computing to process all of this. And so we are building the largest and most powerful computers to really process all of that data and make sure that we're making good decisions. And on the other end of this spectrum, we're also very, very heavy into gaming. We cover every aspect of gaming, from PCs to game consoles to cloud gaming. The most important thing for us in selecting, where do we target our products is where do we see the market going. We honestly have to look 5 years out and say, what does the world need from tech in that time frame?
It's a long process and it's a long design cycle, so it takes a lot of anticipation and it takes a lot of skill to hit that mark 5 years before you even know what the market will look like. You have to anticipate that. AMD is in a position right now where it's done a very good job of anticipating where it had to be in performance in competition with Intel and NVIDIA.
Sue's bets have paid off. AMD has taken market share from its top rival Intel, and it's been the top performing stock on the S&P 500 for the last 2 years.
It's a very competitive space. It's a very high stakes, high reward place, and our goal is to continue to make the right bets year after year. So I'm very proud of what we've done over the last 5 years, but I would also say we're just at the very, very beginning of what we can do, and the next 5 years will be more exciting than the last 5.
I'm Bridget Green.
And I'm Kevin Weber. And today we're bringing up Xilinx, the newest addition to AMD.
So good to have you here, finally.
I heard you want to talk about technology. You don't have to twist my arm too hard on that topic.
I have hot gossip.
Are you looking for secrets?
Bring up Bridget. She's dead. You may not like it, but this is what peak performance looks like.
Hi, everyone, and welcome to The Bring Up.
Yeah, in our grand tradition of doing exciting things here at AMD, we've been doing, well, a lot of exciting things here lately. There were all the announcements we made in our product premiere around CES at the beginning of the year.
But also, in even bigger news, AMD has recently acquired Xilinx, and that's really what we wanted to celebrate today. Now, we know many of you are longtime AMD lovers and super familiar with our tech, but if you're not as familiar with the technologies and products that Xilinx brings to the table, well, wouldn't you know it, Kevin? That's what this whole episode is about.
Yes, as a super broad overview, Xilinx is the inventor of the FPGA, a leader in programmable SoCs, and they deliver some of the most dynamic processing technology in the industry.
When I first heard the good news, I definitely was not familiar with what an FPGA was or what adaptive SoCs were, which are some of Xilinx's key technologies.
We're going to do our very best in this episode to explain some of the core technologies that Xilinx makes, what differentiates them, and how they complement AMD's technologies.
Yes, Xilinx offers a massive portfolio of chips with different sizes and levels of performance so that we can offer solutions for highly complex computing needs or simple functions.
Yeah, our Xilinx silicon can be reprogrammed to do different functions after deployment, eliminating the need to update silicon to support future functionality, which I'll deep dive a lot on later in the episode.
Oh boy. But first, luckily, we found out the ultimate expert on this very subject was visiting the Austin campus, Victor Peng, who joins AMD to lead our newly formed adaptive and embedded computing group. And so I sprung at the chance to ask him all of our burning questions about Xilinx.
Let's check it out.
Victor, thank you so much for coming on our show.
I'm delighted. It's great to be here.
I have been ecstatic because this is definitely one of the more exciting times. I can feel like the energy at AMD since I've joined, 5+ years ago. And so I have a lot of things I would like to ask you. I'm going to limit it.
Awesome. Let's get going.
Cool. So I'm going to start at the tippy top because I know that our audience is made up of a lot of folks who are tech enthusiasts and very familiar with AMD products, but may just not be as familiar with Xilinx technology. And so maybe like a Xilinx 101. Can you tell us a little bit about, what is an FPGA and what is an adaptive SoC?
Sure. Xilinx invented the FPGA, and, without getting into the real gory details, you should think about it as it's a semiconductor chip that after it's been manufactured, you can actually still change kind of the functions that it could do and the capabilities that it has. It's a very regular structure for the most part, and you can program it in a way that you're changing the hardware function. And that's really unique compared to other semiconductor products, because once you fabricate it, it's going to do certain features and capabilities that it was designed to do. If it's software programmable, then you can change what it's doing from a software level, but you actually can't change the hardware. Whereas FPGAs, you can actually change the hardware. When you talk about adaptive SoCs, that's also something that we pioneered, and what that is, integrated on a single die, you have a complete multi-core SoC together with that FPGA that you can then modify post-fabrication. And so what that gives you is a tremendous capability because you have software programmable capability and traditional things like CPU cores and maybe other kinds of peripherals and hardware. Tightly integrated is something where you can customize, the hardware to do things like other forms of acceleration, accelerate other kinds of algorithms, and even change, kind of a lot of the interfaces. So the IOs and things that really control, user experiences in the application. So
I feel like there must be so many exciting use cases for that flexibility.
Absolutely. We get used in everything from, for instance, the Mars Land Rover, Perseverance. We have products in outer space. CERN uses us to detect subatomic particles because we're really good at processing at very real-time kind of speeds. But we're also in 5G base stations. We're in the data center doing acceleration, both on the networking side as well as on the compute side. We're in robotics, we're in vision systems, autonomous driving, that's under development, advanced driver systems today. So it's really amazing what our customers do with this flexibility.
All the really cool stuff, space, cars. That's so cool. Yeah. And I also think that there's so many, exciting opportunities combined with AMD products and technologies. So can you give us some insight into how that technology really is complementary to what AMD kind of already has in its product stack?
Absolutely. I mean, so AMD, of course, is a leader in high performance computing and also compelling visualization systems with their GPUs and so forth. And those have been traditionally the workhorses for all the applications in computing today. But what's happening is, with the explosion of data and some of these other new workloads and applications is that, there are more forms of accelerators. And, there's this whole notion of heterogeneous computing, meaning that there'll be different types of engines to do different types of workloads, if you will. So by combining Xilinx and AMD, we will have this amazing portfolio where, we have the leadership in CPUs, we have GPUs, and now we have these FPGAs as well as adaptive SoCs. And so really we have, the proper engine, if you will, for any kind of workload. And also I'd say with these new emerging workloads like AI, it's a tremendous opportunity for us. So yeah, it's couldn't be a more exciting time in the industry, right? And with the broadest product portfolio, amazing talent, I think, between the two companies. So yeah, I'm extremely excited about it.
It's a very interesting time for the companies to be combining as well, because the last 2-3 years has just been an explosion in both the potential, but also the demand for technology. It's been a little bit crazy, like overdrive. Yes. So, at this time, with all of that in mind, what is your vision for the combined AMD and Xilinx, which I realize very big question, but.
Yeah, no, I mean, it's true. It couldn't be a more exciting time to be in the industry. In this world of an intelligent, connected world, the computing is going to be heterogeneous for sure, right? And it's not going to all take place in the data center. I mean, data centers are growing tremendously, but the edge is also going to grow. And AMD and Xilinx together can service all of it. We can service the edge, right? We can service the data center, as well as the communications infrastructure that connects it all together, because Xilinx participates in 5G communications infrastructure, both wired and wireless. So there's very few companies that are positioned the way we are. Not only we talked a lot about technologies, but even I would say from a market perspective and the breadth of markets we can serve.
I've got my seatbelt buckled. I'm ready for wherever this journey is going to take us. And we just can't thank you enough for coming to talk about some of this with our audience.
Great. It's been a pleasure.
Thank
Anytime.
you.
Yep.
Thanks, Bridget. I think that was a super helpful place to start in understanding the products and technologies that Xilinx have brought to AMD. And it's just so nice and concise, too.
I couldn't agree more. But why stop there when we can add a mountain of unsolicited detail and nuance just to highlight how magical and fascinating these technologies really are?
Yes, Kevin's been ranting for weeks about what sets FPGAs apart from microcomputers and microcontrollers and what that really means for you. And I'm actually pretty curious myself, so I say we just let him wander off into the tall grass of explanation and see where it leads us, shall we?
Let's do it. Okay, so part of the problem with explaining what FPGAs are and how they work is that the differences between them and similar hardware is very nuanced. So let's compare them with similar-ish technologies you may already be familiar with: microcomputers and microcontrollers. While a microcomputer, a microcontroller, and an FPGA can sometimes be interchangeable, there are good reasons to pick one over the other for your application. So let's start with maybe the most recognizable of the three, the microcomputer. This is a Raspberry Pi 4th gen, and it's one of the most common microcomputers on the market. What makes this a microcomputer is that it has all the same basic capabilities as a desktop or laptop computer. You can install and run a Linux desktop on it, surf the web, and even play games. What separates this from a standard computer is, first, the size. This is only about as big as a credit card. And second is the inclusion of these two little rows of pins here. These are known as GPIO pins, or General Purpose Input-Output. The adventurous among you can use software to control these pins, make them turn on and off, like to blink an LED, or configure them in special ways to send information to other devices like a temperature sensor or a motor controller. Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of this as a microcomputer with everything except the GPIO pin functionality stripped away. Now, you might ask, why would I use a microcontroller over a microcomputer if microcomputers seem to be a lot more powerful and provide more functionality? The answer to that is exactly because of all the extra complexity that a microcomputer brings. You see, computers that are meant for humans to interact with don't have to be particularly precise with how they relay information to us. For example, if you open a web page in your browser, it doesn't really matter if it takes 1 second to load or 1.5 seconds. You're getting your cat videos either way. Computers take advantage of that, and they use up all the spare time they're not serving you content to take care of all kinds of background tasks like running antivirus software and checking the file system. Some applications, however, like controlling motors, sending video signals, or even controlling factory equipment, will not quietly wait around for a big bulky operating system to decide to get around to sending a command signal. And sometimes you need to be absolutely certain that the processor will take in information and respond with exactly what it needs to, exactly when it needs to. And a signal arriving a microsecond too early or too late can mean the whole system falls apart. So in short, this little device is great at taking in information and responding to it quickly and reliably. Now we move on to FPGAs, the most curious cousin of the bunch. So to talk about this, let's take a step back and look at a pinout diagram of the first two devices we discussed. A pinout diagram is a very useful guide that shows you what each of the pins on a given piece of hardware is designed to do. This is important because if you mix them up, you can damage your hardware, which I've never done, obviously. This is what the pinout of a Raspberry Pi looks like. Now, I know this is a mess if you've never seen one of these before, but I'll walk you through some of the important stuff. You can see some of these pins are just connected to ground, some can provide power to whatever you connect to it, but most have this GPIO label next to them, which means it's one of those special pins you can toggle on and off through software. What's important here is that although the pins are labeled GPIO, they also have these little labels that say things like UART, EEPROM, SPI, and I2C. Those are special protocols you can use to communicate with other devices. So if you have a device that uses SPI that you want to connect to your microcomputer, you have to use these specific pins to connect to it. The microcontroller is the exact same way. It has a few more features like analog inputs and outputs, but you'll notice that these special I/O functions are also all fixed to a specific set of pins. The reason for this is that inside the chip there is a special bit of circuitry explicitly designed to control and manage these interactions. And that circuitry is physically connected to these specific pins. So it wouldn't make sense to try and connect an SPI device to another pin because there's no controller inside the processor to manage it. So here's where it gets wild. Whereas this microcomputer has 26 configurable pins, and the microcontroller we looked at has 28 configurable pins, this FPGA chip here has an outstanding number of pins. Here's a very simplified diagram of the pins that are available on this model of FPGA. First, you can see that there are just a lot of them. But importantly, none of these, with a couple of exceptions, have any extra label associated with them. No SPI or I2C or even a UART. That is, at least until we make one. That's right. Whereas on the microcontroller and microcomputer, I'm limited to however many peripherals I've been given by the manufacturer. With an FPGA, I can make however many I want. I could make a device with 5 SPI buses and USB 3.0, or DVI video output and 50 I2C connections, and then change it all back tomorrow when I need something different. And that's already a pretty good reason to choose an FPGA for your project. But wait, there's more. We talked about the speed
future. Go on. Unleash your imagination.
Today, I'm proud to launch our AMD Ryzen 6000 series mobile processors that deliver leadership performance, battery life, and much, much more. We have so much new technology in the 6000 series. It starts with an updated Zen 3 Plus CPU core optimized specifically to deliver leadership performance per watt for notebooks. And I know this is one the community has been requesting. For the first time, we are bringing RDNA 2 graphics to our notebook APUs. The RDNA 2 graphics upgrade brings a massive increase in performance compared to our prior generation, and is the same graphics IP powering the latest generation consoles, high-end gaming PCs, and Teslas. For increased performance and greater power efficiency, Ryzen 6000 APUs are built using TSMC's 6nm process technology. And to enable our partners to build the ultimate notebooks, we paired our leadership mobile processor with the latest in memory and connectivity technologies, including low-power DDR5 memory, USB 4, and Wi-Fi 6E. And the performance is just amazing. Ryzen 6000 powered notebooks feature our fastest Ryzen processor ever. With boost speeds up to 5 gigahertz, we're delivering an average of 1.3x faster performance compared to the 5000 series across a wide range of compute-intensive benchmarks. And with an RDNA 2 graphics built in, it's a massive leap, double the performance.
Today, we are introducing the AMD Radeon RX 6000S. This series is specifically built for thin and light gaming laptops. These GPUs are optimized for power efficiency and enhanced with new performance per watt technologies, pushing high performance in the most compact devices. 20% thinner, weighing less than 4.5 pounds. Last year, we introduced the Radeon RX 6000M series lineup for traditional gaming laptops. This year, we're growing the offerings. We are introducing faster performance graphics solutions with faster memory and higher game clocks. And we are also expanding the reach of the models in this series with a new discrete GPU. This new GPU is built on 6nm technology designed for low power gaming. Today, we are announcing a whole lot of new AMD Radeon mobile GPUs to bring the best experience to every gaming laptop. For our desktop gamers, today we are introducing a new 6nm GPU that brings RDNA 2 graphics to even more gamers. The AMD Radeon RX 6500 XT. This graphics card has the fastest sustained GPU clock rates ever at over 2.6 gigahertz, includes 16 hardware ray accelerators, 16 megabytes of Infinity cache, and supports the full suite of Adrenalin software features.
With AMD Advantage, we're working to raise the bar of what defines a great gaming laptop experience. We've partnered with OEMs to design best-in-class gaming laptops by providing them with the design framework that ensures the premium performance delivered by our Ryzen CPUs and our Radeon GPUs is felt through all aspects of the laptop's experience. There are 3 key things to know about AMD Advantage laptops. First, we've amplified their gaming performance by optimizing AMD's CPUs and AMD's GPUs with our smart technologies. Second, they come equipped with high refresh rate and premium quality FreeSync displays. And third, we focus on each model's cooling, acoustics, sleep and resume times, battery life performance, and hundreds of other design decisions, making them truly built to game.
Today, I'm excited to announce that we are bringing 3D chiplet technology to market in our Ryzen CPUs. The Ryzen 7 5800 X3D is our first Ryzen processor with 3D V-Cache technology. It features 8 cores, 16 threads, up to 4.5 gigahertz boost, and a large 64 megabytes of 3D cache to go with the 32 megabytes of 2D cache. The 5800X3D drops right into existing AM4 motherboards and delivers a significant boost in gaming performance. Looking at the performance in 1080p gaming, we see a significant increase in performance in many games with the 96 megabytes of L3 cache. Across the entire suite, it delivers an average of 15% more frames per second than our previous fastest gaming processor, the Ryzen 9 5900X. And when compared to the competition's best gaming processor, we're proud to say the combination of the Zen 3 core and AMD 3D V-Cache once again makes Ryzen the fastest gaming CPU in the world. Zen 4 is the next big step. Built on 5nm process technology, Zen 4 will extend our performance and performance per watt leadership in desktop PCs. For the very first time, let me show you our next generation Ryzen processor. This is the all-new 5nm AMD Ryzen 7000 desktop processor. It's currently running in our labs, and the performance looks incredible. And just as we did with Ryzen 6000 mobile, our next-gen Ryzen desktop processors will be paired with next-generation memory and connectivity technologies to deliver the ultimate experience. In addition to the new Ryzen 7000 CPUs, we're introducing an all-new AM5 platform. AM5 features an LGA socket and includes a support for PCI Express Gen 5, DDR5 memory, and much, much more. Now let's see Ryzen 7000 and Zen 4 in action for the first time. What you're seeing is 1080p gameplay footage of Halo Infinite running on a pre-production 5nm Ryzen processor. To give you an idea of why we're so excited about Zen 4, you can see beautiful gameplay at very high frame rates. And I can tell you that all of those Zen 4 cores are running at 5 gigahertz during this demo. This is the next generation of gaming and PC experiences from AMD.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akida Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akida chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akida development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akida.
takes a long time to build a sustainable product roadmap.
That's the thing about the semiconductor industry. Developing a new product takes years. AMD bet that the products it was developing today would be a hit with customers years down the road.
The first and probably the biggest bet is on the future generation of data centers. So it has room for 2 of our servers. We're all generating tons and tons of data every day. Like from all of your devices, we have all of this data. And the truth is, we're actually using just a fraction of it because we don't have enough computing to process all of this. And so we are building the largest and most powerful computers to really process all of that data and make sure that we're making good decisions. And on the other end of this spectrum, we're also very, very heavy into gaming. We cover every aspect of gaming, from PCs to game consoles to cloud gaming. The most important thing for us in selecting, where do we target our products is where do we see the market going? We honestly have to look 5 years out and say, what does the world need from tech in that time frame?
It's a long process and it's a long design cycle, so it takes a lot of anticipation and it takes a lot of skill to hit that mark 5 years before you even know what the market will look like. You have to anticipate that. AMD is in a position right now where it's done a very good job of anticipating where it had to be in performance in competition with Intel and NVIDIA.
Sue's bets have paid off. AMD has taken market share from its top rival Intel, and it's been the top performing stock on the S&P 500 for the last 2 years.
It's a very competitive space. It's a very high stakes, high reward place, and our goal is to continue to make the right bets year after year. So I'm very proud of what we've done over the last 5 years, but I would also say we're just at the very, very beginning of what we can do, and the next 5 years will be more exciting than the last 5.
I'm Bridget Green.
And I'm Kevin Weber, and today we're bringing up Xilinx, the newest addition to AMD.
So good to have you here, finally.
I heard you want to talk about technology. You don't have to twist my arm too hard on that topic.
I have hot gossip.
Are you looking for secrets?
Bring up Bridget. She's dead.
You may not like it, but this is what peak performance looks like.
Hi, everyone, and welcome to The Bring Up.
Yeah, in our grand tradition of doing exciting things here at AMD, we've been doing, well, a lot of exciting things here lately. There were all the announcements we made in our product premiere around CES at the beginning of the year.
But also, in even bigger news, AMD has recently acquired Xilinx, and that's really what we wanted to celebrate today. Now, we know many of you are longtime AMD lovers and super familiar with our tech, but if you're not as familiar with the technologies and products that Xilinx brings to the table, well, wouldn't you know it, Kevin? That's what this whole episode is about.
Yes, as a super broad overview, Xilinx is the inventor of the FPGA, a leader in programmable SoCs, and they deliver some of the most dynamic processing technology in the industry.
When I first heard the good news, I definitely was not familiar with what an FPGA was or what adaptive SoCs were, which are some of Xilinx's key technologies. So that we can offer solutions for highly complex computing needs or simple functions.
Yeah, our Xilinx silicon can be reprogrammed to do different functions after deployment, eliminating the need to update silicon to support future functionality, which I'll deep dive a lot on later in the episode.
Oh boy. But first, luckily, we found out the ultimate expert on this very subject was visiting the Austin campus, Victor Peng, who joins AMD to lead our newly formed adaptive and embedded computing group. And so I sprung at the chance to ask him all of our burning questions about Xilinx.
Let's check it out.
Victor, thank you so much for coming on our show.
I'm delighted. It's great to be here.
I have been ecstatic because this is definitely one of the more exciting times. I can feel like the energy at AMD since I've joined, 5+ years ago. And so I have a lot of things I would like to ask you. I'm going to limit it.
Awesome. Let's get going.
Cool. So I'm going to start at the tippy top because I know that our audience is made up of a lot of folks who are tech enthusiast and very familiar with AMD products, but may just not be as familiar with Xilinx technology. And so maybe like a Xilinx 101, can you tell us a little bit about, like what is an FPGA and what is an adaptive SoC?
Sure. Xilinx invented the FPGA, and without getting into the real gory details, you should think about it as it's a semiconductor chip that after it's been manufactured, you can actually still change kind of the functions that it could do and the capabilities that it has. It's a very regular structure for the most part, and you can program it in a way that you're changing the hardware function. And that's really unique compared to other semiconductor products, because once you fabricate it, it's going to do certain features and capabilities that it was designed to do. If it's software programmable, then you can change what it's doing from a software level, but you actually can't change the hardware. Whereas FPGAs, you can actually change the hardware. When you talk about adaptive SoCs, that's also something that we pioneered, and what that is, integrated on a single die, you have a complete multi-core SoC together with that FPGA that you can then modify post-fabrication. And so what that gives you is a tremendous capability because you have software programmable capability and traditional things like CPU cores and maybe other kinds of peripherals and hardware. Tightly integrated is something where you can customize, the hardware to do things like other forms of acceleration, accelerate other kinds of algorithms, and even change, kind of a lot of the interfaces. So the IOs and things that really control, user experiences in the application. So
I feel like there must be so many exciting use cases for that flexibility.
Absolutely. We get used in everything from, for instance, the Mars Land Rover, Perseverance. We have products in outer space. CERN uses us to detect subatomic particles because we're really good at processing at very real-time kind of speeds. But we're also in 5G base stations. We're in the data center doing acceleration, both on the networking side as well as on the compute side. We're in robotics. We're in vision systems, autonomous driving that's under development, advanced driver systems today. So it's really amazing what our customers do with this flexibility.
All the really cool stuff. Space, cars. That's so cool. Yeah. And I also think that there's so many, exciting opportunities combined with AMD products and technologies. So can you give us some insight into how that technology really is complementary to what AMD kind of already has in its product stack?
Absolutely. I mean, so AMD, of course, is a leader in high performance computing and also compelling visualization systems with their GPUs and so forth. And those have been traditionally the workhorses for all the applications and computing today. But what's happening is, with the explosion of data and some of these other new workloads and applications is that, there are more forms of accelerators. And, there's this whole notion of heterogeneous computing, meaning that there'll be different types of engines to do different types of workloads, if you will. So by combining Xilinx and AMD, we will have this amazing portfolio where, we have the leadership in CPUs, we have GPUs, and now we have these FPGAs as well as adaptive SoCs. And so really we have, the proper engine, if you will, for any kind of workload. And also I'd say with these new emerging workloads like AI, it's a tremendous opportunity for us. So yeah, it's couldn't be a more exciting time in the industry, right? And with the broadest product portfolio, amazing talent, I think, between the two companies. So yeah, I'm extremely excited about it.
It's a very interesting time for the companies to be combining as well, because the last 2-3 years has just been an explosion in both the potential, but also the demand for technology. It's been a little bit crazy, like overdrive. Yes. So, at this time, with all of that in mind, what is your vision for the combined AMD and Xilinx, which I realize very big question, but
yeah, no, I mean, it's true. It couldn't be a more exciting time to be in the industry. In this world of an intelligent, connected world, the computing is going to be heterogeneous for sure, right? And it's not going to all take place in the data center. I mean, data centers are growing tremendously, but the edge is also going to grow. And AMD and Xilinx together can service all of it. We can service the edge, right? We can service the data center. as well as the communications infrastructure that connects it all together, because Xilinx participates in 5G communications infrastructure, both wired and wireless. So there's very few companies that are positioned the way we are. Not only we talked a lot about technologies, but even I would say from a market perspective and the breadth of markets we can serve.
I've got my seatbelt buckled. I'm ready for wherever this journey is going to take us. And we just can't thank you enough for coming and talk about some of this with our audience.
Great. It's been a pleasure.
Thank
Anytime.
you.
Yep.
Thanks, Bridget. I think that was a super helpful place to start in understanding the products and technologies that Xilinx have brought to AMD, and it was just so nice and concise, too.
I couldn't agree more. But why stop there when we can add a mountain of unsolicited detail and nuance just to highlight how magical and fascinating these technologies really are?
Yes, Kevin's been ranting for weeks about what sets FPGAs apart from microcomputers and microcontrollers and what that really means for you. And I'm actually pretty curious myself, so I say we just let him wander off into the tall grass of explanation and see where it leads us, shall we?
Let's do it. Okay, so part of the problem with explaining what FPGAs are and how they work is that the differences between them and similar hardware is very nuanced. So let's compare them with similar-ish technologies you may already be familiar with: microcomputers and microcontrollers. While a microcomputer, a microcontroller, and an FPGA can sometimes be interchangeable, there are good reasons to pick one over the other for your application. So let's start with maybe the most recognizable of the three, the microcomputer. This is a Raspberry Pi 4th gen, and it's one of the most common microcomputers on the market. What makes this a microcomputer is that it has all the same basic capabilities as a desktop or laptop computer. You can install and run a Linux desktop on it, surf the web, and even play games. What separates this from a standard computer is, first, the size. This is only about as big as a credit card. And second is the inclusion of these two little rows of pins here. These are known as GPIO pins, or General Purpose Input-Output. The adventurous among you can use software to control these pins, make them turn on and off, like to blink an LED, or configure them in special ways to send information to other devices like a temperature sensor or a motor controller. Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of this as a microcomputer with everything except the GPIO pin functionality stripped away. Now, you might ask, why would I use a microcontroller over a microcomputer if microcomputers seem to be a lot more powerful and provide more functionality? The answer to that is exactly because of all the extra complexity that a microcomputer brings. You see, computers that are meant for humans to interact with don't have to be particularly precise with how they relay information to us. For example, if you open a web page in your browser, it doesn't really matter if it takes 1 second to load or 1.5 seconds. You're getting your cat videos either way. Computers take advantage of that, and they use up all the spare time they're not serving you content to take care of all kinds of background tasks like running antivirus software and checking the file system. Some applications, however, like controlling motors, sending video signals, or even controlling factory equipment, will not quietly wait around for a big bulky operating system to decide to get around to sending a command signal. And sometimes you need to be absolutely certain that the processor will take in information and respond with exactly what it needs to, exactly when it needs to. And a signal arriving a microsecond too early or too late can mean the whole system falls apart. So in short, this little device is great at taking in information and responding to it quickly and reliably. Now we move on to FPGAs, the most curious cousin of the bunch. So to talk about this, let's take a step back and look at a pinout diagram of the first two devices we discussed. A pinout diagram is a very useful guide that shows you what each of the pins on a given piece of hardware is designed to do. This is important because if you mix them up, you can damage your hardware, which I've never done, obviously. This is what the pinout of a Raspberry Pi looks like. Now, I know this is a mess if you've never seen one of these before, but I'll walk you through some of the important stuff. You can see some of these pins are just connected to ground, some can provide power to whatever you connect to it, but most have this GPIO label next to them, which means it's one of those special pins you can toggle on and off through software. What's important here is that although the pins are labeled GPIO, they also have these little labels that say things like UART, EEPROM, SPI, and I2C. Those are special protocols you can use to communicate with other devices. So if you have a device that uses SPI that you want to connect to your microcomputer, you have to use these specific pins to connect to it. The microcontroller is the exact same way. It has a few more features like analog inputs and outputs, but you'll notice that these special I/O functions are also all fixed to a specific set of pins. The reason for this is that inside the chip there is a special bit of circuitry explicitly designed to control and manage these interactions. And that circuitry is physically connected to these specific pins. So it wouldn't make sense to try and connect an SPI device to another pin because there's no controller inside the processor to manage it. So here's where it gets wild. Whereas this microcomputer has 26 configurable pins, and the microcontroller we looked at has 28 configurable pins, this FPGA chip here has an outstanding number of pins. Here's a very simplified diagram of the pins that are available on this model of FPGA. First, you can see that there are just a lot of them. But importantly, none of these, with a couple of exceptions, have any extra label associated with them. No SPI or I2C or even a UART. That is, at least until we make one. That's right. Whereas on the microcontroller and microcomputer, I'm limited to however many peripherals I've been given by the manufacturer. With an FPGA, I can make however many I want. I can make a device with 5 SPI buses and USB 3.0, or DVI video output and 50 I2C connections, and then change it all back tomorrow when I need something different. And that's already a pretty good reason to choose an FPGA for your project. But wait, there's more. We talked about the speed at which each device can respond to signals, but FPGAs take it to a whole new level. That's right, a microcomputer will take in a signal and provide a response sort of whenever it gets around to it. It may be right away, but it also might be a few hundred cycles from now. Microcontrollers respond quickly and reliably, but even in the best case scenario, it's still possible for these to take a few cycles to read a signal and respond. That's not bad, but it could be better. Enter FPGAs, which if properly configured can take in and respond to a signal instantly, which means they can do math and process signals extremely quickly, making them ideal for real-time applications. Okay, and with that, we've come to the end of this edition of In the Weeds with Weber. It's time for me to get back to civilization. Thanks, Kevin.
Well, that was a lot, but I actually have a much better understanding now. So to this deep dive, I say, jump right in. The water's fine.
Well, it was truly my pleasure.
I know it was. We're very excited to keep you guys updated with more Xilinx goodness in the future, but for now, that's all we have for you on this episode of The Bring Up, and so we hope to see you very soon with more AMD news.
Yes, if you don't want to miss any future episodes, all you got to do is subscribe to the AMD YouTube channel and hit that little bell icon. We'll see you next time.
Thanks for watching.
Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of a microcomputer as everything with except for the GPIO pin functionality stripped away. Now, I might ask, why use a microcontroller over? So, the answer to that is because exactly it's a lot of leaves, Bridget.
I think it's looking really good.
Okay, does it feel like they're maybe in camera or something though? Is it
No,
is it good?
We see you.
Okay.
For sure.
Okay.
It's just the leaves are a nice accent and they're giving you a lot of like color bounce.
Yeah, I feel like the yeah, the lighting is maybe being affected.
Let's see this one.
Okay, yeah.
Just a little bit like
okay. Yep, no, that's good. No, yep, that's probably good.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future, They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with a breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
Today, I'm proud to launch our AMD Ryzen 6000 series mobile processors that deliver leadership performance, battery life, and much, much more. We have so much new technology in the 6000 series. It starts with an updated Zen 3 Plus CPU core optimized specifically to deliver leadership performance per watt for notebooks. And I know this is one the community has been requesting. For the first time, we are bringing RDNA 2 graphics to our notebook APUs. The RDNA 2 graphics upgrade brings a massive increase in performance compared to our prior generation, and is the same graphics IP powering the latest generation consoles, high-end gaming PCs, and Teslas. For increased performance and greater power efficiency, Ryzen 6000 APUs are built using TSMC's 6nm process technology. And to enable our partners to build the ultimate notebooks, we paired our leadership mobile processor with the latest in memory and connectivity technologies, including low-power DDR5 memory, USB 4, and Wi-Fi 6E. And the performance is just amazing. Ryzen 6000 powered notebooks feature our fastest Ryzen processor ever. With boost speeds up to 5 gigahertz, we're delivering an average of 1.3x faster performance compared to the 5000 series across a wide range of compute-intensive benchmarks. And with an RDNA 2 graphics built in, it's a massive leap, double the performance.
Today, we are introducing the AMD Radeon RX 6000S. This series is specifically built for thin and light gaming laptops. These GPUs are optimized for power efficiency and enhanced with new performance per watt technologies, pushing high performance in the most compact devices. 20% thinner, weighing less than 4.5 pounds. Last year, we introduced the Radeon RX 6000M series lineup for traditional gaming laptops. This year, we're growing the offerings. We are introducing faster performance graphics solutions with faster memory and higher game clocks. And we are also expanding the reach of the models in this series with a new discrete GPU. This new GPU is built on 6nm technology designed for low-power gaming. Today, we are announcing a whole lot of new AMD Radeon mobile GPUs to bring the best experience to every gaming laptop. For our desktop gamers, today we are introducing a new 6nm GPU that brings RDNA 2 graphics to even more gamers. The AMD Radeon RX 6500 XT. This graphics card has the fastest sustained GPU clock rates ever at over 2.6 gigahertz, includes 16 hardware ray accelerators, 16 megabytes of Infinity Cache, and supports the full suite of Adrenalin software features.
With AMD Advantage, we're working to raise the bar of what defines a great gaming laptop experience. We've partnered with OEMs to design best-in-class gaming laptops by providing them with the design framework that ensures the premium performance delivered by our Ryzen CPUs and our Radeon GPUs is felt through all aspects of the laptop's experience. There are 3 key things to know about AMD Advantage laptops. First, we've amplified their gaming performance by optimizing AMD's CPUs and AMD's GPUs with our smart technologies. Second, they come equipped with high refresh rate and premium quality FreeSync displays. And third, we focus on each model's cooling, acoustics, sleep and resume times, battery life performance, and hundreds of other design decisions, making them truly built to game.
Today, I'm excited to announce that we are bringing 3D chiplet technology to market in our Ryzen CPUs. The Ryzen 7 5800X3D is our first Ryzen processor with 3D V-Cache technology. It features 8 cores, 16 threads, up to 4.5 gigahertz boost, and a large 64 megabytes of 3D cache to go with the 32 megabytes of 2D cache. The 5800X3D drops right into existing AM4 motherboards and delivers a significant boost in gaming performance. Looking at the performance in 1080p gaming, we see a significant increase in performance in many games with the 96 megabytes of L3 cache. Across the entire suite, it delivers an average of 15% more frames per second than our previous fastest gaming processor, the Ryzen 9 5900X. And when compared to the competition's best gaming processor, we're proud to say the combination of the Zen 3 core and AMD 3D V-Cache once again makes Ryzen the fastest gaming CPU in the world. Zen 4 is the next big step. Built on 5nm process technology, Zen 4 will extend our performance and performance per watt leadership in desktop PCs. For the very first time, let me show you our next generation Ryzen processor. This is the all-new 5nm AMD Ryzen 7000 desktop processor. It's currently running in our labs, and the performance looks incredible. And just as we did with Ryzen 6000 mobile, our next-gen Ryzen desktop processors will be paired with next-generation memory and connectivity technologies to deliver the ultimate experience. In addition to the new Ryzen 7000 CPUs, we're introducing an all-new AM5 platform. AM5 features an LGA socket and includes a support for PCI Express Gen 5, DDR5 memory, and much, much more. Now let's see Ryzen 7000 and Zen 4 in action for the first time. What you're seeing is 1080p gameplay footage of Halo Infinite running on a pre-production 5nm Ryzen processor. To give you an idea of why we're so excited about Zen 4, you can see beautiful gameplay at very high frame rates. And I can tell you that all of those Zen 4 cores are running at 5 gigahertz during this demo. This is the next generation of gaming and PC experiences from AMD.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akida Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akida chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akida development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akida.
5 years ago, Advanced Micro Devices was in trouble.
Ooh, AMD, Advanced Micro Devices, very painful day for this stock.
AMD it's still surviving, but surviving. Not by a lot.
The chipmaker was bleeding money, drowning in debt, facing a possible bankruptcy, and its stock was trading around $2 a share. Lisa Su then became the company's first female CEO, faced with leading a daunting turnaround.
I was really excited to become CEO, but of course, a little bit scared like anyone taking on a new job.
After getting a doctorate in engineering at MIT and nearly 2 decades in the semiconductor industry, Su was ready for the challenge. She laid out a plan to focus on microchips for gaming consoles, data centers, and platforms like virtual reality.
The most important thing for us as we thought about what AMD would look like back in 2014 is what are we good at? And what we are good at is making high-performance microprocessors. And that meant actually saying that we weren't going to do some things. At the time, mobile was a very, very exciting field, but it wasn't what we were fundamentally good at. And so we really focused on our core. And I know that sounds simple, but actually it takes a long time to build a sustainable product roadmap.
That's the thing about the semiconductor industry. Developing a new product takes years. AMD bet that the products it was developing today would be a hit with customers years down the road.
The first and probably the biggest bet is on the future generation of data centers. So it has room for 2 of our servers. We're all generating tons and tons of data every day. Like from all of your devices, we have all of this data. And the truth is, we're actually using just a fraction of it because we don't have enough computing to process all of this. And so we are building the largest and most powerful computers to really process all of that data and make sure that we're making good decisions. And on the other end of this spectrum, we're also very, very heavy into gaming. We cover every aspect of gaming, from PCs to game consoles to cloud gaming. The most important thing for us in selecting, where do we target our products is where do we see the market going. We honestly have to look 5 years out and say, what does the world need from tech in that time frame?
It's a long process and it's a long design cycle, so it takes a lot of anticipation and it takes a lot of skill to hit that mark 5 years before you even know what the market will look like. You have to anticipate that. AMD is in a position right now where it's done a very good job of anticipating where it had to be in performance in competition with Intel and NVIDIA.
Su's bets have paid off. AMD has taken market share from its top rival Intel, and it's been the top performing stock on the S&P 500 for the last 2 years.
It's a very competitive space. It's a very high stakes, high reward place, and our goal is to continue to make the right bets year after year. So I'm very proud of what we've done over the last 5 years, but I would also say we're just at the very, very beginning of what we can do, and the next 5 years will be more exciting than the last 5.
I'm Bridget Green.
And I'm Kevin Weber, and today we're bringing up Xilinx, the newest addition to AMD.
So good to have you here, finally.
I heard you want to talk about technology. You don't have to twist my arm too hard on that topic.
I have hot gossip.
Are you looking for secrets?
Bring up Bridget. She's dead. You may not like it, but this is what peak performance looks like.
Hi, everyone, and welcome to The Bring Up.
Yeah, in our grand tradition of doing exciting things here at AMD, we've been doing, well, a lot of exciting things here lately. There were all the announcements we made in our product premiere around CES at the beginning of the year.
But also, in even bigger news, AMD has recently acquired Xilinx, and that's really what we wanted to celebrate today. Now, we know many of you are longtime AMD lovers and super familiar with our tech, but if you're not as familiar with the technologies and products that Xilinx brings to the table, well, wouldn't you know it, Kevin? That's what this whole episode is about.
Yes, as a super broad overview, Xilinx is the inventor of the FPGA, a leader in programmable SoCs, and they deliver some of the most dynamic processing technology in the industry.
When I first heard the good news, I definitely was not familiar with what an FPGA was or what adaptive SoCs were, which are some of Xilinx's key technologies.
We're going to do our very best in this episode to explain some of the core technologies that Xilinx makes, what differentiates them, and how they complement AMD's technologies.
Yes, Xilinx offers a massive portfolio of chips with different sizes and levels of performance so that we can offer solutions for highly complex computing needs or simple functions.
Yeah, our Xilinx silicon can be reprogrammed to do different functions after deployment, eliminating the need to update silicon to support future functionality, which I'll deep dive a lot on later in the episode.
Oh boy. But first, luckily, we found out the ultimate expert on this very subject was visiting the Austin campus, Victor Peng, who joins AMD to lead our newly formed adaptive and embedded computing group. And so I sprung at the chance to ask him all of our burning questions about Xilinx.
Let's check it out.
Victor, thank you so much for coming on our show.
I'm delighted. It's great to be here.
I have been ecstatic because this is definitely one of the more exciting times. I can feel like the energy at AMD since I've joined, 5+ years ago. And so I have a lot of things I would like to ask you. I'm going to limit it.
Awesome. Let's get going.
Cool. So I'm going to start at the tippy top because I know that our audience is made up of a lot of folks who are tech enthusiasts and very familiar with AMD products, but may just not be as familiar with Xilinx technology. And so maybe like a Xilinx 101. Can you tell us a little bit about, what is an FPGA and what is an adaptive SoC?
Sure. Xilinx invented the FPGA, and, without getting into the real gory details, you should think about it as it's a semiconductor chip that after it's been manufactured, you can actually still change kind of the functions that it could do and the capabilities that it has. It's a very regular structure for the most part, and you can program it in a way that you're changing the hardware function. And that's really unique compared to other semiconductor products, because once you fabricate it, it's going to do certain features and capabilities that it was designed to do. If it's software programmable, then you can change what it's doing from a software level, but you actually can't change the hardware. Whereas FPGAs, you can actually change the hardware. When you talk about adaptive SoCs, that's also something that we pioneered, and what that is, integrated on a single die, you have a complete multi-core SoC together with that FPGA that you can then modify post-fabrication. And so what that gives you is tremendous capability because you have software programmable capability and traditional things like CPU cores and maybe other kinds of peripherals and hardware. Tightly integrated is something where you can customize, the hardware to do things like other forms of acceleration, accelerate other kinds of algorithms, and even change, kind of a lot of the interfaces. So the IOs and things that really control, user experiences in the application. So
I feel like there must be so many exciting use cases for that flexibility.
Absolutely. We get used in everything from, for instance, the Mars Land Rover, Perseverance. We have products in outer space. CERN uses us to detect subatomic particles because we're really good at processing at very real-time kind of speeds. But we're also in 5G base stations. We're in the data center doing acceleration, both on the networking side as well as on the compute side. We're in robotics. We're in vision systems, autonomous driving that's under development, advanced driver systems today. So it's really amazing what our customers do with this flexibility.
All the really cool stuff. Space, cars. That's so cool. Yeah. And I also think that there's so many, exciting opportunities combined with AMD products and technologies. So can you give us some insight into how that technology really is complementary to what AMD kind of already has in its product stack?
Absolutely. I mean, so AMD, of course, is a leader in high performance computing and also compelling visualization systems with their GPUs and so forth. And those have been traditionally the workhorses for all the applications in computing today. But what's happening is, with the explosion of data and some of these other new workloads and applications is that, there are more forms of accelerators. And, there's this whole notion of heterogeneous computing, meaning that there'll be different types of engines to do different types of workloads, if you will. So by combining Xilinx and AMD, we will have this amazing portfolio where, we have the leadership in CPUs, we have GPUs, and now we have these FPGAs as well as adaptive SoCs. And so really we have, the proper engine, if you will, for only any kind of workload, and also I'd say with these new emerging workloads like AI, it's a tremendous opportunity for us. So yeah, it's couldn't be a more exciting time in the industry, right? And with the broadest product portfolio, amazing talent, I think, between the two companies. So yeah, I'm extremely excited about it.
It's a very interesting time for the companies to be combining as well, because the last 2-3 years has just been an explosion in both the potential, but also the demand for technology. It's been a little bit crazy, like overdrive. Yes. So, at this time, with all of that in mind, what is your vision for the combined AMD and Xilinx, which I realize very big question, but.
Yeah, no, I mean, it's true. It couldn't be a more exciting time to be in the industry. In this world of an intelligent, connected world, the computing is going to be heterogeneous for sure, right? And it's not going to all take place in the data center. I mean, data centers are growing tremendously, but the edge is also going to grow. And AMD and Xilinx together can service all of it. We can service the edge, right? We can service the data center, as well as the communications infrastructure that connects it all together, because Xilinx participates in 5G communications infrastructure, both wired and wireless. So there's very few companies that are positioned the way we are. Not only we talked a lot about technologies, but even I would say from a market perspective and the breadth of markets we can serve.
I've got my seatbelt buckled. I'm ready for wherever this journey is going to take us. And we just can't thank you enough for coming and talk about some of this with our audience.
Great. It's been a pleasure.
Thank
Anytime.
you.
Yep.
Thanks, Bridget. I think that was a super helpful place to start in understanding the products and technologies that Xilinx have brought to AMD, and it's just so nice and concise, too.
I couldn't agree more. But why stop there when we can add a mountain of unsolicited detail and nuance just to highlight how magical and fascinating these technologies really are?
Yes, Kevin's been ranting for weeks about what sets FPGAs apart from microcomputers and microcontrollers and what that really means for you. And I'm actually pretty curious myself, so I say we just let him wander off into the tall grass of explanation and see where it leads us, shall we?
Let's do it. Okay, so part of the problem with explaining what FPGAs are and how they work is that the differences between them and similar hardware is very nuanced. So let's compare them with similar-ish technologies you may already be familiar with: microcomputers and microcontrollers. While a microcomputer, a microcontroller, and an FPGA can sometimes be interchangeable, there are good reasons to pick one over the other for your application. So let's start with maybe the most recognizable of the three, the microcomputer. This is a Raspberry Pi 4th gen, and it's one of the most common microcomputers on the market. What makes this a microcomputer is that it has all the same basic capabilities as a desktop or laptop computer. You can install and run a Linux desktop on it, surf the web, and even play games. What separates this from a standard computer is, first, the size. This is only about as big as a credit card. And second is the inclusion of these two little rows of pins here. These are known as GPIO pins, or General Purpose Input-Output. The adventurous among you can use software to control these pins, make them turn on and off, like to blink an LED, or configure them in special ways to send information to other devices like a temperature sensor or a motor controller. Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of this as a microcomputer with everything except the GPIO pin functionality stripped away. Now, you might ask, why would I use a microcontroller over a microcomputer if microcomputers seem to be a lot more powerful and provide more functionality? The answer to that is exactly because of all the extra complexity that a microcomputer brings. You see, computers that are meant for humans to interact with don't have to be particularly precise with how they relay information to us. For example, if you open a web page in your browser, it doesn't really matter if it takes 1 second to load or 1.5 seconds. You're getting your cat videos either way. Computers take advantage of that, and they use up all the spare time they're not serving you content to take care of all kinds of background tasks like running antivirus software and checking the file system. Some applications, however, like controlling motors, sending video signals, or even controlling factory equipment, will not quietly wait around for a big bulky operating system to decide to get around to sending a command signal. And sometimes you need to be absolutely certain that the processor will take in information and respond with exactly what it needs to, exactly when it needs to. and a signal arriving a microsecond too early or too late can mean the whole system falls apart. So in short, this little device is great at taking in information and responding to it quickly and reliably. Now we move on to FPGAs, the most curious cousin of the bunch. So to talk about this, let's take a step back and look at a pinout diagram of the first two devices we discussed. A pinout diagram is a very useful guide that shows you what each of the pins on a given piece of hardware is designed to do. This is important because if you mix them up, you can damage your hardware, which I've never done, obviously. This is what the pinout of a Raspberry Pi looks like. Now, I know this is a mess if you've never seen one of these before, but I'll walk you through some of the important stuff. You can see some of these pins are just connected to ground, some can provide power to whatever you connect to it, but most have this GPIO label next to them, which means it's one of those special pins you can toggle on and off through software. What's important here is that although the pins are labeled GPIO, they also have these little labels that say things like UART, EEPROM, SPI, and I2C. Those are special protocols you can use to communicate with other devices. So if you have a device that uses SPI that you want to connect to your microcomputer, you have to use these specific pins to connect to it. The microcontroller is the exact same way. It has a few more features like analog inputs and outputs, but you'll notice that these special I/O functions are also all fixed to a specific set of pins. The reason for this is that inside the chip there is a special bit of circuitry explicitly designed to control and manage these interactions. And that circuitry is physically connected to these specific pins. So it wouldn't make sense to try and connect an SPI device to another pin because there's no controller inside the processor to manage it. So here's where it gets wild. Whereas this microcomputer has 26 configurable pins, and the microcontroller we looked at has 28 configurable pins, this FPGA chip here has an outstanding number of pins. Here is a very simplified diagram of the pins that are available on this model of FPGA. First, you can see that there are just a lot of them. But importantly, none of these, with a couple of exceptions, have any extra label associated with them. No SPI or I2C or even a UART. That is, at least until we make one. That's right. Whereas on the microcontroller and microcomputer, I'm limited to however many peripherals I've been given by the manufacturer. With an FPGA, I can make however many I want. I could make a device with 5 SPI buses and USB 3.0, or DVI video output and 50 I2C connections, and then change it all back tomorrow when I need something different. And that's already a pretty good reason to choose an FPGA for your project. But wait, there's more. We talked about the speed at which each device can respond to signals, but FPGAs take it to a whole new level. That's right, a microcomputer will take in a signal and provide a response sort of whenever it gets around to it. It may be right away, but it also might be a few hundred cycles from now. Microcontrollers respond quickly and reliably, but even in the best case scenario, it's still possible for these to take a few cycles to read a signal and respond. That's not bad, but it could be better. Enter FPGAs, which if properly configured can take in and respond to a signal instantly, which means they can do math and process signals extremely quickly, making them ideal for real-time applications. Okay, and with that, we've come to the end of this edition of In the Weeds with Weber. It's time for me to get back to civilization. Thanks, Kevin.
Well, that was a lot, but I actually have a much better understanding now. So to this deep dive, I say, jump right in. The water's fine.
Well, it was truly my pleasure.
I know it was. We're very excited to keep you guys updated with more Xilinx goodness in the future, but for now, that's all we have for you on this episode of The Bring Up, and so we hope to see you very soon with more AMD news.
Yes, if you don't want to miss any future episodes, all you got to do is subscribe to the AMD YouTube channel and hit that little bell icon. We'll see you next time.
Thanks for watching.
Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of a microcomputer as everything with except for the GPIO pin functionality stripped away. Now, I might ask, why use a microcontroller over? So, the answer to that is because exactly it's a lot of leaves, Bridget.
I think it's looking really good.
Okay, does it feel like they're maybe in camera or something though, or is it
No,
is it good?
We see you.
Okay.
For sure.
Okay.
It's just the leaves are a nice accent and they're giving you a lot of like color bounce.
Yeah, I feel like the yeah, the lighting is maybe being affected.
Let's see this one.
Okay, yeah.
Just a little bit like
okay. Yep, no, that's good. No, yep, that's probably good.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
Today, I'm proud to launch our AMD Ryzen 6000 series mobile processors that deliver leadership performance, battery life, and much, much more. We have so much new technology in the 6000 series. It starts with an updated Zen 3 Plus CPU core optimized specifically to deliver leadership performance per watt for notebooks. And I know this is one the community has been requesting. For the first time, we are bringing RDNA 2 graphics to our notebook APUs. The RDNA 2 graphics upgrade brings a massive increase in performance compared to our prior generation, and is the same graphics IP powering the latest generation consoles, high-end gaming PCs, and Teslas. For increased performance and greater power efficiency, Ryzen 6000 APUs are built using TSMC's 6nm process technology. And to enable our partners to build the ultimate notebooks, we paired our leadership mobile processor with the latest in memory and connectivity technologies, including low-power DDR5 memory, USB 4, and Wi-Fi 6E. And the performance is just amazing. Ryzen 6000 powered notebooks feature our fastest Ryzen processor ever. With boost speeds up to 5 gigahertz, we're delivering an average of 1.3x faster performance compared to the 5000 series across a wide range of compute-intensive benchmarks. And with an RDNA 2 graphics built in, it's a massive leap, double the performance.
Today, we are introducing the AMD Radeon RX 6000S. This series is specifically built for thin and light gaming laptops. These GPUs are optimized for power efficiency and enhanced with new performance per watt technologies, pushing high performance in the most compact devices. 20% thinner, weighing less than 4.5 pounds. Last year, we introduced the Radeon RX 6000M series lineup for traditional gaming laptops. This year, we're growing the offerings. We are introducing faster performance graphics solutions with faster memory and higher game clocks. And we are also expanding the reach of the models in this series with a new discrete GPU. This new GPU is built on 6nm technology designed for low-power gaming. Today, we are announcing a whole lot of new AMD Radeon mobile GPUs to bring the best experience to every gaming laptop. For our desktop gamers, today we are introducing a new 6nm GPU that brings RDNA 2 graphics to even more gamers. The AMD Radeon RX 6500 XT. This graphics card has the fastest sustained GPU clock rates ever at over 2.6 gigahertz includes 16 hardware array accelerators, 16 megabytes of infinity cache, and supports the full suite of Adrenalin software features.
With AMD Advantage, we're working to raise the bar of what defines a great gaming laptop experience. We've partnered with OEMs to design best-in-class gaming laptops by providing them with the design framework that ensures the premium performance delivered by our Ryzen CPUs and our Radeon GPUs is felt through all aspects of the laptop's experience. There are 3 key things to know about AMD Advantage laptops. First, we've amplified their gaming performance by optimizing AMD's CPUs and AMD's GPUs with our smart technologies. Second, they come equipped with high refresh rate and premium quality FreeSync displays. And third, we focus on each model's cooling, acoustics, sleep and resume times, battery life performance, and hundreds of other design decisions, making them truly built to game.
Today, I'm excited to announce that we are bringing 3D chiplet technology to market in our Ryzen CPUs. The Ryzen 7 5800X3D is our first Ryzen processor with 3D V-Cache technology. It features 8 cores, 16 threads, up to 4.5 gigahertz boost, and a large 64 megabytes of 3D cache to go with the 32 megabytes of 2D cache. The 5800X3D drops right into existing AM4 motherboards and delivers a significant boost in gaming performance. Looking at the performance in 1080p gaming, we see a significant increase in performance in many games with the 96 megabytes of L3 cache. Across the entire suite, it delivers an average of 15% more frames per second than our previous fastest gaming processor, the Ryzen 9 5900X. And when compared to the competition's best gaming processor, we're proud to say the combination of the Zen 3 core and AMD 3D V-Cache once again makes Ryzen the fastest gaming CPU in the world. Zen 4 is the next big step. Built on 5nm process technology, Zen 4 will extend our performance and performance per watt leadership in desktop PCs. For the very first time, let me show you our next generation Ryzen processor. This is the all-new 5nm AMD Ryzen 7000 desktop processor. It's currently running in our labs, and the performance looks incredible. And just as we did with Ryzen 6000 mobile, our next-gen Ryzen desktop processors will be paired with next-generation memory and connectivity technologies to deliver the ultimate experience. In addition to the new Ryzen 7000 CPUs, we're introducing an all-new AM5 platform. AM5 features an LGA socket and includes a support for PCI Express Gen 5, DDR5 memory, and much, much more. Now let's see Ryzen 7000 and Zen 4 in action for the first time. What you're seeing is 1080p gameplay footage of Halo Infinite running on a pre-production 5nm Ryzen processor. To give you an idea of why we're so excited about Zen 4, you can see beautiful gameplay at very high frame rates. And I can tell you that all of those Zen 4 cores are running at 5 gigahertz during this demo. This is the next generation of gaming and PC experiences from AMD.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks, an engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akida chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akida development environment for free at brainchip.com/developer. Unlocking the future of AI. Brainchip, Akida.
Five years ago, Advanced Micro Devices was in trouble.
Ooh, AMD, Advanced Micro Devices, very painful day for this stock.
AMD it's still surviving, but
surviving.
Not by a lot.
The chipmaker was bleeding money, drowning in debt, facing a possible bankruptcy, and its stock was trading around $2 a share. Lisa Su then became the company's first female CEO, faced with leading a daunting turnaround.
I was really excited to become CEO, but of course, a little bit scared like anyone taking on a new job.
After getting a doctorate in engineering at MIT and nearly 2 decades in the semiconductor industry, Su was ready for the challenge. She laid out a plan to focus on microchips for gaming consoles, data centers, and platforms like virtual reality.
The most important thing for us as we thought about what AMD would look like back in 2014 is what are we good at? And what we are good at is making high-performance microprocessors. And that meant actually saying that we weren't going to do some things. At the time, mobile was a very, very exciting field, but it wasn't what we were fundamentally good at. And so we really focused on our core. And I know that sounds simple, but actually it takes a long time to build a sustainable product roadmap.
That's the thing about the semiconductor industry. Developing a new product takes years. AMD bet that the products it was developing today would be a hit with customers years down the road.
The first and probably the biggest bet is on the future generation of data centers. So it has room for 2 of our servers. We're all generating tons and tons of data every day. Like from all of your devices, we have all of this data. And the truth is, we're actually using just a fraction of it because we don't have enough computing to process all of this. And so we are building the largest and most powerful computers to really process all of that data and make sure that we're making good decisions. And on the other end of this spectrum, we're also very, very heavy into gaming. We cover every aspect of gaming, from PCs to game consoles to cloud gaming. The most important thing for us in selecting, where do we target our products is where do we see the market going. We honestly have to look 5 years out and say, what does the world need from tech in that time frame?
It's a long process and it's a long design cycle, so it takes a lot of anticipation and it takes a lot of skill to hit that mark 5 years before you even know what the market will look like. You have to anticipate that. AMD is in a position right now where it's done a very good job of anticipating where it had to be in performance in competition with Intel and NVIDIA.
Su's bets have paid off. AMD has taken market share from its top rival Intel, and it's been the top performing stock on the S&P 500 for the last 2 years.
It's a very competitive space. It's a very high stakes, high reward place, and our goal is to continue to make the right bets year after year. So I'm very proud of what we've done over the last 5 years, but I would also say we're just at the very, very beginning of what we can do, and the next 5 years will be more exciting than the last 5.
I'm Bridget Green.
And I'm Kevin Weber, and today we're bringing up Xilinx, the newest addition to AMD.
So good to have you here, finally.
I heard you want to talk about technology. You don't have to twist my arm too hard on that topic.
I have hot gossip.
Are you looking for secrets?
Bring up Bridget. She's dead. You may not like it, but this is what peak performance looks like.
Hi, everyone, and welcome to The Bring Up.
Yeah, in our grand tradition of doing exciting things here at AMD, we've been doing, well, a lot of exciting things here lately. There were all the announcements we made in our product premiere around CES at the beginning of the year.
But also, in even bigger news, AMD has recently acquired Xilinx, and that's really what we wanted to celebrate today. Now, we know many of you are longtime AMD lovers and super familiar with our tech, but if you're not as familiar with the technologies and products that Xilinx brings to the table, well, wouldn't you know it, Kevin? That's what this whole episode is about.
Yes, as a super broad overview, Xilinx is the inventor of the FPGA, a leader in programmable SoCs, and they deliver some of the most dynamic processing technology in the industry.
When I first heard the good news, I definitely was not familiar with what an FPGA was or what adaptive SoCs were, which are some of Xilinx's key technologies.
We're going to do our very best in this episode to explain some of the core technologies that Xilinx makes, what differentiates them, and how they complement AMD's technologies.
Yes, Xilinx offers a massive portfolio of chips with different sizes and levels of performance so that we can offer solutions for highly complex computing needs or simple functions.
Yeah, our Xilinx silicon can be reprogrammed to do different functions after deployment, eliminating the need to update silicon to support future functionality, which I'll deep dive a lot on later in the episode.
Oh boy. But first, luckily, we found out the ultimate expert on this very subject was visiting the Austin campus, Victor Peng, who joins AMD to lead our newly formed adaptive and embedded computing group. And so I sprung at the chance to ask him all of our burning questions about Xilinx.
Let's check it out.
Victor, thank you so much for coming on our show.
I'm delighted. It's great to be here.
I have been ecstatic because this is definitely one of the more exciting times. I can feel like the energy at AMD since I've joined, 5+ years ago. And so I have a lot of things I would like to ask you. I'm going to limit it.
Awesome. Let's get going.
Cool. So I'm going to start at the tippy top because I know that our audience is made up of a lot of folks who are tech enthusiasts and very familiar with AMD products, but may just not be as familiar with Xilinx technology. And so maybe like a Xilinx 101. Can you tell us a little bit about, what is an FPGA and what is an adaptive SoC?
Sure. Xilinx invented the FPGA, and, without getting into the real gory details, you should think about it as it's a semiconductor chip that after it's been manufactured, you can actually still change kind of the functions that it could do and the capabilities that it has. It's a very regular structure for the most part, and you can program it in a way that you're changing the hardware function. And that's really unique compared to other semiconductor products, because once you fabricate it, it's going to do certain features and capabilities that it was designed to do. If it's software programmable, then you can change what it's doing from a software level, but you actually can't change the hardware. Whereas FPGAs, you can actually change the hardware. When you talk about adaptive SoCs, that's also something that we pioneered, and what that is, integrated on a single die, you have a complete multi-core SoC together with that FPGA that you can then modify post-fabrication. And so what that gives you is tremendous capability because you have software programmable capability and traditional things like CPU cores and maybe other kinds of peripherals and hardware. Tightly integrated is something where you can customize, the hardware to do things like other forms of acceleration, accelerate other kinds of algorithms, and even change, kind of a lot of the interfaces. So the IOs and things that really control, user experiences in the application. So
I feel like there must be so many exciting use cases for that flexibility.
Absolutely. We get used in everything from, for instance, the Mars Land Rover, Perseverance. We have products in outer space. CERN uses us to detect subatomic particles because we're really good at processing at very real-time kind of speeds. But we're also in 5G base stations. We're in the data center doing acceleration, both on the networking side as well as on the compute side. We're in robotics, we're in vision systems, autonomous driving, that's under development, advanced driver systems today. So it's really amazing what our customers do with this flexibility.
All the really cool stuff, space, cars. That's so cool.
Yeah.
And I also think that there's so many, exciting opportunities combined with AMD products and technologies. So can you give us some insight into how that technology really is complementary to what AMD kind of already has in its product stack?
Absolutely. I mean, so AMD, of course, is a leader in high performance computing and also compelling visualization systems with their GPUs and so forth. And those have been traditionally the workhorses for all the applications and computing today. But what's happening is, with the explosion of data and some of these other new workloads and applications is that, there are more forms of accelerators. And, there's this whole notion of heterogeneous computing, meaning that there'll be different types of engines to do different types of workloads, if you will. So by combining Xilinx and AMD, we will have this amazing portfolio where, we have the leadership in CPUs, we have GPUs, and now we have these FPGAs as well as adaptive SoCs. And so really we have, the proper engine, if you will, for only any kind of workload. And also I'd say with these new emerging workloads like AI, it's a tremendous opportunity for us. So yeah, it's couldn't be a more exciting time in the industry, right? And with the broadest product portfolio, amazing talent, I think, between the two companies. So yeah, I'm extremely excited about it.
It's a very interesting time for the companies to be combining as well, because the last 2-3 years has just been an explosion in both the potential, but also the demand for technology. It's been a little bit crazy, like overdrive. Yes. So, at this time, with all of that in mind, what is your vision for the combined AMD and Xilinx, which I realize, very big question, but.
Yeah, no, I mean, it's true. It couldn't be a more exciting time to be in the industry. In this world of an intelligent, connected world, the computing is going to be heterogeneous for sure, right? And it's not going to all take place in the data center. I mean, data centers are growing tremendously, but the edge is also going to grow. And AMD and Xilinx together can service all of it. We can service the edge, right? We can service the data center, as well as the communications infrastructure that connects it all together, because Xilinx participates in 5G communications infrastructure, both wired and wireless. So there's very few companies that are positioned the way we are. Not only we talked a lot about technologies, but even I would say from a market perspective and the breadth of markets we can serve.
I've got my seatbelt buckled. I'm ready for wherever this journey is going to take us. And we just can't thank you enough for coming and talk about some of this with our audience.
Great. It's been a pleasure.
Thank
Anytime.
you.
Yep.
Thanks, Bridget. I think that was a super helpful place to start in understanding the products and technologies that Xilinx have brought to AMD, and it was just so nice and concise, too.
I couldn't agree more. But why stop there when we can add a mountain of unsolicited detail and nuance just to highlight how magical and fascinating these technologies really are?
Yes, Kevin's been ranting for weeks about what sets FPGAs apart from microcomputers and microcontrollers and what that really means for you. And I'm actually pretty curious myself, so I say we just let him wander off into the tall grass of explanation and see where it leads us, shall we?
Let's do it. Okay, so part of the problem with explaining what FPGAs are and how they work is that the differences between them and similar hardware is very nuanced. So let's compare them with similar-ish technologies you may already be familiar with: microcomputers and microcontrollers. While a microcomputer, a microcontroller, and an FPGA can sometimes be interchangeable, there are good reasons to pick one over the other for your application. So let's start with maybe the most recognizable of the three, the microcomputer. This is a Raspberry Pi 4th gen, and it's one of the most common microcomputers on the market. What makes this a microcomputer is that it has all the same basic capabilities as a desktop or laptop computer. You can install and run a Linux desktop on it, surf the web, and even play games. What separates this from a standard computer is, first, the size. This is only about as big as a credit card. And second is the inclusion of these two little rows of pins here. These are known as GPIO pins, or General Purpose Input-Output. The adventurous among you can use software to control these pins, make them turn on and off, like to blink an LED, or configure them in special ways to send information to other devices like a temperature sensor or a motor controller. Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of this as a microcomputer with everything except the GPIO pin functionality stripped away. Now, you might ask, why would I use a microcontroller over a microcomputer if microcomputers seem to be a lot more powerful and provide more functionality? The answer to that is exactly because of all the extra complexity that a microcomputer brings. You see, computers that are meant for humans to interact with don't have to be particularly precise with how they relay information to us. For example, if you open a web page in your browser, it doesn't really matter if it takes 1 second to load or 1.5 seconds. You're getting your cat videos either way. Computers take advantage of that, and they use up all the spare time they're not serving you content to take care of all kinds of background tasks like running antivirus software and checking the file system. Some applications, however, like controlling motors, sending video signals, or even controlling factory equipment, will not quietly wait around for a big bulky operating system to decide to get around to sending a command signal. And sometimes you need to be absolutely certain that the processor will take in information and respond with exactly what it needs to, exactly when it needs to. And a signal arriving a microsecond too early or too late can mean the whole system falls apart. So in short, this little device is great at taking in information and responding to it quickly and reliably. Now we move on to FPGAs, the most curious cousin of the bunch. So to talk about this, let's take a step back and look at a pinout diagram of the first two devices we discussed. A pinout diagram is a very useful guide that shows you what each of the pins on a given piece of hardware is designed to do. This is important because if you mix them up, you can damage your hardware, which I've never done, obviously. This is what the pinout of a Raspberry Pi looks like. Now, I know this is a mess if you've never seen one of these before, but I'll walk you through some of the important stuff. You can see some of these pins are just connected to ground, some can provide power to whatever you connect to it, but most have this GPIO label next to them, which means it's one of those special pins you can toggle on and off through software. What's important here is that although the pins are labeled GPIO, they also have these little labels that say things like UART, EEPROM, SPI, and I2C. Those are special protocols you can use to communicate with other devices. So if you have a device that uses SPI that you want to connect to your microcomputer, you have to use these specific pins to connect to it. The microcontroller is the exact same way. It has a few more features like analog inputs and outputs, but you'll notice that these special I/O functions are also all fixed to a specific set of pins. The reason for this is that inside the chip there is a special bit of circuitry explicitly designed to control and manage these interactions. And that circuitry is physically connected to these specific pins. So it wouldn't make sense to try and connect an SPI device to another pin because there's no controller inside the processor to manage it. So here's where it gets wild. Whereas this microcomputer has 26 configurable pins, and the microcontroller we looked at has 28 configurable pins, this FPGA chip here has an outstanding number of pins. Here's a very simplified diagram of the pins that are available on this model of FPGA. First, you can see that there are just a lot of them. But importantly, none of these, with a couple of exceptions, have any extra label associated with them. No SPI or I2C or even a UART. That is, at least until we make one. That's right. Whereas on the microcontroller and microcomputer, I'm limited to however many peripherals I've been given by the manufacturer. With an FPGA, I can make however many I want. I could make a device with 5 SPI buses and USB 3.0, or DVI video output and 50 I2C connections, and then change it all back tomorrow when I need something different. And that's already a pretty good reason to choose an FPGA for your project. But wait, there's more. We talked about the speed at which each device can respond to signals, but FPGAs take it to a whole new level. That's right, a microcomputer will take in a signal and provide a response sort of whenever it gets around to it. It may be right away, but it also might be a few hundred cycles from now. Microcontrollers respond quickly and reliably, but even in the best case scenario, it's still possible for these to take a few cycles to read a signal and respond. That's not bad, but it could be better. Enter FPGAs, which if properly configured can take in and respond to a signal instantly. which means they can do math and process signals extremely quickly, making them ideal for real-time applications. Okay, and with that, we've come to the end of this edition of In the Weeds with Weber. It's time for me to get back to civilization. Thanks, Kevin.
Well, that was a lot, but I actually have a much better understanding now. So to this deep dive, I say, jump right in. The water's fine.
Well, it was truly my pleasure.
I know it was. We're very excited to keep you guys updated with more Xilinx goodness in the future, but for now, that's all we have for you on this episode of The Bring Up, and so we hope to see you very soon with more AMD news.
Yes, if you don't want to miss any future episodes, all you got to do is subscribe to the AMD YouTube channel and hit that little bell icon. We'll see you next time.
Thanks for watching.
Next, we have a microcontroller. A microcontroller is quite different and far simpler than a microcomputer. Essentially, you can think of a microcomputer as everything with except for the GPIO pin functionality stripped away. Now, I might ask, why use a microcontroller over? So, the answer to that is because it's a lot of leaves, Bridget.
I think it's looking really good.
Okay, does it feel like they're maybe in camera or something though? Or is it
No,
is it good?
We see you.
Okay.
For sure.
Okay.
It's just the leaves are a nice accent and they're giving you a lot of like color bounce.
Yeah, I feel like the the lighting is maybe being affected.
Let's see this one.
Okay, yeah.
Just a little bit like.
Okay. Yep, no, that's good. No, yep, that's probably good.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
Today, I'm proud to launch our AMD Ryzen 6000 series mobile processors that deliver leadership performance, battery life, and much, much more. We have so much new technology in the 6000 series. It starts with an updated Zen 3 Plus CPU core optimized specifically to deliver leadership performance per watt for notebooks. And I know this is one the community has been requesting. For the first time, we are bringing RDNA 2 graphics to our notebook APUs. The RDNA 2 graphics upgrade brings a massive increase in performance compared to our prior generation and is the same graphics IP powering the latest generation consoles, high-end gaming PCs, and Teslas. For increased performance and greater power efficiency, Ryzen 6000 APUs are built using TSMC's 6nm process technology. And to enable our partners to build the ultimate notebooks, we paired our leadership mobile processor with the latest in memory and connectivity technologies including low-power DDR5 memory, USB 4, and Wi-Fi 6E. And the performance is just amazing. Ryzen 6000 powered notebooks feature our fastest Ryzen processor ever. With boost speeds up to 5 gigahertz, we're delivering an average of 1.3x faster performance compared to the 5000 series across a wide range of compute-intensive benchmarks. And with an RDNA 2 graphics built in, it's a massive leap, double the performance.
Today, we are introducing the AMD Radeon RX 6000S. This series is specifically built for thin and light gaming laptops. These GPUs are optimized for power efficiency and enhanced with new performance per watt technologies, pushing high performance in the most compact devices. 20% thinner, weighing less than 4.5 pounds. Last year, we introduced the Radeon RX 6000M series lineup for traditional gaming laptops. This year, we're growing the offerings. We are introducing faster performance graphics solutions with faster memory and higher game clocks. And we are also expanding the reach of the models in this series with a new discrete GPU. This new GPU is built on 6nm technology designed for low-power gaming. Today, we are announcing a whole lot of new AMD Radeon mobile GPUs to bring the best experience to every gaming laptop. For our desktop gamers, today we are introducing a new 6nm GPU that brings RDNA 2 graphics to even more gamers. The AMD Radeon RX 6500 XT. This graphics card has the fastest sustained GPU clock rates ever at over 2.6 gigahertz, includes 16 hardware ray accelerators, 16 megabytes of Infinity Cache, and supports the full suite of Adrenalin software features.
With AMD Advantage, we're working to raise the bar of what defines a great gaming laptop experience. We've partnered with OEMs to design best-in-class gaming laptops by providing them with the design framework that ensures the premium performance delivered by our Ryzen CPUs and our Radeon GPUs is felt through all aspects of the laptop's experience. There are 3 key things to know about AMD Advantage laptops. First, we've amplified their gaming performance by optimizing AMD's CPUs and AMD's GPUs with our smart technologies. Second, they come equipped with high refresh rate and premium quality FreeSync displays. And third, we focus on each model's cooling, acoustics, sleep and resume times, battery life performance, and hundreds of other design decisions, making them truly built to game.
Today, I'm excited to announce that we are bringing 3D chiplet technology to market in our Ryzen CPUs. The Ryzen 7 5800 X3D is our first Ryzen processor with 3D V-Cache technology. It features 8 cores, 16 threads, up to 4.5 gigahertz boost, and a large 64 megabytes of 3D cache to go with the 32 megabytes of 2D cache. The 5800 X3D drops right into existing AM4 motherboards and delivers a significant boost in gaming performance. Looking at the performance in 1080p gaming, we see a significant increase in performance in many games with the 96 megabytes of L3 cache. Across the entire suite, it delivers an average of 15% more frames per second than our previous fastest gaming processor, the Ryzen 9 5900X. And when compared to the competition's best gaming processor, we're proud to say the combination of the Zen 3 core and AMD 3D V-Cache once again makes Ryzen the fastest gaming CPU in the world. Zen 4 is the next big step. Built on 5nm process technology, Zen 4 will extend our performance and performance per watt leadership in desktop PCs. For the very first time, let me show you our next generation Ryzen processor. This is the all-new 5nm AMD Ryzen 7000 desktop processor. It's currently running in our labs, and the performance looks incredible. And just as we did with Ryzen 6000 mobile, our next-gen Ryzen desktop processors will be paired with next-generation memory and connectivity technologies to deliver the ultimate experience. In addition to the new Ryzen 7000 CPUs, we're introducing an all-new AM5 platform. AM5 features an LGA socket and includes a support for PCI Express Gen 5, DDR5 memory, and much, much more. Now let's see Ryzen 7 It's 1080p gameplay footage of Halo Infinite running on a pre-production 5nm Ryzen processor. To give you an idea of why we're so excited about Zen 4, you can see beautiful gameplay at very high frame rates. And I can tell you that all of those Zen 4 cores are running at 5 gigahertz during this demo. This is the next generation of gaming and PC experiences from AMD.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akida Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akida chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akida development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akida.
Five years ago, Advanced Micro Devices was in trouble.
Ooh, AMD, Advanced Micro Devices, very painful day for this stock.
AMD it's still surviving, but surviving. Not by a lot.
The chipmaker was bleeding money, drowning in debt, facing a possible bankruptcy, and its stock was trading around $2 a share. Lisa Su then became the company's first female CEO, faced with leading a daunting turnaround.
I was really excited to become CEO, but of course, a little bit scared like anyone taking on a new job.
After getting a doctorate in engineering at MIT and nearly 2 decades in the semiconductor industry, Su was ready for the challenge. She laid out a plan to focus on microchips for gaming consoles, data centers, and platforms like virtual reality.
The most important thing for us as we thought about what AMD would look like back in 2014 is what are we good at? And what we are good at is making high-performance microprocessors. And that meant actually saying that we weren't going to do some things. At the time, mobile was a very, very exciting field, but it wasn't what we were fundamentally good at. And so we really focused on our core. And I know that sounds simple, but actually it takes a long time to build a sustainable product roadmap.
That's the thing about the semiconductor industry. Developing a new product takes years. AMD bet that the products it was developing today would be a hit with customers years down the road.
The first and probably the biggest bet is on the future generation of data centers. So it has room for 2 of our servers. We're all generating tons and tons of data every day. Like from all of your devices, we have all of this data. And the truth is, we're actually using just a fraction of it because we don't have enough computing to process all of this. And so we are building the largest and most powerful computers to really process all of that data and make sure that we're making good decisions. And on the other end of this spectrum, we're also very, very heavy into gaming. We cover every aspect of gaming, from PCs to game consoles to cloud gaming. The most important thing for us in selecting, where do we target our products is where do we see the market going. We honestly have to look 5 years out and say, what does the world need from tech in that time frame?
It's a long process and it's a long design cycle, so it takes a lot of anticipation and it takes a lot of skill to hit that mark 5 years before you even know what the market will look like. You have to anticipate that. AMD is in a position right now where it's done a very good job of anticipating where it had to be in performance in competition with Intel and NVIDIA.
Sue's bets have paid off. AMD has taken market share from its top rival Intel, and it's been the top performing stock on the S&P 500 for the last 2 years.
It's a very competitive space. It's a very high stakes, high reward place, and our goal is to continue to make the right bets year after year. So I'm very proud of what we've done over the last 5 years, but I would also say we're just at the very, very beginning of what we can do, and the next 5 years will be more exciting than the last 5.
I'm Bridget Green.
And I'm Kevin Weber, and today we're bringing up Xilinx, the newest addition to AMD.
So good to have you here, finally.
I heard you want to talk about technology. You don't have to twist my arm too hard on that topic.
I have hot gossip.
Are you looking for secrets?
Bring up Bridget. She's dead. You may not like it, but this is what peak performance looks like.
Hi, everyone, and welcome to the Bring Up.
Yeah, in our grand tradition of doing exciting things here at AMD, we've been doing, a lot of exciting things here lately. There were all the announcements we made in our product premiere around CES at the beginning of the year.
But also, in even bigger news, AMD has recently acquired Xilinx, and that's really what we wanted to celebrate today. Now, we know many of you are longtime AMD lovers and super familiar with our tech, but if you're not as familiar with the technologies and products that Xilinx brings to the table, well, wouldn't you know it, Kevin? That's what this whole episode is about.
Yes, as a super broad overview, Xilinx is the inventor of the FPGA, a leader in programmable SoCs, and they deliver some of the most dynamic processing technology in the industry.
When I first heard the good news, I definitely was not familiar with what an FPGA was or what adaptive SoCs were, which are some of Xilinx's key technologies.
We're going to do our very best in this episode to explain some of the core technologies that Xilinx makes, what differentiates them, and how they complement AMD's technologies.
Yes, Xilinx offers a massive portfolio of chips with different sizes and levels of performance so that we can offer solutions for highly complex computing needs or simple functions.
Yeah, our Xilinx silicon can be reprogrammed to do different functions after deployment, eliminating the need to update silicon to support future functionality, which I'll deep dive a lot on later in the episode.
Oh boy. But first, luckily, we found out the ultimate expert on this very subject was visiting the Austin campus, Victor Peng, who joins AMD to lead our newly formed adaptive and embedded computing group. And so I sprung at the chance to ask him all of our burning questions.
Very good afternoon to all of you. Welcome to session 2 of day 1 of our AI Summit. We have very exciting sessions covering fintech, perception AI, AI chip architectures, ultra-low power edge AI ASICs, followed by a panel discussion on how AI ML accelerating digital transformation and few more startup showcases today. So stay tuned. We'll begin with our session today.
Hello, Srinivas. Hello. Hello, everyone.
Our next session is a keynote by Prabhat Sahu on growth path and use cases of AI in fintech. While fintech as a vertical has grown exponentially, the aspect of it being operational as a business scaled down, the economics and the feasibility. He'll be talking about multiple ways AI in fintech can reduce the broader operative manual effort and make transactions and lending quicker, efficient, and more secure. Let me introduce Prabhat Sahu, founder and CEO of Sahu Labs. Sahu is working on building a passwordless ecosystem. So let me introduce Prabhat to all of you. Prabhat is a data science specialist. He has edited the digital and the automation in the decision-making process for Maharashtra State, the Agricultural Department. He was a consulting director at Trinity Entertainment and Strategic Consultants, Mumbai. He was head of government sales and marketing, instrumental in acquiring government contracts in his previous engagements. He's a policy advisor to the state of Maharashtra, worked towards disrupting agriculture, marketing, and supply chain scenarios in the state of Maharashtra. He also created a network of about 150 farmers and worked towards eradication of middlemen in his previous engagements. He is a policy researcher, Office of Member of Parliament, Legislative Research, Economy and Polity Research, Constituency Development, implementation of various government schemes, researching out of people, and working on grievance addressing of people, etc. So let's listen to Prabhat. Over to you, Prabhat.
Sure. I hope I'm audible. Hello, Srinivas. Hello, everyone. I'll be broadly addressing the aspects of how AI has enabled growth in fintech. Before we go ahead into the whole aspect of how use cases and growth paths can be discovered in fintech using artificial intelligence and other aspects of automation, I would like to bring in the core of how fintech can be divided into multiple segments, which can be addressed in multiple aspects of use cases. To be very precise, I believe that fintech can be broken down into lending, transactions, regulatory efforts, on the other end, investments, trading, and other kind of exchanges. Fintech broadly is the aspect where we have been able to digitize a whole world of a whole world where money was going from one entity to the other in multiple ways and multiple scenarios. So when it comes to AI directly influencing fintech, I would like to start building around what was the reason why what is the reason why any technology tries to disrupt the other, right? So when it comes to the core financial industry, fintech came in to just impact three things in the financial industry, right? One was efficiency, second was cost of distribution, and the third was decision making, right? So when it comes to the broad use cases of how fintech has been addressing the broader aspect of business, I believe that AI as a core is here to increase the efficiency, of course, by understanding by spending less money and less time on understanding who is more creditworthy and more apt in terms of risk and distribution of capital. On the other end, of course, that we have been able to build engines that are that is making decision making easy in terms of who to lend to and how to source them, essentially. And the third aspect is, of course, verification of all the data that comes in. So now this is what broadly AI has been able to do in lending as a core. And then, of course, there will be other use cases that I'll be describing now. Let's start with addressing use cases one by one, right? So the top 6 use cases that I have been able to define and that I'll be elaborating across my conversation here is going to be are going to be in six aspects. One is trading. I believe that AI has been able to change the way assets are being bought and sold across exchanges. This could be multiple asset classes, essentially, but yeah, trading is something that AI has been able to dramatically change because AI has been able to spot risks and spot opportunities very easily because of the larger data play that is there. I will be expanding across my conversation. Then comes regulatory technology. I believe that RegTech has been the forefront of AI use cases in fintech in India, especially. India has seen one of the largest revolutions in terms of regulatory technology, which has made all our banks far more intelligent, right? That is why we have started seeing neobanks coming in, and a lot of these, all of this was enabled when regulatory technology became the core of the whole revolution in India. Then comes customer relationship management. Those times are gone when branch banking and these kind of aspects were required to distribute capital or deal with individuals across. So in case of lending, or in case of transactional enablement, or in case of exchanges, branch banking and these level of grassroots distribution has been disrupted at scale, eventually making multiple fintech verticals, multiple aspects of fintech more profitable and less operational, and of course impacting unit economics at scale. So customer relationship management has been the forefront of how artificial intelligence has been able to beat the core of how things used to work earlier. Then let's bring down to, once you have, of course, done regulatory efforts, you exactly know who to distribute money to, you exactly know how to source them. You do credit scoring and loan prediction. So this is when you work towards understanding risk scalability, and of course understand how much capital to allocate to what risk. And of course, on the other end, insurance use cases are there. On the other end, you have use cases in asset trading and these kind of things. So this is where credit scoring and loan prediction has been able to ease a lot of these things. Then comes churn prediction, right? So churn prediction as a broader use case is important across multiple types of fintech use cases. You see churn prediction happening at scale when it comes to giving out credit lines. You see churn prediction happening at scale when it comes to savings banking and those kind of efforts. You see churn prediction in mutual funds. You see churn prediction in anywhere where there is multiple touch points across transactions is where churn prediction has been able to build its mark. Then comes the core of all these things, that is fraud detection. Fraud detection has the largest amount of use cases in fintech, and fraud detection has been one of the best possible innovations that AI has brought to fintech. So fraud detection has been able to be an umbrella of all data points that eventually is able to reduce risk across transactions, use cases, and capabilities. Any particular aspect of these will be covered by me in the next 15-20 minutes. When it comes to addressing regulatory technology as a core, I would like to break this down into two aspects. Like, one is regulatory core and then compliance. So regulatory core is where we have seen that a lot of daily operational regulations are being automated using AI. This happens in the payment gateway business. This happens in in insurance transactions. This happens in loan. This happens in neobanking. That people have built AI layers to essentially monitor day-to-day operational regulatory tech. The times have gone when people used to build large compliance teams. Regulatory tech has been able to beat the regular operational compliance that you have to build into the daily system. And then, of course, the other aspect would be core compliance, which means what are the things that you would need to set up a business unit, or what are the things that you would need to operate a business unit beyond a certain scale, beyond a certain geography. These kind of things have also been monitored across, and of course, verification of these documents have become automated and have reduced overall manual effort, eventually making the cost of all of these things far lower than what they used to be. Human effort still tends to be at its core, because India has a lot of data which is not digitized yet, but we tend to see growth in these kind of aspects at scale eventually. India has seen a huge amount of startups coming in this space where people are building for regulatory tech and compliance. And when it comes to broader development of these things, it has not been very difficult, because India, like we all know, India is one of the best government-supported stacks ever. Right? It's a flex that we have over Western civilization, because India has been able to have one of the most modern tech stacks that the government has provided. We have OCEN, which is yet to come up, but then we have UPI, which has become core of a lot of these things, and a lot of data in terms of lending, in terms of transactional capabilities coming from the core of how UPI was built. And a lot of these things that have been able to disrupt transactions across multiple business lines, including consumer, including business loans, including all of these. While we are addressing the aspect of how AI has been able to transform the core operational effort into how things were automated by utilizing multiple data points, we move towards the use case that has seen the most impact of automation and AI. When it comes to customer relationship management, we have noticed that fintech app that allows financial companies to build strong relationships in customers is the one that leads the business essentially, right? So any application that has been able to build stronger relationships, for example, if you see an investment app, the moment it realizes your behavior of investment, the moment it realizes your capability of investment, the capability of how much you pour in your track record across investing in assets on that application, it starts suggesting more solutions, eventually making upselling and cross-selling better, right? We have seen this in the forefront of lending and exchange business essentially. Customer relationship management has seen the most automation in the last couple of years broadly, which reduces the overall cost of retention, cost of acquisition of customer, and of course day-to-day operational cost, which makes unit economics more healthier in such businesses. When it comes to customer relationship management as a core, AI has been able to build multiple reasons for which we have been able to adopt it, right? So personalized experience being the forefront of all of these things. This leads to higher revenues, lower churn, more depth in the business as in terms of health, right? So when it comes to trading, I believe that that again is another business which has seen the most which has seen a large amount of reduction in terms of human effort. Trading is a business which used to be driven by these large floors of humans trying to look at data points, a lot of human intuition involved, and research, tip sheets, blah, blah. AI has brought all of this down to more accessibility and democratization, essentially. That is what automation does to all of us, right? It reduces the amount of barrier that's there to enter into anything, and eventually democratizes it for anybody, anywhere to do it. You know, we all, I'm sure, agree on this fact that it was important for automation and AI to bring in a lot of these data points for every single one of us to feel like a trader at some point, right? India has seen the most amount of stock prediction since forever now, essentially because of these things that have led to all of us having more information, eventually start doing multiple things, right? And that is what I think has been the core of the whole trading industry, essentially. The time has gone when people used to, large firms used to dominate all of this. It is democratized now. Every individual buys shares, sells shares, buys crypto, sells crypto. All of it because of the democratization that AI has brought into the broader scenario. Then while I'm talking about this, AI has also made sure that regulations across trading has been implemented in a stringent manner. It's not these kind of use cases that have come in have reduced a lot of fraud that used to happen in trading, essentially. It's been a while since we have all heard of larger trading frauds. Back in 2000 to 2005, it was a daily thing. But now it doesn't happen because of the democratization. Now that everybody is investing 5,000 rupees daily, 2,000 rupees daily, 1,000 rupees daily, 5,000 rupees a week, in scales like these, the Pareto rule has split, right? There is no 80-20 rule here. It's not true that 20% of people are making the 80% of things, because now millions and millions, crores and crores of people are investing on a daily basis, eventually ensuring that there is a huge distribution of the overall split in data points as well as regular assets in terms of broader trading in general. And then comes my I believe this is one of my favorite aspects to talk about, right? So when we all start noticing that AI in fintech was going up, we noticed that the core that became the most important aspect of this was credit scoring, right? It was there was a time when bureau data and of course other larger systems used to essentially decide who's creditworthy and who's not. But credit scoring has been able to, credit scoring and loan prediction as a broader vertical has been able to ensure that more capital is easily disbursed while risk has been able to kept at a lower side of things, right? That's genuinely because there are so many data points available. The engines are able to decide if somebody's worthy for 5,000 rupees, but somebody's not worthy for 50,000 rupees. Somebody's worthy for 50,000 rupees, but for a period of 6 months and not for a period of 2 years. Somebody's worthy for 2 years, but not for 1 month. These kind of things is what has been able to reduce risk at a broader scale, and of course ensure that we all are able to build a healthy business at scale and healthy business in terms of unit economics as a metric that has impacted all these businesses. I would like to conclude with the broader thought that AI could have thousands of use cases that we all talk about. AI could have thousands of sub use cases, thousands of things that is they're being disrupted. But what's more important in all of this is collection of enough data to ensure that healthy transactions and healthy environment of trading, of lending is there. And of course, multiple people who are building lending infrastructure will be the next revolution, because these people will ensure that lending infrastructure, wealth infrastructure, trading infrastructure, these people will ensure that more and more people are building businesses in these verticals, eventually democratizing it more and eventually reducing the risk for everybody involved. So I hereby conclude. Srinivas sir, if there is any particular thing that you would want me to expand on. Am I audible?
Yeah, Prabhat, I can hear you.
Perfect.
Yeah, we have one or two questions, Prabhat. Probably, I think we can.
Sure.
Yeah. So, in fact, there's an audience question. In fact, while I introduced, I said you're actually building on a passwordless ecosystem. So, in fact, the question says, while the BFSI industry is very regulated and handle very sensitive data, how are you actually going to achieve this passwordless ecosystem?
In BFSI, we are right now enabling almost every aspect of the vertical. We have insurance use cases, we have banking transaction use cases, we have lending, as well as larger exchanges who are using us. And I believe that all of that is happening because regulation is very dependent on how we all perceive it as a core. For example, if I say that Mr. Srinivas has an ID and a password which he uses to log into a bank, and if we all believe that this is going to be safe, we all are so wrong about it, because there are 1,000 ways in which I could know his ID and password, and there are 1,000 ways in which he could lose a lot of things that he has amassed across years, right? So the broader security is by taking it away from the device and making it human-centric. For example, if I say that only Srinivas sir will know his password and ID, it's wrong. It's not possible. But if I say that only Srinivas sir will have access to his biometrics, that's right, and that makes it more secure. Regulations have been very supportive. Regulatory authorities have been very supportive to these changes because these are important for greater good, and we have been able to implement it across use cases in BFSI. And if there is any particular aspect of BFSI use case that anybody would want to have a look, they can go to our website and explore. I think you're not audible, sir.
Yeah, Prabhat?
Yeah.
thank you very much for sharing variety of use cases in fintech.
Sure.
And you also talked about the importance of data collection and how do you actually use that data to for the good of the industry, basically, right? It helps both the consumers as well as the businesses, right? I mean, it benefits.
Sure.
So once again, thank you for taking time and sharing your thoughts on this.
Thank you so much.
Thanks for joining. Yeah.
Thank you. Bye-bye.
Bye. Now we move on to our next session. So our next session is a keynote by Pradeep Sukumaran on perception AI. Pradeep will touch upon perception AI applications that are being enabled at the edge across different industry verticals, which is made possible due to availability of different 2D and 3D sensors, different AI hardware accelerators, options, and an ever-increasing array of deep learning network architectures. He will focus a bit more on the different AI hardware accelerated architectures and also on the need for efficient AI software development SDKs. So let me introduce Pradeep Sukumaran. Pradeep is a VP AI and Cloud of Ignitarium. He heads the AI and Cloud Software Division with a charter to build and grow a world-beating delivery team. He was previously a part of the sales and marketing team with a special focus on generating sales pipeline for vision intelligence products and services, working with worldwide field sales and partner ecosystem in US, Europe, and Asia Pac. Prior to joining Ignitarium in 2017, Pradeep was senior solutions architect at Open Silicon, an ASIC design house. At Open Silicon, where he spent a good 5 years, Pradeep was responsible for front-end, FPGA, and embedded software business development, marketing, and technical sales, and also drove the IoT hardware roadmap. Pradeep started his professional career in 2000 at Sasken, where he worked for 11 years, primarily as an embedded multimedia expert, and then went on to lead the multimedia software IP team. Welcome, Pradeep. Welcome to the session.
Thanks, Srini. Am I audible? You can see me, right?
Yeah, Pradeep.
I'll share my screen now.
Yeah, please go ahead.
Yeah, which is perception AI at the edge. So before I get into the details, I would just like to define what perception system means. It's basically a machine or a device with embedded advanced intelligence which can perceive its surroundings and take decisions in real time. I mean, there's no great thing here. It's a simple thing. And it basically consists of three components. As you can see, there is sensors, there's compute and act. But what's interesting and what's changing here is the kind of sensors that we're dealing with and the kind of compute. So I'm going to focus on these two aspects, more on the compute part as we go. And perception AI is defined by us as the use of deep learning, and in some cases, deep learning plus traditional signal processing algorithms to process the data that you're getting from these sensors. So with that definition in context, I'll just briefly give you a few of the use cases that we have come across and across different industry verticals, which are leveraging these sensors and also the newer generations of AI hardware accelerators at the edge. First up is the more popular one. All of us have heard about autonomous driving, and this is still very much work in progress, I would say, in terms of enabling anything beyond level 2, level 3 is probably there in some form. But a lot of action is happening here with a lot of sensors and compute. Also, in the world of robotics, autonomous mobile robots is an area where we are seeing more and more sensors being integrated, and a lot of the compute needs are increasing. On the industrial side, we are seeing a variety of use cases. There are vision-based use cases, but there are also a lot of IoT sensor-based time series analytics. And this is where you're talking about sensors like motion sensors, microphones to capture the audio, and doing time series analytics to predict anomalies. And surveillance, this is like an hallmark of perception systems. But what we are seeing different now is the use of multiple sensors being brought in to get more intelligence from the environment. Example would be microphones being used along with camera sensors to get higher level of information. 3D LiDARs being used with cameras at, for example, traffic junctions to get a pattern of your traffic that will enable smarter traffic management systems. So that's an interesting trend that we are seeing. And on the medical side, there are a lot of tier 1 medical device companies, as well as a lot of startups who are working on creating the next generation surgical equipments, endoscopes, which leverage a lot of the video data and analysis using AI. A lot of it gets done on platforms like FPGAs. So these are some of the use cases, just to give you a little more perspective on the perception AI world. Now, a typical perception system would consist of, in our view, 2 main components. One is the sensor itself, which is in hardware, and then you have the compute, which is also in hardware along with software. And I'll just talk about a few of them which are relevant in the discussion going forward. What we call as vision sensors, which could either be 2D or 3D cameras. We are used to a lot of AI-based processing using 2D cameras, but there's a world out there that we are seeing which uses stereo cameras, for example, thermal cameras, other types of time-of-flight cameras as well. And then you have LiDARs and radars. These sensors are becoming cheaper from the defense military domain. They've come into the automotive consumer domain, and it's getting more and more easier for many companies to start considering these sensors, lower cost sensors now, along with these existing sensors, to create what we call as sensor fusion or multimodal systems. So I'll give a couple of examples to make this point. In the robotic space and warehouses, predominantly it's been IMUs, and we have had 2D cameras and 3D cameras, but now we are seeing LiDARs being used inside warehouses, 3D LiDARs as well. And we are looking at use cases where you're using, again, as I mentioned, LiDAR with camera for a traffic junction. So a lot of data is now being captured by these systems. And the point is, how are you going to process all this? And that is where we get to the next point, which is the compute part. And we're going to see what are the different options that are there for product developers to consider when you're building an edge system with all these sensors. So let's look at a few basic things first. The general purpose hardware that is available to all of us easily is CPUs, you've got DSPs, you've got GPUs. Now, these were not built with AI kind of workloads in mind. So we are still using these for AI workloads, but primarily, except for GPU, where it was inherently built for parallel processing, and it's got great memory access architectures. And that's the reason why GPUs kind of became the reason why deep learning became a reality in one sense. But there is a huge demand for edge-based analytics at lower cost and lower power. So one interesting evolution that we are seeing is that semiconductor vendors are adding on coprocessors and extending these architectures to support AI workloads. So we call this, as a DNN engine that gets strapped on to the existing, compute architectures. We're also seeing, accelerators being added to GPUs, to boost the performance that is expected. So this is one class of hardware architectures. The other is the FPGAs. This could be FPGAs that you use as a package, or it could be FPGA IPs that you can integrate. The advantage, of course, is it's programmable, higher performance, in some cases lower power, but from a application development, there are some, I would say, lowlights in terms of ease of use. But that's also changing now, because the FPGA companies have realized the importance of AI applications and what FPGAs can do. So they've really beefed up their software SDK platforms, and we've worked on a few, and we found them quite more friendly than what it used to be. The third class is more interesting for us, which is the ASICs. These are the newer generation of architecture which are purpose built for accelerators, especially looking at the deep learning networks. And we're going to touch upon a little bit more in the next slides. If you were to look at the different architectures and kind of slot them in an hierarchy from low power, low performance, this is typically how it would look. You have microcontrollers, DSPs, FPGAs, which do not have anything special as an accelerator inside the chip, but they do have the general purpose compute that is available. And there is a lot of software layers now being made available on these to enable neural net processing, and all the way to the PCI accelerator-based cards, which are very suitable for the sensor fusion or HD camera-based analytics. One area that we see which is gaining a lot of traction is TinyML. We are seeing hardware architectures, which are being built with less than like 8-bit processing in mind. So while you have softwares which can do below 8-bit, now we're seeing hardware architectures also which are the 3-bit, 4-bit. So there is a good amount of innovation that we are seeing on the accelerator side as well here. So a bit more on the AI ASIC hardware architectures. This is some learnings that we have had over the years that we've been working on different kind of architectures. At the heart of such ASICs is what we could call as a core compute element. People call it program element. They are characterized by the performance in terms of flops or tops. You're talking about floating point or integer implementations, and the power could range from a few milliwatts to watts. Okay, and what is important as a benchmark to select any of these hardwares is the combination of these two, which is tops per watt. We have seen architectures evolve and ASICs evolve from less than 1 top per watt to over now 8, 10, and beyond tops per watt. Although tops per watt could be a misleading benchmark to decide, it's still good because it lets you to choose from an array of options and narrow down to a few. This is a rough order of magnitude comparison that you do. But to really decide that this hardware architecture is suitable for your application, the best thing that we have seen is to actually try it out, to try out that application in its full form as much as you can, end-to-end application, and see the kind of performance you can get. There are a lot of factors which contribute to the overall performance, just like any other system. It's just not the compute engine's power. It's to do with the memory architectures that is there in that system. It's to do with the components before and after the AI processing part. So all of those play a very critical role in this. So when we implement edge AI systems, we have seen two broad categories of system level architectures. One is we've got sensors connected to a single chip, and that chip has a host CPU to run your operating system, to interface with your sensors and actuators. And then you have it connected to a DNN engine, could be a DSP, could be GPUs, could be custom accelerators. And more or less, these are applications which take a few milliwatts to a watts, give you powers in the range of under a watt, under a top to a few tops, and they're suitable for audio, video applications. In fact, a few of the sensor fusion applications as well. But if you have to go to a really high-end system and build perception systems, which can take in multiple sensors, and you're looking at an architecture where you have accelerator card, which is usually attached to a host SoC or a PC using PCIe. Gen 3, Gen 4, 1 lane, 2 lane, 4 lanes, you've got multiple configurations. And the options are ever increasing now, and it just gets all the more difficult for a product, a developer, a customer to actually decide on which is the right kind of hardware to use. To give you a kind of a high-level view of what kind of applications would require what kind of tops. This is just a rough representation. If you're looking at one channel of video analytics, for example, post detection, many of those video analytic applications, you're typically okay with less than one top. And in fact, you wouldn't even need accelerators for this, hardware accelerators. You could very well do this on some of the higher end CPU SoCs, like you have even Raspberry Pis, for example, they run this quite comfortably. Then you have the 3D perception use cases for people tracking, for example, where you need at least a few tops of compute at the AI side for real-time performances. And as you go into dealing with, for example, hundreds of video channels that you need to process at an edge server, you are talking about tops which are in the few hundreds. And then the most complex use case that, edge use case that we have seen is, of course, ADAS. If you're looking at multiple cameras, LiDAR, radars, we're talking about probably 1,000 tops or more, maybe even 2,000 tops. So this is a quick overview of the hardware architecture. Now, very important one from our perspective, users of these kind of hardware platforms in developing applications, and also closely working with semiconductor companies developing these kind of chips. SDK, which is the software development kit, which sits on top of the software, is very important. So when we get down to building applications, all the spec on paper and in fact, even some of your benchmarks on the hardware looks really great. But then when you build the end application, you see that it doesn't meet your performance and power targets, right? And from our experience, the AI SDK that's that sits on top of the hardware and gives you all the hooks to get the maximum juice out of the accelerators is where the magic is actually. And we are seeing a lot of these AI chip companies focus now more on these, basically to enable as many developers as they can, as quickly as they can. In my view, if you were to ask why, for example, NVIDIA Jetson is the most popular choice of Edge AI, of course it has compute, but I would say it is the software SDK. The Jetpack is beautifully packaged together. It's taken a few years to get to a mature, stable state. It has all the components that you need to build your pipeline, and these are highly optimized components. Encoders, decoders, post-processors, pre-processors, and of course, you cannot support all kind of neural networks on a particular hardware. A semiconductor vendor just cannot do that. There are so many new architectures coming out. So if developers can actually quickly implement newer layers, or using, for example, CUDA or whatever abstraction layers that the accelerator provides, that would be a very good thing for implementing more optimized solutions. So when we typically get down to building applications, we look at doing benchmarking. Now, there are benchmarks that are available from the hardware accelerators, companies, but they are benchmarked with standard networks and in standard operating conditions, right? Now, when you have to do a product development, you will actually have to look at end-to-end. For example, in a video application, you have to look at the latencies from glass to glass, from the camera glass to the display. So you have to look at the pipeline. It could be multi-channel, single channel. You have pre-processors, you have a lot of memory access. And we have seen implementations where the AI engine does its job. You get your required IPS, inference per second. But then somewhere down the line, usually before the IPS, you have some clog, and that could, you could tie it to some memory access. You may need some interesting way of doing some DMAs to get, work around that bottleneck. So a lot of effort has to go into optimizing, the complete data pipeline. And I think, the SDKs also could kind of improve make it easier by providing some good reference designs where you're leveraging as much of the efficiency as possible from the hardware. So along with hardware accelerators, SDK plays an equally, and I would say nowadays even more an important role. So with this in context, again, would like to go back to some of the applications and give a little more details about some of the applications, from low end to the high end. So audio AI, this is the case where you're doing offline voice command engine. These basically has a data pipeline like you see below here. DSPP processor block, you have a custom neural network, then you have voice command classification. In terms of complexity, it is not so high. You require very less RAM, you require very low MCPS. You don't even need hardware accelerator here. Some of the implementations are done on MCUs, on FPGAs, very low end FPGAs, some DSPs. But what we're seeing is that there are companies out there, and you're going to see some of them in this conference as well, talking about TinyML architectures. And there's a good reason that it's there. It's because there are applications where you want AI workload and you want to do it at lower power than non-AI workload. So it's so competitive now that end consumers want more AI features. At the same time, they want longer battery life. So that is where we are seeing this TinyML, hardware architectures, a set of companies doing some pretty interesting, innovative work there. So this is one use case, one application. The other, moving into the video side, you have post detection as one common application, and you actually can develop multiple use cases with this behavior detection for sports analytics, for patient monitoring. And this is how a typical data pipeline, if you were to implement it at the edge, would look like. You have a camera. And again, like I said, you have different options of cameras that you have to select, resolution, FPS. And then you have preprocessor blocks. You have the DL-based key point estimators. There are a lot of standard networks, and there are, again, varieties of architecture that are available. Some can detect one human key point, some can detect multiple, some cannot detect the half a body and all that. So a lot of variations out there. So you've got to choose the right one. And you also have the key point classifier, which will is usually application dependent. And for such networks, these are in the 5 to 10 million parameters complexity networks. They take 50 to 75 megabytes of RAM, and you can easily run this on target hardwares like GPUs, AI SoCs, FPGAs, and some special ASICs. And they typically require less than five tops. Maybe 1 or 2 tops is more than sufficient for this class of application. On the 3D side, if I were to take an example, I did not go with the usual applications like object detection, in a ADAS or robotic one. I'm going with what is called as people counting and tracking. Now, this could also be done using 2D cameras, but there are reasons now that we are seeing where customers are looking at implementing this using 3D LiDARs. One is the cost of the LiDARs are coming down. The second more important part, it works better than 2D cameras in challenging conditions, outdoor environments, different lighting conditions. So if you connect a LiDAR, 3D LiDAR, and you connect a compute box to it, the kind of components that you need to take care of is pre-processing, the 3D point cloud. You have a DL-based implementation of the 3D point cloud. Compared to earlier where we used to use the PCL libraries, now you have a lot of networks. Like point pillar, center point, etc. And for these networks, the parameters are a little more complex. You have 75 to 100 million parameters. You have 300 to, let's say, 500 megabytes of RAM. And definitely you need higher tops if you're looking at more real-time performance. And you have, again, a lot of options that you can choose from to build this kind of applications. So with these 3 applications, I'm just trying to give you a variety view on the different combinations of hardware accelerators that are possible, different type of sensors that are being used. To summarize, it's quite interesting to see the semiconductor industry as well as the open source area where you get a lot of these new architectures being published. There is, in my view, a lag. Of course, the semiconductor industry, there is a lot more, architectures that are still being tried out, and it has to become mainstream. But definitely, with a lot of these sensors and multi sensors, I'm sure that there'll be more investments happening from the semiconductor companies in building better and faster SDKs. And I would like to reemphasize that software SDK is going to play a crucial role in the adoption of the newer architecture. So the accelerators, come with better SDKs are the ones that will easily get adapted. With this, I end my presentation and I open up for questions, please.
Yeah, Pradeep.
Yeah. Yes, really.
Yeah, while the video is coming up, I think I will just pick up one audience question.
Sure.
Yeah, I know you talked about the importance of software SDKs. I think throughout you've been talking, hardware is important. At the same time, the SDKs are key. Apart from the proprietary, along with your processors, the OEMs provide, but are there any open source toolkits available for the startups to start working on?
I would say not there. These accelerators that we're talking about are very custom, and there's a lot of proprietary software that comes along with it. Of course, what is available on top of those are open source. You have frameworks, TensorFlow, PyTorch, and all those being supported. So you get to reuse a lot of open source components on top of these SDKs. When I say SDK, I'm talking about the APIs that allow you to access these hardware functions. So those are going to still be proprietary. Of course, there are, I'm sure there'll be, DLA architectures that would open up on the software side as well, where it becomes a little more open. But from what we have seen, it is closed.
Closed. Okay. Good. Thanks, Pradeep, for sharing the insights on perception AI, the applications, the AI hardware required, and how things are moving to the edge, the compute moving towards edge, and the software SDKs and the importance of that. So once again, thank you very much for your time and sharing your insights on this.
Yeah, thanks a lot, Srini. Yeah.
Thanks for joining. Yeah. So we'll move on to our next session. Our next session is presented by Mr. Murty Gonella. He will give us an overview of BrainChip's Akida neural processor IP for ultra low power edge AI. Akida IP and its neuromorphic compute capabilities to solve the AI at IoT or edge challenges. So Mr. Murty is a head of BrainChip's India Design Center. He graduated from NIT Warangal and pursued his master's in US. Worked in USA with AT&T Bell Laboratories. He also worked with Conexon Systems, later at Microsemi, and now with BrainChip. Over to you, Mr. Murty, for you.
Hi, Srinivas. Thanks for the introduction. Am I audible and visible?
Yes.
Okay, good. Let me share the presentation, and please tell me if it's visible.
Sure, you can share your. Yeah, we can see your presentation. You can put it on the presentation mode.
Okay, good. Thank you very much for the introduction, Srinivas. And as Srinivas just mentioned, I'm handling the Hyderabad, India Design Center of BrainChip. And my presentation is about BrainChip's neural processor IP, also called Akida IP, for ultra low power edge AI. The Akida IP technology is unique in respect of solving the AI challenge on the edge. It's very effective and efficient, as we will see shortly, and everywhere, because it works directly on the IoT edge or on the sensor, which are all pervasive. And most importantly, it is inspired by human brain. So if you followed the news recently, the Mercedes-Benz Vision EQXX model uses Akida IP for keyword spotting. This happens locally in the car. Other automotive use cases that Akida IP can solve are visual and voice authentication, tactile, vibration diagnostics, and so forth. I'll show in a later slide how all the various sensory functions can be integrated. Automotive, with this IP, BrainChip provides close to sensor AI to many other segments such as home, industrial, medical, so forth. So in short, Akida IP accomplishes AI tasks in IoT edge at a substantially lower values of power, memory space, and inference time, and without sacrificing the accuracy compared to CNN networks, which are running on the higher end CPUs, GPUs, and so forth. This is the need of the day and the need of the future, where countless IoT devices must execute as much AI locally as possible without resorting to high-end servers of the cloud. Now, besides just doing inference on the edge, these scenarios need the capability for edge learning or on-chip learning, as we call it. And to accomplish all of these tasks, BrainChip is the first to provide a neuromorphic solution that is effective and commercially viable today. And all of this is the result of 15 years of architecture research. BrainChip is located in 4 different areas as of now. It has centers of excellence in Australia, in California, US, in Toulouse, France, and in Hyderabad in India. If you take a look at the edge space, moving AI to the edge brings in substantial dividends because you don't have to resort to cloud or any other server on the internet, other than to communication gathered by executing AI locally on the sensors with a huge amount of data. This data is substantially humongous in size, and which would otherwise have to travel on the net if such a solution doesn't exist. So what BrainChip AI does is process all this AI, execute all the AI tasks, process the data locally on the sensor, and send only the meaningful information or summary for being processed on the higher end servers. This also has the indirect effect on security, meaning this also indirectly means it's more security because the data that needed to travel, since the data doesn't travel on the net, the overall effective attack surface is minimized as well. Distributed AI allows sensor fusion because the Akida IP, as I'll show shortly, can integrate all the sensor modalities, all the types of sensor modalities. You can see the graphic on the right, the compounded annual growth rate for edge-based edge devices needing AI in the next 3 years. This slide shows a little more detailed and itemized benefit analysis of the edge AI over data center-based alternatives. So you can see, for example, power efficiency, low power, ultra low latency because we don't touch the network other than to just send the information that we gathered after the AI tasks are completed. small memory footprint, which is why we go to, which is one of the main motivations for being able to deploy AI on the edge. And one-shot learning, few-shot learning, and so forth, which enables edge learning, as I just mentioned before. And I'll have some more details on this in the subsequent slides. Low bandwidth, of course, and privacy enabling. As I said, the overall effective attack surface is minimized because things are sensor local. Now I come to the integration that I mentioned about, where different sensory modalities are integrated. You can see visual, vision, audition, olfaction, gustation, tactile. These are the 5 sensors that we are aware of. And then there are other sensor data such as LIDAR, radar, and so forth. So they're all integrated, and Akida IP provides a solution for each and every one of those. Akida IP can work as an independent processor, doing all the heavy lifting, doing the inference, doing the edge learning, and so forth. But it can also be working. It can also be made to work in conjunction with a host CPU as a AI accelerator. So both use cases are possible. And you can see on the line, amber line below, the arrow line, you can see how the data proceeds from the capture stage through all the intermediate stages and leading up to the activation stage, action stage or actuation stage. Akida IP is unique in the sense that in a remarkably small real estate, it blends all the 4 factors top on the wish list for AI, which are distributed computing, event-based processing, event-based communication, and event-based learning. You can see that these bullets that are listed here are almost exactly the same as we discussed earlier, but most importantly, they all end up being good for the planet, as you can see in this slide. Akida IP is available as a fully synthesizable RTL. It is processor agnostic and process agnostic, and it is delivered as with standard UDA tools. Customers can integrate this into their own SoC. I will later talk about scaling and configurability of this IP. BrainChip has a reference SoC, an SoC as a reference chip, which integrates this IP, and it is called Akida 1000. That's the name of the SoC. This comes with a full-blown stack of full-blown software ecosystem, which is operating system agnostic, and it can be used to power a hardware board housing this chip. BrainChip also has reference boards, reference hardware designs employing this chip, various form factors, and they have abilities such as PCI Express and USB 3.0 and such in order to communicate with hosts. And we have built BSP for these boards, and it is available on ARM's key website. This is the chip, the Akida 1000 that I mentioned in the previous slide. As you can see here, you have these 2 rectangles on the bottom. This is the data processing and event class generation block, and then the neural fabric. So together is the Akida IP. So in the data processing, basically what happens is we convert from pixel to event domain, and I'll describe it a little later. From the image pixels, it is converted into event domain, or even in non-image data, it is converted into event domain. And it is in this mesh that you see here, there are 80 neural processing units, which are connected in a mesh configuration. And this is all digital logic and local SRAM. So there is little or no dependence on external memory. So everything is completely self-contained in this IP. Then we have the M-class, it's a Cortex-M microcontroller that we use together with the FPU, and it has some inherent DSP capabilities. It has PCI Express, USB 3.0, and many other interfaces. Only a few are shown here. We have I2C, I3C, I2S, the standard interfaces, UART, JTAG, and so forth. External memory, LPDDR interfaces there. And you can do multi-chip expansion. You can cascade 64 of these devices together and using PCI Express bus. And this is the flexible, the neural mesh together with the data to event conversion. This is the Akida IP that is being integrated into our reference chip here. This in this and the next slide, I'll discuss the sizing and configurability that I mentioned about the Akida IP. The IP has what are called nodes. Each node is consisting of 4 NPUs, neural processing units, and we can scale it all the way from a very low, ultra low power 2-node IP all the way up to a 256 node IP. So 2-node IP means you get 8 NPU cores, and 256 you get 1024 NPU cores. NPUs in each node can be configured as convolutional as well as fully connected, and the convolutional NPUs can be used to perform the standard. One doesn't need to learn anything in order to be able to use it. It's very simple and straightforward to use. The quantization step in MetaTF allows the conversion of weights and activations into as low as 1-bit, 2-bit, and 4-bit activations and weights. So this is very low bit widths. So what happens is, in other words, the important thing here is processing an event domain means that there is computation only when there are non-zero activations. So there is no compute when there are 0 activations, which means that, in other words, the higher the sparsity, the greater the advantages that the brain chip IP brings over CNN alternatives. And higher sparsity is not uncommon in most of the real-world AI use cases. And shorter data bits coupled with sparser computation together substantially reduces the memory footprint, and also there is impressively low power at which the inferences can be made without sacrificing accuracy. But how do we instantiate a model on as low as a 2-node IP, you would ask? So if the customer gets a 2-node IP, which is 4 NPUs, and if the model spans more than, if the model needs so many layers that span more than 4 NPUs, what do we do? So we have a multipass feature where the various passes are on the nodes, run one right after the other, together accomplishing the whole inference task. So this also results in reduced memory requirements. So you can do one pass right after the other, depending on the size of the network that we have versus the number of NPUs you got. Just to go back to the previous slide, here on the right, you see the various configurable parameters, the TOPS, the silicon area, the memory, and etc. So these are it's highly configurable in that sense. Now I'll come to, in this slide, I discuss the very compelling feature of Akida IP, which is called edge learning. So you might ask, so you do training elsewhere, get a CNN model, convert to SNN, and do the inference on your device, right? So yes, but however, in addition to that, Akida IP also brings edge learning capability. So it learns things on the fly using one-shot, few-shot, and multi-shot learning. So the scheme is basically what happens here is after the base CNN feature extractor, the last layer, which is a CNN classifier, is replaced with Akida native layer. And Akida IP's edge learning capability has been demonstrated in some very popular use cases such as MobileNet, keyword spotting, and gesture classification. I have a demo video at the end on the gesture classification. On KWS, for example, we have the standard Google command set, 30 keywords, then silence and unknown, 32. And the network is made to learn on the fly 3 additional keywords, and there is a very impressive performance right there. Here is some comparison of 4 different use cases. These are the TinyML benchmarking use cases. You see visual wakeboard here, which uses the COCO data set. Basically, it is a person, the person is there, person is not there kind of a thing. Or a certain object is there, certain object is not there kind of a thing. So this is a visual wakeboard. Uses MobileNet. Then there is C410. We have data for these 3 cases: keyword spotting and anomaly detection. Keyword spotting uses the depth switch separable CNN, and anomaly detection uses comes with the tired mouse and has an autoencoder, unsupervised learning and stuff. So if you see the numbers here, you can see almost 100x less power over the best performing chip, and even the inference speed is so much higher. In this, so we have seen the 4 use cases of TinyML benchmarking. Now, in this, we focus on KWS specifically, and in comparison with competing architectures, I show here in the hashed rectangle with a dashboard border. So there is Akida 1000 clocked at 300 megahertz, and Akida 1000, the same chip, clocked at 5 megahertz. Look at the very small. You can see operating point where the microjoule per inference and the inferences per second and milliwatt combination is very impressive. Even at 300 megahertz, the full clock speed of the chip, of the reference chip that we have, it is still compares very favorably with the competing architectures. Here, there's a quick 1-minute demo in this slide. So you see in this the rectangle on the left, gray one, vehicle and person detection. In the bounding boxes, you see person or car, as you see. I'm just going to run that. The green is a car, and the purple is the human. Okay, then on this one, on the amber box on the right, there are 2. The blue is the visual wakeboard where a person is detected. On the right, it does the face recognition. It actually recognizes who the person is. So you see, so someone is here. And names the person. Tabitha. Same. So as you could see, it combines both into one. So there is person detection, and then there is facial recognition. Sorry, I'll stop that. Done that before. So in this, there are, you must have seen these demos already, most of them, but I will try to focus on just three demos in the interest of time. This is an automotive in-cabin experience video, which I will try to show on the browser. Please follow through. It's a short demo.
Hi, I'm Rob Telson, Vice President of Worldwide Sales and Marketing at BrainChip. Thank you for joining us today here at Edge Computing World's Demo Shootout. We're going to take some time, talk about BrainChip, and talk about our chip, Akida. So first of all, BrainChip is the leader in neuromorphic artificial intelligence. Our core product, as I highlighted before, is Akida. And it mimics the human brain's architecture, resulting in a revolutionary neuromorphic computing solution that enables a new generation of AI at the edge, the next generation. BrainChip addresses the ultra-low power and performance requirements of edge-based devices. We focus on smart automotive applications, smart city, smart health, and smart home. And we process in the microwatts to milliwatts. I'm going to emphasize that. Akida is that ultra-low power solution. Again, power consumption is in the microwatts to milliwatts with a configurable and scalable architecture. But most importantly, it's our on-device learning without depending on the cloud, which leads to device personalization, which enables multiple applications to address many solutions. So today, let's talk about smart automotive and some use cases. There's the intelligent cockpit and body applications, there's ADAS, and there's vehicle motion and energy. But for today, we're focused on the intelligent cockpit and body. And we're going to demonstrate Akida with in-cabin monitoring, digital assistant, and facial recognition. So this demonstration is going to show you 3 networks that are running simultaneously: facial identification and facial recognition, keyword spotting with voice matching, person and no person detection, and on-device edge-based learning with facial identification in multiple subjects, and on-device personalization with voice matching. Those voices were trained into a data set so Akida can recognize them. And all of these demos are running on the Akida hardware. So here we are for the in-cabin experience. And leveraging the smart automotive philosophy, on the gray screen, you have the Akida face recognition screen, where we're going to have someone come into the screen who's going to recognize who it is. In the center, you have the keyword spotting, and it's going to recognize its voice. And on the blue side, you have the visual wave, where it's going to recognize that someone is in the cabin. Let's take a look.
Hey, Akida. Aaron, all systems active. Hey, Akida. Todd, all systems active.
The amazing thing about this demonstration are the results. For the person detection model, we used MobileNet V1. The power consumed was only 8 milliwatts. For the facial identification model, we used Mobile FaceNet. The power consumed 22.6 milliwatts. And for keyword spotting, we used the KWS network. The power consumed 600 microwatts. So in summary, what we really want to emphasize is that traditional AI is compute intensive, and its solutions are not for the future of smart automotive solutions. There's too much irrelevant data which is being processed, which consumes way too much power. And there's too many dollars being spent in the wrong areas. The key is not to process more data faster. The key is to process the relevant data efficiently and accurately. So neuromorphic computing is the next generation of AI, and processing the most relevant data smarter, faster, and most economical. BrainChip is the first to market. We are leading the way with an ultra-low power solution with on-device training for device personalization. So if there are any questions, you can contact us at www.brainchip.com. You can follow us at YouTube at BrainChip Inc., or at LinkedIn at BrainChip Holdings, or Twitter at BrainChip_Inc. We look forward to hearing from you, and thank you very much for letting us participate in the demo shootout.
Then I have the next, just a second, please. I'll show gesture control quickly.
Welcome, everyone. This is Jeff Cohn with the Wall Street Resource. Joining me is Sean Hare, CEO of BrainChip Holdings.
Sorry about that.
Good morning, Sean.
Morning.
Can a simple natural remedy made from vegetables stop sugar spikes? 1 tablespoon of this simple remedy diabetes symptoms quickly. Every diabetic must see this urgent video. Stanford scientists recently discovered a mind-bending solution shown to lower your blood sugar effortlessly. This took...
Sorry about that. I apologize.
Murthy, we can move on.
Yeah, I think we can. Yeah, but gesture control is particularly of interest because it uses events. It uses native events, not the pixel data. It takes inputs from the DVS camera. So that's what this demo is supposed to. Anyway, these demos are on the YouTube. You can find them. Just search for BrainChip. You can find the 3 demos. And then in the next slide, just a second. Yeah, there are other demos. There's wine testing demo here. There is edge learning demo here. Again, keyword spotting and visual Wakeford and facial recognition demos. Finally, I want to show the online resources. There is this doc.brainchipinc.com site where there is a good bit of information on Akida, MetaTF, and Model Zoo, and many other examples. There is a lot of, it's very informative, very educative, and you can check that out. For the code referred here, you can look at our GitHub site where there is all the code that is referred here is present here under the Akida examples folder in GitHub. And you can look, we are in PyP also, the Python package index. You can go there to get all the Python packages that are referred, that are using which all the examples are built here. So, with that, I'll just come to my last slide, which is like a key takeaway message. It says the cloud-free future is now. So it's not in the distant future, it is now. So we can definitely execute AI comfortably on the edge and IoT space and utilize the power of a neural processing IP like Akida IP. With that, I'll conclude and over back to you, Srinivas. Thanks. I would like to specifically thank IESA for organizing this, and thanks all the audience for listening to this presentation. Sorry about the video. I couldn't show the other 2 videos that I planned.
Murthy, thank you very much. I think before we conclude, there are 2 questions from the audience. Maybe one specific on why is it processor called Akida? The name Akida, is there? In fact, this is from one of the audience.
Tough question for me, sorry. I think it has a Greek root, but
okay.
Yeah.
Right. Okay. So I think in the interest of time, I'll post the question and we'll respond back to the concern person was asked. So we conclude the session. So thank you very much again for taking time and taking us through what BrainChip is doing and moving the entire compute to edge, including your AI models and including the learning happens at the edge level. I think that's the interesting future we are all of us looking forward to see, because in the last a decade or so we said edge, because of the lack of compute, we moved everything to cloud, and now we are coming back to edge again. So hopefully, I think whatever you explained, we get to see in the next few years. Thank you, Murthy. Thank you very much. And we'll move on to the next session. Yeah.
Thank you very much, Srinivas.
Yeah. Our next session is by Mr. Swamy Irrinki. Good morning, Mr. Swamy. Thank you for joining us from US. I know it's early morning. You have to wake up, or rather midnight.
Hi.
Okay. So, Mr. Swamy is going to present on ultra low power edge AI ASICs, and predominantly he'll focus on how AI is migrating to edge devices. I think that's going to be the focus of his session. So before I hand over, I'll probably take a minute and introduce him. Mr. Swamy is a marketing and business development executive with over 25 years of diversified experience in high technology startups and public companies, with demonstrated leadership in developing strategy, go-to-market plans, product positioning, demand generation, business development, and sales. So Mr. Swamy is responsible for Moschip's global strategy for growth in semiconductor, embedded system business units, along with North America business development and sales for IP, turnkey, ASICs, and design services. Prior to Moschip, Swamy was a senior director marketing at Sci-Fi for SoC or IP products at Open Silicon for custom SoCs. Swamy also held Director of Product Marketing for SoC products at Form Factor and Business and Marketing Management roles at Computing, Storage, and Networking business units of LSI. Now LSI is a part of Broadcom. So Mr. Swamy, over to you.
Thank you, Srinivas, for the kind introduction. Let me share my screen. Yes. So with the as the topic highlights that, as you just heard the presentation from Murty on how the brain power Cicada IP is enabling AI learning and inferencing on the edge for ultra low power with very low power. So my topic is about how we can leverage that IP and we can develop ASICs with that with IP, and we're collaborating with BrainChip in that aspect. So let me go through that. My topic will cover the AI edge devices for end applications. Some few examples. How does edge accelerators are dedicated for each application, for each device, can be implemented with the custom ASICs, and what is the custom ASICs market, and what is Moschip ASIC platform is enabling the smart edge devices, and we'll actually run the demo along with this BrainChip Akira demo with our ASICs, and we'll conclude and take any Q&As towards the end. So some of the examples are just to, and we all know that as we talked, heard throughout the sessions today, the AI is already there at the edge, both learning and inferencing happening at the edge. For examples like you can self-checkout application, facial recognition, autonomous mobile robots in manufacturing, etc. So all these applications need both learning and inferencing at the edge. So there are traditionally this implementation of it is implemented through it can be done with the CPU. It's very easy to implement with CPU with algorithms, but CPUs are not ideally suited for the CNN because it requires the sequential processing feature does not match how the AI algorithms are done. They're more suited for a data center, but they can work along with they can do a lot of hosting applications along with the accelerator. Similarly to GPU is also provides very high throughput and bandwidth, but it requires massive power in a big data center. So it has its place, but for edge devices, it is not the ideal solution. But it can run some specific video functions. But for AI learning and inferencing, a dedicated edge accelerator provides the most optimized power and computing efficiency at a very low at a small form factor, and it can be customized for each application. Of course, it comes with a cost. It has to be customized and dedicated for each application. But it is ideally suited for this edge devices to have a dedicated edge accelerator customized for each specific edge device. So there comes the need for ASIC. So each application, you can require an ASIC. As I mentioned, ASIC provides the lowest power and the highest performance compared to any other implementation of implementing edge accelerators. There are edge accelerators that implement with CPUs, GPU, and FPGA. But my topic today is about ASIC. ASIC provides certain applications that require ASIC. It provides the fast, high needed performance at the lowest power. But it's a fixed function. It is expensive because it has to be customized. It requires NRE. It requires time to develop. It's not off the shelf. But it provides the lowest power for this power sensitive devices. So what is the edge device? The total, there are many market research reports are predicting that in the next 5 years, about 2 billion, around 2+ billion units will be AI enabled. I'm talking about edge devices. I'm not talking about the data center. I'm not talking about the network at the edge. I'm talking about the pure edge and endpoint edge devices. The application that I showed earlier. So those this market is only for the extreme edge devices, not on the edge of the network and not on the data center. That is a much bigger market. So in that, about 2 billion, roughly about 2 billion units will be AI enabled, is growing at a CAGR of about 17.7. And for that, the chips that require for 2 billion units, 2 billion plus units, the total chips that will power these 2 billion units is about 5.5 billion. Roughly about $2 a chip type of. These are very small ASICs powering very low cost-sensitive applications for ultra-low power. And of that, still ASIC is about 1 billion. There are applications because of the NRE and cost, NRE and time to develop. Some applications can still be leveraging CPU, GPUs, and FPGAs. So the ASIC TAM of this 5.5 billion is about 1 billion. And that is the fastest growing growth rate among all the other segments in this market. So now the ASICs are optimized for this ultra low power sensitive, especially for battery life and low cost, always on sensor hubs, addressing privacy concerns, on-device AI. So these are some of the applications like video cameras, your Ring doorbells, smart speakers. Some of the applications are in the dashboard of automotive applications. Very cost-sensitive, power-sensitive applications that to enable AI for these applications. A custom ASIC edge accelerator that works along with it works in conjunction with the CPU or a GPU, but optimized for AI. Edge accelerator optimized is the best way to implement to achieve the needed cost and the power sensitive power requirements. So the ASICs enable high performance processing with a low power at the smallest form factor. They're optimized for a specific application compared to general purpose GPUs and CPU FPGAs. They can power AI functionality at the lowest unit price point, but it comes with an upfront investment like an NRE. And some of this, for most of the edge devices, the ASICs can be developed in a mature nodes, 28 nanometer, 20 nanometers. You don't need to go to FinFET needs for these kind of edge device applications. So for Morship has developed an ASIC platform for edge devices in 40 nanometer. This is not AI enabled. This is developed for Indian defense, for handheld applications, etc. So this market. So we're leveraging this platform was developed. It was not AI enabled, but we're leveraging this platform to make it AI enabled in 28 nanometer, where by leveraging the BrainChip Akida IP that you just talked about, because BrainChip licenses IP. So we're collaborating with BrainChip to license that neural network IP and take our platform in 40 nanometer and we develop this in 28 nanometer, so that we can develop edge ASICs for a given application And this platform will work. It can be enabled AC development either for the ARM CPU or this new RISC-V CPU applications, so that because the neural network IP from BrainChip does the AI inferencing and learning, but the CPU and GPU does other functions that the typical applications that need. So this is our platform, leveraging BrainChip Akida neural network IP that you just heard the talk in the prior session. So with that, but this IP also, this platform need a lot of other IPs like a lot of chip-to-chip, some of the IPs, SerDes 5 IP that Moship has developed in-house these IPs. So using our IP and the BrainChip neural network IP and other third-party IPs from our partners, we have developed this 28 nanometer ASIC platform that we can customize for each edge application. So I don't want to, it's already been covered in the prior session, but the prior session about how the BrainChip IP is well suited for ultra low power edge applications, especially for a power sensitive applications. And they have a track record of, they've been there in these solutions are already available. They have a demo platforms. They have different designs. Many chips already implement this IP. So with that, so I don't want to spend too much time on this because it's already covered in the prior presentation. So with this IP, how are we? Let me give an example of for our ASIC application. For some of the examples, like for classification, how to classify objects, how to detect, how to learn and influence on the edge, leveraging the IP with our ASIC platform. And let me run a demo with that. And when in this demo, please pay attention to the along with the how the platform is developing classification detection. Please pay attention to the power, the average power, the frames per second, and efficiency. And these are extremely low power numbers. So most of the power numbers you see will be sub 100 milliwatts, and that's what's required for this ultra power sensitive edge devices. So with that, let me run this demo. Okay, so with that we can conclude with the demo. The edge AI accelerators can be customized for specific edge device application, and these edge AI accelerators that can be developed as an ASICs, and ASICs enable the highest performance processing with a low power consumption and small form factor. And MOSFET ASIC platform with the BrainChip's Akida neural network IP will enable customers to develop and bring customized solutions for ultra low power and smart edge devices. With that, that concludes the presentation and the demo about how MOSFET is enabling this ASICs for our customers, leveraging our ASIC platform for this ultra low power sensitive edge devices. Thank you.
Thank you, Swamiji.
Yes, Srinivas.
Yeah, thanks for taking us through, how the AI at the edge level, improving IoT applications and MOSFET's ASIC platform. So in the interest of time, I will post the questions offline to you with the contact details. Request you to kindly reach out to them and respond to their queries. Thank you very much once again for joining this late from US.
Thank you. Thank you very much. Thank you. Bye.
Our next session, in fact, we have Mr. Rahul Shashi and Mr. Bofin Babu. In fact, both of them would be handling the next session. The focus is on AI in cybersecurity. So they will present a case study on various cyber crimes happening and how machine learning technologies is used to prevent them from happening. That's going to be the focus of the session. Before I hand it over to them, I'll probably take a quick minute and introduce both of them. Rahul Shashi is an Indian entrepreneur, founder of CloudSec, and a security expert. He was voted as the top influential cybersecurity person in 2015. He's made a significant open source contributions to the security landscape and is an invited speaker to over 20 plus countries. Is a part of the working committee of RBI and Ministry of Electronics and IT. Mr. Bofin Babu, who's also joined with him, is a graduate of BITS Pilani in computer science in 2016. He has worked with NVIDIA in software development, joined CloudSec in 2016 as a founding tech team member and data scientist. Have given multiple talks and training sessions and conferences. Now, Bofin Babu now heads AI engineering efforts at CloudSec. So welcome both of you. Over to you, Rahul.
Yes, Srinivas, thank you. I'll request Bofin, to start presenting. I hope I'm actually in an airport right now. Yeah, hi.
Is my screen visible?
It is.
Yeah.
So, yeah, cool. Guys, thanks for joining. Just go really fast through the introduction because we have already done that. My name is Rahul Shashi. I've only done cybersecurity. In fact, I quit my engineering to do cybersecurity full time. Founded the company almost 7 years back, along with Bofin and a bunch of other folks. And we're going to show some very interesting cybercrime activities, which is happening, and how our technology is actually, and generally how the technology we built is fighting them. So that's my introduction. Bofin, you want to just?
Yeah, so I joined Rahul's mission in 2016. So our aim was to build a technology to automate the process of detecting cybercrimes at scale, right? And all these years we've been building and polishing that tech, and today I'll be talking about that.
Yeah, awesome. So we have some interesting things, and I don't know how many people in the crowd have actually fall for a cybercrime or a cyber activity. But Bofin, do you want to go to the next slide?
Sure.
Yeah. So I'm going to narrate a real-world incident that has happened. Okay, and this has happened to someone. The names are fictional, obviously, because we don't want to hide the identity of the victim. But what has happened is Mr. Jacob. Jacob is a working person, and one fine day he had certain issues with his bank account, and then he decides to contact his bank over phone, right? So obviously, when you want to contact your bank on phone, what do? Well, like everyone does, Jacob goes to Google, searches the bank name and customer care number. So it's like, well, XYZ bank customer care number. Of course, Google gave him the results, and he got the customer care number of the bank on the top of the search results. Immediately, Jacob makes a call to the bank, and he is greeted with the IVR, the voice response system, and then he's eventually connected to a human. And while on the conversation with the customer sector executive, maybe the call would have taken 20 minutes. By the end of the call, Jacob literally lost every money he has in his account. How did he lost? He started receiving SMS of transactions which he has never done. His debit card was used to buy things from Amazon and other shopping portals, even gift cards, etc., etc. And then he lost all the money. End of the conversation, he realized this, and he realized that he has almost lost 2 lakh rupees on that particular day. Now, you might be wondering what is happening in this scenario, right? In fact, Jacob has been actually scammed, and this is a very, very common cybersecurity, brand scam which is happening, and I'll explain in detail what has happened. To the next slide. Can you go to the previous one, Bofin? Can you go to the previous slide?
Yes, sir.
Okay, I think. Can you go to the previous slide? No. Yeah. Okay. Yeah. Okay. Sure. So what has happened here is, when Jacob searched for the number, he got the number of customer care, but actually the number he got was actually not the customer care number at all. In fact, the number he got was actually posted by cyber criminals, and those were the numbers of the cyber criminals. So when Jacob called that number, they pretended to be a customer success executive from the bank, and then they said, well, in order to resolve your issue, we're going to trigger an OTP to your phone. Now, Jacob thinks that he's talking to the customer success executive, and the customer success executive asked Jacob to read out the OTP. Basically, this OTP is actually his banking OTP to do transactions. And while Jacob did that, the bad guy behind who has this OTP used that to make all these transactions. That is how Jacob lost his money. Now, the people who have understood this might be wondering, how is this happening? So let me run you through all the different dark web, or when I say dark web, all the criminal activities which is happening in the cyberspace, and some of the activities which we monitor. For instance, what you see over here is a conversation which is happening on Telegram. Telegram is like a messaging service, like WhatsApp. It's in a group. It's happening in a group where a bunch of bad guys are there. A particular person, XYZ, is selling full account details. KYC means that you can buy a Coinbase or a Rupee or a Beam account from the cyber criminal. So if you pay him 400 rupees, he will give you someone else's bank account, which is registered to someone else's username, address, and things. So it's a verified bank account, which you can buy for 399 rupees. Can you go to the next one? Bofin, can you go to the next one? Yeah.
This is the next slide.
Yeah, I think there's a delay in when I see it.
Okay.
Yeah, so what you see over here is another posting, right? Where another person is selling accounts, basically user accounts of Uber, Teen Party, Amazon, etc., etc. Now you might be wondering, why would someone be buying an Amazon account? And that's for 10 rupees, by the way. Well, I'll come into that later. But yes, this is again an advertisement by a cyber criminal where he is selling for 10 rupees an Amazon account. Or for 8 rupees, a Rummy Gold, which is actually a online Rummy website account. Can you go to the next one?
Yes. Can you see it?
Yeah, the thing is, it's a bit of a delay in my end. So, yeah, it's okay. I mean, I think I'll speak. So I think what you see over here, yeah. So what you see over here is actually a guy complaining that someone reached out to him with a service saying that they will print his Aadhaar card or laminate his Aadhaar card. Or in some cases, many people on the internet are reached, they get an SMS or an email where the reach out is saying that they'll be getting their Aadhaar card printed or Aadhaar card details changed. Well, what is happening here is these are all fake websites or criminals operating these websites. You don't actually get your Aadhaar card details changed. Rather, if you see the form on the right side, they'll ask you to enter your full name and phone number, email address, etc., in order to change your Aadhaar details. The minute you enter the phone number, they will actually reach out to the Aadhaar portal. In fact, there is a portal, Aadhaar portal, where people can modify the details, which is an actual Aadhaar portal run by the government. They actually contact that website in the background and trigger an OTP. And then on their page, they'll ask you to enter that OTP, which means the minute you give them the OTP to the Aadhaar portal, thinking that you're actually changing your Aadhaar details, they will get access to the Aadhaar portal. Can you go to the next slide, Bofin?
Yes.
Now, how are these three different things associated? One, the first incident was what? Someone was selling a full KYC bank account, right? Someone was selling a full KYC bank account. The second, someone was selling an Amazon account, like, a username and password to an Amazon account. And the third case, someone was actually duping users to their KYC portal. In fact, criminals, what they're doing is they're trying to get hold of an Aadhaar card or the Aadhaar EYC portal. The minute they get access to an Aadhaar card, and they have different ways, not just the EYC portal. In fact, many documents you submit to buying a phone, right, for a SIM card. Some of the agents, we have seen some of the telephone operator agents have resell those information to someone else as well. So the point is they get hold of your Aadhaar card, your Aadhaar details, and then they use that information to create fake bank accounts in your name. So that's one. Or they use that information to create a fake phone number as well, right? Now, what do they use with this fake phone number? Well, if you want to create an Amazon account, you just need a phone number, right? You can create an Amazon account. Now when they dupe someone like Jacob, and the fact, the minute they have got Jacob's debit card, they will start buying things from the fake Amazon account, right? And then they will send that details to and then they'll raise a refund onto the fake bank account. And that way, they would be able to siphon the whole money. So this is this whole ecosystem of what is happening in the cyber world, and tons of people on a daily basis loses lakhs of rupees. And if you are if not one of them, you have to be very cautious. Now go to the next slide, Bofin. While this is happening, what you see over on the left is someone posting, and this is how the advertisement looks like. It basically says, a job wanted, call this number, or customer care number, call this number, etc., etc. So and there are tons of such malicious advertisements on the internet, which is to defraud you and take your money. Now, what CloudSec does in this particular case is our technology monitors the different parts of the internet, looks for these malicious advertisements, which are put to scam users, in fact. And then we automatically, the minute we identify a scam, we automatically report that to the social media platform where it is posted, whether it's Twitter or whether it's Facebook or whatever. All this done is in a completely automatic way. And can you go to the next slide, Bofin? And the social media platform suspends those accounts so that people don't get victimized, or people don't fall for these scams. So what you see on this slide is a threat impacting just one brand. For instance, we have noticed almost 1,800 incidents. That means 800 advertisements on various social media platforms, whether it's Twitter, whether it's Gehlhaar, whether it's YouTube. That's what you see on the left, in a short period of time. In fact, the cyber criminals have created almost 271 phone numbers in the short span in order to target just one brand, which is Beam, right? Beam UPI brand. If you are trying to do these analysis manually, which is why it is impossible to do an analysis, which is the reason why we have technology that can automatically monitor and remediate these things in a fast and interesting way. I'll hand over to Bofin, and he will go into the depth about how the tech is solving these problems. Over to you, Bofin.
Yeah, sure. So, like Rahul said, right? By the way, all the screenshots you have seen here are from our tool itself, right? So let me just give you an idea how we can solve this problem with AI, right? So if I'm going to take that, right, just like what Rahul said and stop. So we receive over like 12 lakh data points or events every day, right? And how much human effort it would take for a company like us to deploy people to go through these 12 lakh events every day to find, malicious incidents and alerts that's affecting brands, right? It's impossible. But if you have built a system that can actually crunch to this data and alert on a malicious activity in less than an hour, right? Maximum hour will take to alert. So I'm just going to explain, what's going behind the scene and how we can build a technology like that, and what are the things we build over time and how we improved it, right? So, I mean, if I'm going to talk about building a technology, right, an AI-based solution to solve this, there are two elements, right? So basically, first part is machine learning, second part is knowledge graphs, right? So if we have these two beautiful things together, we can really solve this thing pretty well, right? So if you remember the examples Rahul showed previously with respect to the customer's care scam or the OTP scam, right? These incidents we call events, right, comes in various forms. It can come through a dark web channel, or it can come through a messaging services channel, or it can come through anywhere, right? So the first part of doing that is to, collect data from all these event streams. For example, like, can be mobile apps or code leaks or card leaks or domain data itself or social media profile data, right? So first you collect this data from multiple sources. Then we have built a unique info extraction module that will extract 400 plus entities like IP addresses, phone numbers, actor names, email, and a lot more, right? Vulnerability, tools, etc., right? From this text. It can be either text or image, right? After we extract these entities and the relationships, this will keep expanding our ex-vigil knowledge graph, we call it. So this is a very big knowledge graph which we've been, improving all these years. And over the top of this knowledge graph, we have built multiple machine learning and deep learning models for the classification correlations, right? Which eventually sends actionable alerts to the organizations about incidents like, for example, there is a fake customer care number, right? Even happening for you, right? Or there is an app in an app store, third-party app store, which is malicious and corrupted, which is impersonating your app, right? So you may have to do something about it and alert your customers. So take you need to initiatives to take down the app, etc. So that's the way we do it. So coming into details, right? So this is like the 5-step threat detection pipeline we follow, right? The first part is, like I said, is the data collection part. So we have built semi-automated callers to collect data at scale, right? When I say semi-automated, it's half programmatical, half machine learning or computer vision, right? So so you have to define a certain set of rules to kind of define the base structure of the product. Then the system will automatically start crawling, sites that belong to a certain set of, certain type, for example, marketplaces, or say discussion forums, right? And when we meet a post, we have built structured content extractors that will just go and look at a discussion and only pick in the essential parts. For example, there will be a lot of advertisements, extra links, everything in the page. Just need the exact discussion, right? In a very structured way. Who is talking what? What's the time? Who is giving the reply, etc., etc. Then after this information is collected from that particular forum post, let's say it's going to the clean classification stage, right? This is a stage where, like I said, right, looking at the data we bring in, we try to reduce noise. We try to see what are the Chengan and what are things we can remove at this phase so that we can actually send quality data to the next step, right? In the next step, we try to correlate this event, right? This potentially malicious event, against our historic data. Like I said, we have a huge knowledge graph, right? And we also have a huge event storage, right? Which store events in a search engine, right? So we check with our historic data lake, and, looking at the past, events which we alerted, and looking at, let's say, for example, we have seen an activity. We know that there is a hacker group that is responsible for, conducting a lot of, let's say, customer care scam, right? And if this new event kind of correlates with the activity of such a hacker, right? Again, it will give a high weighting, right? So basically, the correlation phase looks at the past data we have in the DB for this given new event. And in the next phase, the fact that when we identify this as a relevant event, we try to correlate. We try to see how much of this, what is the relevance of this incident for a particular organization, right? For example, cybersecurity events, right? We say them as a threat in a generic sense, in a way that, this is a threat. But from sector to sector, from company to company, the impact of that event or a cybersecurity threat varies, right? So at this point, right, at this step, the client relevancy step is where we look at that event and try to map the assets to the clients and figure out, how much of the threat that is to the client. Then in the credibility phase, if we further polish the severity and do things like active profiling and try to give a very, very polished threat radar weightage for the event, and we give an alert, right? This is like the 5-step detection pipeline, we follow. And at each step, right, we have deployed multiple machine learning and deep learning models, to solve it, right? So I mean, if I'm gonna, build a very basic system to solve, cyber threat intelligence with AI, right? This is how I will approach, right? This is, by the way, just talking about, how someone can probably start building a small prototype, something like that, right? It's not the complete system, right? So basically, you will have a part where you can do data collection and content extraction at scale from various sources, which requires you to set up the right, infrastructure, which requires you to set up the base, setup to collect data from multiple networks, including multiple networks in dark web. Then, which requires you to set up and build, AI-based structured content extractors, right? Probably you'll have to, deploy a lot of computer vision techniques there. For example, say, you get a page screenshot of a web page, right? Can you kind of detect areas where there is some, rich text present, right? Or can you detect, distinguish between, an image being an ad versus non-ad, right? And it's not purely computer vision always. You also taking features from the HTML page text, right? Mixing these two features, trying to extract the relevant content from a given input, right? Then again, it goes to a stage where, what is the right classifier or the right thread classifier I have to send this event to, right? Is it a source code leak event, or is it an event I need to, send it to a fake app, classification system, or is it an event I need to send it to a discussion monitoring system, right? So we have a parent classifier that, let's say, we can deploy something that, routes this discovered events to the right, deep learning model, right? From there, finally we have sort of a client relevancy, engine, which is an amalgam of multiple, models and techniques. And for example, if you look at a text-to-text match, right? What we can do, right? For example, we can do something like a semantic textual similarity, right? So given a text, right? See how much semantically this text is similar to a previous text, right? The previous text is corresponding to an already known and reported past cybersecurity, right? Another thing probably is like, with respect to extracting all the entities from that text, right? Who are the people mentioned in that text? Who are the organizations mentioned in that text, right? And what are the assets like IP addresses and domains if mentioned in that text? And also not just about extracting these entities, but also about finding the relationship, finding the relationship between them, right? For example, in a sentence like, this redactor is attacking this organization with this tool, right? Such kind of relationships are being built at this stage, multiple modules. Oh yeah, multiple modules. Sorry. Yeah, sorry. Multiple. So I'm just by the way, sorry. Multiple modules are being played here to kind of solve this issue. So I mean, I have just listed a few ML and AI tasks which will be used to solve this this problem. For example, including knowledge-based population, source code summarization, text summarization, and multi-level. Hello.
Yeah, we need to conclude the session. In fact, the next panel discussion is already in. So please.
Give me 2 minutes. 2 minutes. So, so this is actually the kind of giving a high-level idea about the tech power of this thing, right? So now that just give you an overview of the technical aspect of how we build, how someone can build a technology like this, right? So let me just give you some kind of impact of a tool like this with say 100+ global clients, right? With while deploying this tech for 100+ global clients, we are able to detect 4.7 billion leak predictions, about 75 terabyte of data, right? Relevant data for these people, plus about 4 lakh plus fake domains and around 3 lakh of brand IP infringements, right? So this is a kind of global impact of what you have built, and that's all I wanted to talk about. Right? So thank you guys. So I know we are running short on time. So if you have more doubts, please reach out to us. you can actually get our details through Srinivas. Yeah. Thank you, Srinivas. Over to you.
Thanks, Babu. I know quite an interesting topic and very important topic for the industry is basically, I think the more and more we go digital, security becomes critical. And I think the kind of cutting edge work you guys are doing. In the interest of time, I'm not actually asking questions. We have some 2-3 questions. We'll post it offline to you and probably write to them separately. Okay?
Sure.
Yeah. Thank you and Rahul. I know Rahul, you're traveling in spite of that, taken time to join, and thank you very much for taking us through your CloudSec architecture in terms of how you're actually working on the AI-enabled security framework.
Thank you. Thanks for having us.
Thank you, guys.
Good. Now we'll move on to our next session, which is a panel discussion. The focus of panel is going to be on how AI, ML accelerating the digital transformation in the industry. The session will be moderated by Vikram Labhe. The panel will deliberate on the role of AI in digitally transforming businesses, some success stories, and also they will discuss on some learnings and also the challenges ahead. We have an esteemed panel along with Vikram. We have Mr. Ajay Agarwal, who's a Senior Vice President, Head Center of Excellence, AI Analytics at Happiest Minds. And we have Mr. Atul Thotre, ISV Product Modernization Leader at Amazon Web Services. And we have Mr. Raman, who's VC and mentor for startups. And we have Mr. Manish Singhal, founding partner, Pi Ventures. So let me introduce the moderator of this panel, Vikram. Vikram Labhe is the Vice President and Managing Director of Phytron India. Phytron, a SaaS product startup in data space. Vikram joined Phytron as India founder in 2016 and has played an instrumental role in its growth, culminating into its $5.6 million valuation in the year 2021. Vikram started his career at PMC Sierra Inc. in Vancouver, Canada, a company focused on semiconductor products in the telecom and enterprise storage domain. He worked as memory developer as well as analog designer in its initial years of career. Vikram relocated to Bangalore in 2005 to start PMC's first India operations and R&D center. Within 10 years, he scaled it to be PMC's largest R&D center worldwide. Vikram has also managed and scaled Microsemi's India R&D center, which reached a peak headcount of 1,000+ employees. Vikram has served on the board of India Electronics and Semiconductor Association and Indo-Canadian Business Chamber, ICBC. He is currently a Thai Bangalore chapter member and a founding director of National ESDM, that is Electronic System Design and Manufacturing Technology Research Academy, called NETRA, an initiative through which more than 50 startups are thriving on college campuses. Vikram has done his MS in analog circuits from Simon Fraser University, Canada. He holds one US patent and has several conference papers to his credit. He's also an alumnus of IIM Bangalore. Vikram, over to you, and thank you for leading the panel, and please take it forward and introduce the rest of the panelists. Thank you, Vikram, for joining.
Thank you, Srinivas, for such a generous introduction. To be honest, it's a pleasure to be here among the distinguished panelists here. I know we are running behind schedule, and I probably have to compress it in 50 minutes. We'll try our best. because it's such an interesting topic and such a strong panel. It's going to be very difficult, I must admit. With that, let me start with the introduction of the panelist. I'll start with Atul. Atul is an accomplished cloud executive and digital transformation leader. He's currently based out of Silicon Valley. Thank you so much, Atul. This is very early morning for you, for waking up early and being part of this panel. Currently, Atul is a global head of product for ISV modernization at AWS. Before joining AWS, Atul has led digital transformation advisory function at Microsoft Azure, through which he helped spearhead several digital transformation efforts for all of the Fortune 100 clients of Microsoft. It's more than 23 years of experience in the industry, and Atul's experience spans product consulting, advisory arena with focus on enabling digital businesses. Thank you, Atul, for being part of this panel. Next
Glad
one.
to be here, Vikram. Thank you.
Next one, I want to quickly introduce Raman Pathasathy. He's a digital transformation expert and a startup mentor. Raman is a complete strategy to operations person. He has more than 2 decades of industry experience in data management and enabling digital transformation for Fortune 500 companies. After his last company's successful exit last year, Raman has been advising and mentoring startups and early stage companies involved in digital transformation. Raman again is based out of US, based out of Dallas, Texas. And I have one more reason to thank Raman here, not just taking the call at a wrong time. He's actually recovering from COVID and he's still agreed to be part of this panel. So thank you so much, Raman. We all wish you a speedy and complete recovery.
Thank you, Vikram. I hope I'm audible. If I cough in between or my throat is a little different or voice is a little different, please forgive me for that today.
Don't worry about it. Don't worry about it. Yeah. With that, let me move to Ajay Agrawal. Right. Ajay is a successful serial entrepreneur. He has been instrumental in building product startups in the high-tech space. He has led multiple startups from incubation to success while building high-caliber teams, adapting to dynamic market conditions, and demonstrating keen understanding of customer as well as market needs. His Silicon Valley-based startup was funded by the likes of Intel Capital and Philips. And his most recent venture, which was Cupola Technologies, an IoT engineering company, was acquired by Happiest Minds in 2017. Currently, Ajay is the head of AI and Analytics Center of Excellence at Happiest Minds. Welcome, Ajay.
Thank you, Vikram. It's a pleasure being here.
The last panelist is Manish Singhal. He's a founding partner at Pi Ventures. He's a technologist turned entrepreneur turned a venture capitalist. Complete package there, right? He's an IIT graduate. He aspires to help put India on the deep tech innovation map of the world via his work at Pi Ventures. Manish started Pi Ventures in early 2016 with the vision of accelerating the development of AI startups in India. Before Pi, Manish co-founded letsventure.com and led it to become the leading marketplace for startups and early stage investors in India. In just 12 months, he grew the investor base to 700 plus investors from 20 countries and got 1,800 startups on the platform. Manish has also worked for many different startups and established organizations like Sling Media and Motorola in the past. He's also a very interestingly certified coach under the International Coaching Federation of USA. And he's also a keen psychologist and volunteers his time to help people who are facing with mental health issues. Welcome, Manish.
Thank you, Vikram. Pleasure to be here.
All right. With that, let's dive in, guys. I'm going to keep my opening remarks very short and open it up to you guys, for very interesting conversations here. So, we all know that digital transformation is one of the most critical drivers on how companies will continue to deliver value to their customers in a highly competitive environment that we currently are in. This has just gotten accelerated post-COVID, right? And AI and ML are the tools that can be used to plan and implement digital transformation. Some still consider this to be a technology of future, but we have examples like autonomous cars, which tell us that it's not just fiction. So with that, Manish, can you start with your opening remarks on your own opinion on AI and digital transformation, please?
Sure. I think when we started our first fund back in 2016, our core focus was to look at AI companies. And one of my mentors told me that go and find some 3-4 interesting companies before you start a fund. And actually, I could not find in a month or two that I spent on the ground. But I think what I learned, though, in those 2 months is that there is enough green shoots happening, both on the business requirement front and on the AI tech front, and probably on the talent side as well, which led us to the conviction that let's launch a thematic focused fund based on AI. Ever since then, right? And there is, I'm not joking, but when I was raising money, I was presenting to investors, and one of the investors asked, "Why are you raising money for Air India?" Because it was AI, right? So, and like from there, we have come to a level where every kid knows what AI is, right? It is out there in every article that you read today, everything in the papers, etc. So that is the kind of transformation that this technology has undergone in the last 5-6 years. And it has cut across every sector. We are very sector agnostic. We meet companies across every sector, be it healthcare, be it enterprise, be it logistics. So what we are seeing is that almost every company is going to, wherever there is a data-led opportunity to do something, which is a lot of companies, is trying to embrace AI in some digital transformation or the other in their organization. So that's our common observation. There are within the sort of the whole spectrum of AI, there are obviously some very incremental use cases of AI which can be very easily implemented in organizations, and on the other end, there are some very complex problems that AI is solving. So you have that whole spectrum of AI problems being attempted by startups and being solved by bigger companies as well.
So what a satisfying journey so far it must have been, but at the same time, we've just gotten started.
Yes, that's right. Thank you.
Thanks, Manisha. Ajay, if you could give your opening remarks, please.
Sure. Thanks, Vikram, and thanks, IESA, for the invite for this wonderful event. I think all of us will agree that we are living in exciting times, where pretty much every organization, across the different spectrum is talking about digital transformation. And, if we actually deep dive and look at why there is elevated focus on digital transformation, I actually believe that there is a huge focus to heighten the customer experience at this point in time. And also there is a huge demand to sort of bring in a lot more fluidity in the business processes. And if you continue and look at, what the analysts are looking at, if you look at, say, McKinsey, they're basically pointing towards a clear trend where pretty much every industry and every function across the industry is actually already on a journey of digital transformation, at different stages, so to speak. And the more heartening fact is that at least 2/3 of them are looking at increasing their spendings in the days to come. So I think digital transformation is pretty much here to come and stay and and prosper in the years to come. The other important thing is how does artificial intelligence stitches into the digital transformation. I think digital transformation was always there. It was more of experience and domain knowledge based. What artificial intelligence has done is actually it has hugely multiplied the impact and scale with its human-like intelligence. And this has resulted in empowering and augmenting all the business stakeholders with the insights and the decision-making ability like never before. The other thread on this has been the rapid pace at which the AI/ML technology is growing. I clearly remember a few years back, we were basically worried about the scarcity of data scientists, and we thought auto ML is something which will help us democratize that. And fast forward 2 to 3 years from then, we are talking about decision intelligence, which is amalgamation of explainable AI and composite AI. And explainable AI, as we all know, is basically helping us understand the decision better, apart from helping on the bias. The core component of composite AI is where we have gone beyond the machine learning and the deep learning models to sort of use other AI techniques like computer vision, NLP, graph analytics, or rule-based analytics to arrive at the decision making that is being done now. Now, in my opinion, we have such a powerful tool where you could use any of these techniques or use an ensemble of that to sort of drive business additions and agility that is required. So in summary, if I look at today's world, both digital transformation and AI ML are very heavily interlinked. And across the globe, across all industries and functions, there's an accelerated push to do the transformation using AI. And effectively, we are driving towards more innovative business models, looking at enhanced customer experience. At the same time, we are optimizing the business operations that we have, as of today.
Excellent. Thank you, Ajay, and look forward to diving into some of the specifics in following rounds. Atul, if you could go next.
Sure. Thank you for the invite for and participation in the IESA Summit, AI Summit. Hello to all the panelists here. Thanks for moderating, Vikram. I think to add on to what Manish and Ajay had said, right? So the industry and the customers always knew the promise of AI, right? The promise of AI was to drive that breakthrough solutions and innovation to get the human potential to really realize today and not waiting for solutions. As you mentioned, the driverless cars and connected nature of our enterprises is driving that. I think what we see from the insights we gather through the customers we have spoken at AWS is just the AI is giving a pioneering angle to creating solution and launching and solving for human problems. I mean, we have seen in the COVID times how fast the industry from drug discovery to creating the vaccine to getting the vaccine in the hands of human beings and allowing the problems to be solved at a rapid pace, right? And so I would say the speed of innovation, speed of solving problems, at the same time of giving the agility to the businesses to respond with real-time decision making have been the clear role of AI, right? We are not there yet. And when we say AI, it is amalgamation of the ML and the data. There are still, according to Gartner, 68% of companies in the world who have yet to take advantage of the data analytics, ML, and AI. So the opportunity is immense. But the role of AI in digital transformation has now put customer and human being at the center of this journey, right? So we can really solve rapidly a customer journey to give intuitive customer experiences in real time. And that is where the future advancement of AI, and we see this in the food delivery business, we see that in drug discovery business, genomics and automobile. But and AWS had been giving tools and frameworks and solutions to really accelerate this journey for developers and companies to give the solutions. So I think that we have to get from the aspirational phase of the AI to really operationalizing AI for the better human experiences. So I think that's in my opinion, has been the role, impact, and the value of AI.
Very, very, very interesting opening comment. I really look forward to your, your thoughts and inputs as well, Atul.
Thank you.
Yeah, Raman, if you could give your opening remarks.
Sure, Vikram. Again, thanks for inviting me for this panel, and it is so good to see my other panelists talking about AI, and I think they have covered most of the exciting things which is happening today. I echo their comments. I would just add a couple of comments from my side. One, if you imagine the last century, from a technology perspective, the key focus was automation. This century is all about information. And we are just at the tip of the iceberg. We're just scratching right now. And even though the AI ML trend have gone through a phase of early adoption to late adoption, or between early majority right now and between early majority and late majority, I would say new use cases, new scenarios are going to give us new S curves every now and then. It is just exploding like anything throughout the world. And we all know, business runs on data. Data is the fuel, and AI ML brings data to life. And one of the enablers, if you look at from a supply chain perspective, is to achieving the nirvana of the right products or right services to right people at right location at right time. And I think we are getting close to that. So I would conclude my opening remarks with that. Over to you back, Vikram.
Thank you so much, Raman. Very, very interesting context everyone has set. So with that, let's dive into the first, part of the discussion. To start with, let's hear out from all the panelists on what do you guys think of the landscape, right? The adoption of AI and what are its business impacts. So if each one of you, could dive in some of these, and let me start with you, Ajay. Right? If you could, you come from multiple startups, and the last one sold to Happiest Minds. So as a result, you're seeing a lot of use cases there. So if you could start with digital transformation stories leveraging AI ML, that would be great.
So thanks, Vikram. So as part of my focus around AI ML, at Happiest Minds for the last 4 years, have been involved with multiple success stories around AI ML, predominantly focused, either on customer side, or the operation analytics, or in some cases piggybacking around IoT. And pretty much saw, the focus where, the initial set of use cases were sort of, around the narrow AI use cases, what Manish mentioned, in terms of doing POC and MVP to sort of getting it adopted across functions in the organization. What I will touch upon today is, one transformation story where we leveraged AI and ML for one of the largest energy and distribution company, and which is in business for for around a century. So when we engage with this initiative, the first step was obviously to sort of consult and discover and understand the pain points, from a business perspective and the existing landscape, so that we could actually achieve the goal of improving the operational efficiency. Here, we hit the nail on the head by identifying that the problem originated from the data that was fed to the systems, and the systems that were being used, were not a problem in itself. And this was very unlike most of the competitors who have suggested that they should be looking at overhauling or replacing their existing software systems. The next step for us was to actually use use AI ML to enable this transformation. And what it meant was that there was huge pile of data in the forms of images and free text, which basically had humongous amount of knowledge within that in terms of the maintenance that were done for ages, for the systems that, for the plants that were being operated. Also, we connected to other relevant sources which were not used, and with using NLP, for mining the text as well as the documents and the vision analytics from a document perspective, we could actually figure out all the information around the critical assets as well as the the history around the maintenance around that. Now, as soon as we were armed with this information, the whole experience in terms of the field force management, was at the next level, and also it enabled us to actually run a very efficient operation. As we got into this exercise, we also realized that we were able to establish the criticality of various assets. So if you look at a typical energy plant, you'll have valves, pumps, motors, vents, pipes, etc. And because we had so much information available from the documentation and other things, we actually sort of use that to derive the criticality of assets which have backups, assets which don't have backup or have single point of failure, or the impact that they have had in the past because of failure. And that helped us to actually optimize the entire work order management, and also improve the predictive maintenance aspect of it. The other important aspect, and if you understand this energy segment, there is an outage whenever you are looking at the plant outage planning, and this basically runs in 2 days, and the budget runs into millions of dollars. So we actually looked at the historic data, we looked at the estimates versus the real cost incurred and the maintenance history, and sort of used AI ML. Most of it was around machine learning, where we were able to efficiently sort of plan the outages, for this plant. And to top it off, as we got deeper into that, we could actually look at the piping and instrumentation diagram for the existing installation. And we did sensorization around the assets that were there to sort of create a digital twin, getting them the real insights. So I think if you look at this story, I think it's very, very evident that AI/ML was at the forefront to transform the business and get a very, very efficient operation. The most satisfying part for us was to actually get this company on a path to save around $200 million through this initiative. And as we did that, we obviously expanded our scope from the fossil fuel to sort of solar, wind, and the nuclear power. The most important learning, if I have to underline here, is that we are generally in a hurry to sort of look at AI/ML driven solution. But I think the key point here was to take a business first approach and understand the landscape and the business challenges before you jump onto the solution or the approach around AI.
Awesome. So good to know. And companies have already started to see, bottom line, impact as well with the use of the technology there. Thank you, Ajay. Let me move to Atul. You come from a lot of experience with AWS and before that Microsoft as well. If you could just quickly, talk us through about your experience.
Yeah, I was about to pile on with Ajay saying that we have similar case study, and I hope Ajay used some of the AWS, Amazon, Monitron devices for plant maintenance, and that just to highlight how the products and technologies can accelerate the work Happiest Minds and companies they're doing is the innovation that we see our role in product platforms. It's, for example, Amazon Monitron, which allows one of our customers in gas and power industry, traditional monolith, to not only predictively analyze the data which is governing the plant and the equipment, but also take that in real-time decisions to then take a proactive action onto making sure that the equipment and the plant doesn't go down, that doesn't have a downtime, right? I mean, clearly the what I have seen with talking to customers through understanding what innovations we have to embed in our products is there is clearly a desire for solving these problems. A lot of other organizational things come in the way, right? It comes to the mindset, it comes to the culture, it comes to those inertias built into the organization fabric, which is hampering the adoptions, right? And so the vision of the company to really solve the problem, going towards the adding the predictions using the ML, and those skill set are not available readily. That's what we are working on, making it easier from tools like Amazon SageMaker and the ML Studio, and making it very predefined models for healthcare and manufacturing and automation. So hopefully developers and companies can take advantage of that. But at the end of the day, it is about creating a strategy to attack a problem statement by thinking of data and analytics and AI/ML as a first step, right? So that AI/ML data mindset, that if you look at the traditional companies, they have a leverage which the startups don't have, which is that the years and years of experience and data and the domain knowledge and the IP. And that is what they have to leverage to solve the customer problems using the tools and products and technologies. So those are the real challenges. And we are in the business of solving that by really accelerating those solutions to market by giving them the tools and products and frameworks that makes it easy, accessible, and expansive, so that they can really achieve their customer solutions in the real time.
Thank you so much, Atul, for those insights. And let me move to Manish. Manish, from an India perspective, like the startups that you're seeing on a day-to-day basis, could you give us a flavor on, are there any specific verticals you see them, or so a bit more of insights on that would help.
I think we are seeing it has changed over a period of time. Nowadays, we see application of AI across almost all verticals. I can't think of a vertical where we are not seeing a startup working in AI. to give you some examples of transformational AI, if I can say that way, right? I mean, big companies use it in a different transformation, different context of transformation. For us, it is solving problems which are otherwise very difficult to solve. So if I can bring out 2-3 companies from our portfolio, Niramai, for example, is solving the problem of detecting breast cancer very early, much earlier than mammogram and ultrasound can do, using thermal and AI, right? And they've got FDA approval as well now. So that has been, I hope it saves a lot of lives around the world, right? So that is transformational and very disruptive. We have another company called IESA, which is in mental health. So they are able to build a platform which is actually a bot, if you will, right? But that bot is like a therapist. So it talks to you and chat. You can chat with it and understands where are you coming from. In a very safe way, is able to guide you through your mental health challenges, which is, as you can imagine, is a very difficult problem to solve technically, but it cannot be solved without AI, or rather very difficult to solve without AI, I should say. So these are a couple of healthcare examples. We have other examples as well. We have companies in logistics space trying to solve the entire allocation problem. Then we have a company called Pixis, which is actually doing very well in the whole marketing infrastructure space, where it can create ads automatically using AI for brands and target it very accurately. And now they're actually saving millions of dollars for their customers. So short answer, we are seeing application across. And we are, because of our focus, we tend to choose companies which have a slightly disruptive angle to solving problems which are otherwise hard to solve. And these companies are right here in India, but they're working for the globe. I mean, to me, now India, US, it doesn't matter, right, where you are. All of these companies have global customer base.
So that's so heartening to hear, Manish. That's really heartening to hear that you're seeing it across sectors and lots of innovation there. And thanks. Raman, over to you. If you could also share some of the examples that you've seen from a business impact perspective.
Sure, Vikram. I think we talked about some specific examples from the other panelists here. But if you look at from a broad way, the areas of impact, it can range from automation to governance, to personalization, to intelligence, to speed of analytics, to recommendations and actions, right? So if you take supply chain, for example, companies strive to sense demand real time. They want to respond real time, and they want to reach at a global scale. And also, while they're reaching and they're selling their products and services in a global scale, they also want to take the feedback real time. So all of these things, if you have to achieve at scale, you need AI, ML, and tools and other things in the landscape, such as cloud and big data, to come together to make sure that there is there is analytics done at high scale at real time, so that this can be achieved. Also, if you look at purely from a customer side, right? We are all end consumers, and we can relate to the example of personalization and recommendations, right? All the companies which are now selling, whether it's online or brick or mortar store, they want to know you, right? They want to know what products you are buying, what services you are getting from them. They are in a continuous quest of profiling you so that they can target with the right offers, the right products. And AI, ML, and data science are at the forefront of modeling some of these complex scenarios, profiling the customer scale at a granularity, so that where the users which are using systems can be provided with next best action, so that they can take actions on the scenarios. Similarly, on the governance side, the data governance side, right? Idea is to almost eliminate human intervention, right? If the data itself, you start reading data, and if you're able to do a lot of things without any touch and feel, you can go ahead and do that. and only bring out those exception for human interventions. Right? So whether it's governance, whether it's automation, whether it is personalization, AI ML is in the forefront and enabling this in companies today.
Yeah, super exciting to hear all of you, on the landscape, the opportunities and the impact that AI is able to make. Let's move to the next topic. With the opportunities also comes the challenges, right? And I guess potentially the biggest challenge right now is also the skills, the right people, right? So Raman, I want to toss it back to you again on what is your advice to engineers interested in this space?
It's a very interesting time you're going through right now. It's a good and bad both, right? The good part of it is it is so pervasive right now. The whole AI ML and digital transformation as a concept right now, every company is going through, and accordingly to kind of to service that, to help companies skill up. There are a lot of courses available today in the university. It's like every college, every university is offering data science courses today, and everybody wants to become a data scientist, as you said, right? As I think it was Manish who said about even a child is now knowing what is AI. It's appearing in the newspaper, right, every now and then. So while you have so many choices, what do you do, right? So it's very important to ask yourself this question: why are you doing what are you doing, right? In the sense, if you want to do some study, if you want to do some analysis, if you want to build a model, of course you need to have a knowledge on some modeling and statistics. You need to get trained on some tools to do that. But a very important aspect of this is you're doing this to simulate some real business scenarios or use cases. So understanding a reasonable understanding of a business domain or a scenario use case is, I think, is a must. That will help a data scientist find a needle in a haystack, as you call it, or apply the 80-20 rule to take the relevant topics first in terms of tackling and addressing it and generating value in an organization, and then build it up on that, right? So while we have choices, as Manish said, right, it is now pervasive across verticals. So, people are looking at it, building a career on this, should pick up a particular vertical possibly if they're interested to that, go deeper on that, build their expertise on that, so that they can differentiate themselves from other data scientists, right? And this is going to keep on happening. But the good part of it is there are lots and lots of demand in the market today, right? And as Atul was telling, right, you still want good people with good skills in this space, right? And the demand is going to continue to keep on growing on this.
Certainly, yeah, really interesting times ahead for the next generation who's getting into these fields as well. Sure. Manish, maybe I will toss it over to you now on your advice to young entrepreneurs who's leveraging AI technology.
Yeah, sure. I mean, with every sort of a revolution of this kind, there is hype and there is reality. So I think this is a common thing in startups or in bigger companies that don't get onto the bandwagon of AI just because it is hot. It is not a sort of a brahmastra to solve everything that you see. So it is a very important and very useful technology to solve specific problems. And unless you know what the problem is, don't jump on AI, right? It's like the reverse sort of a thing where, okay, you are fixated on AI and then looking for a problem to solve. So it's the same thing for entrepreneurs, right? So ultimately, what what is it that the business really needs, what is the business problem, what is the best way to solve that problem. AI may not be the best way to solve that problem. So, and then go from there. Specifically for startups, I also feel that in addition to these two questions, they also need to answer the question of how are they different, or what have they uniquely done with respect to other solutions that are out there in the market. Because otherwise you will get margined out over a period of time. So.
Excellent. I think that's an amazing piece of advice, Manish. With that, I'll move to Atul. You come from these large organizations, so probably a good person to help us understand the build versus buy dilemma for enterprises adopting AI and ML technologies or initiatives.
No, I think I will second what Manish said. It's very easy for founders and startups to get excited about a new tool and new hype and think of AI as the hammer that solves, every problem, thinking problem as a nail. It is about using the right use case, because it is okay at a small level when you can use AI and ML, but how is it going to scale, and is it going to, offer you the return on investment? For build versus buy, it is really about how fast and how innovative you want to become. It's about the balance of that speed, time to market, and what is the complexity of problem. And as sometimes we at Amazon have a 3-layer approach, right? We are obviously a compute cloud company, so we give at a framework infrastructure level the ML services that you can use as a developer, frameworks like PyTorch and MXNet, TensorFlow, to really control your ML models, create your ML models. That's where the driverless cars and other key innovations for space is coming. For really accelerating time to market, you don't have to know all these frameworks. You could use Amazon SageMaker Studio, and use predefined ML models and focus on use case, focus on IP, focus on domain knowledge, and solve that problem. And very at the buy side, you can use the AI services like Lex and Recognition to infuse these AI services in your solutions to really deliver those, right in time, real time customer experiences. So it is about thinking, and as Ajay mentioned, thinking about the business value of that solution that you're delivering to your customer, that customer really wants today, and in a cost-effective manner, so that you can control, because AI is, compute intensive, it can get expensive real fast. So from a build versus buy, the founders and the companies have to use that decision-making metrics to understand, what is the problem we're solving, how big, how complex, and how fast do we want to innovate, and then make a decision based on the services available at their disposal.
Very true, very true. Never an easy decision to make, but it's a very important one to make it right, and use data and metrics is the right way. Thank you, Atul. Yeah. Ajay, if you could also give us your view on pitfalls and challenges when it comes to AI at scale.
Sure, Vikram. Before that, let me extend and agree to what both Manish and Atul mentioned. I think when we look at a build versus buy debate, you should always look at building to differentiate. The startup analogy that Manish gave, and you should actually look at buying to accelerate, and that's the philosophy and the support that you get from Atul and his companies. Now, coming to the pitfall and challenges, I think every new technology that gets adopted, and something like AI, which has such widespread impact on the way it augments human, both both at work as well as otherwise in life. There are obviously concerns on privacy, there are concerns on security, and there are concerns on the bias that system may get in. And most of this bias, according to me, is unconscious one. The good part that I see about this is there is a huge amount of work going on the regulatory framework. And at the same time, there is the technology development, which is taking conscious steps where actually the machine is helping the humans to reduce bias. And at the same time, you are taking help from humans to reduce the system-based, system-driven biases. And there's a symbiotic relationship and the human loop coming in there. The other aspect is, with the kind of business decision making that AI/ML is sort of supposed to drive, there is a focus around AI ethics, responsibility, and fairness. And I think it is a very well placed focus. And what it means is that you have to look at enabling trust with AI, and that is something that consciously as an organization that you got to look at. You have to look at building AI governance, practices or focus, so that you choose right set of tools to identify, unfair features or even track features that are getting used within the organization. The other important aspect is, it's easy to sort of get into the bandwagon of putting AI, AI applications, but you also got to be knowing and continually discussing what is the purpose of the application. For example, if you are looking at a drone-based surveillance and we are looking at AI and vision analytics to sort of track people and vehicle to sort of avoid any accidents in a dangerous zone. I think the purpose of this application is to sort of track people and vehicles and address their safety, and not to look at identifying them by their face or the number plates and stuff like that. And there are few recommendations that you should always keep in mind when you are actually sort of designing this kind of use cases. I think one is to actually look at a large set of data to dilute the biases. Other is to sort of keep constant monitoring around the biases that may happen in the system and track the model and the feature usage on a continual basis. The other thing is, if at all possible, when you actually create a team, the construct should be coming from a very diverse background of the team, so that all aspects are covered. Now, coming on the privacy and compliance, I think PI information handling is very important, and we generally focus on the data aspect of it. But if you look at from an AI perspective, I think the features like race, ethnicity, gender, religion, I think they have to be handled with the right amount of sensitivity. And if you're building an AI application and the input is of sort of image which gives you some differential privacy or give you information around the house address or car license plate, I think those have to be handled at a early stage so that the information doesn't percolate deeper into the system. Now, the good part is, as the awareness and the compliance needs are growing, complying with regulations and looking at standards like European Union regulation for AI and GDPR standard, I think that will help us set the roadmap for AI governance. And as AI gets more and more adopted and becomes a DNA for an organization, I think the governance aspects becomes very, very important, so to speak.
All right. Thank you so much, Ajay, for those insights. Srinivas, before we open up for the next round, I wanted to check, are we allowed to go 5 minutes over?
Yeah, please, Vikram, go ahead. I know we have started late. Please take that up. Yeah.
Thank you so much.
Actually, the discussion is quite interesting. I think we should bring up all the points that you're planned for, please.
Thank you so much. And before I go to the next round, guys, I want to mention that Manish has a hard stop at 6 o'clock. He may go a couple of minutes over, but the last round, maybe I'll start with Manish, and we may not have time for any questions for him. So the last round we had planned was for future of AI, right? And Manish, if you could start with India perspective, right? Impacts, benefits, anything else you want to mention from a future of AI?
I think future of AI, in our opinion, is that it will become a very horizontal sort of a layer across products. Like, a few years back, mobile was in that stage, right? We were asking, do you have a mobile app, right, for any application? And some people had, some people not. But today it's like a given, you don't even ask, right? Similarly, cloud before that. So we do believe that the future of AI for most products will become sort of a given layer in a product for most applications. So that's one angle in the future of AI. The other is just the AI as a technology. If we look at and what does that future hold? Of course, we are still in very narrow AI, right? We are looking at narrow use cases, solving for them, etc. But things are moving ahead from there. Like, one of our companies actually is able to create relevant video ads for brands, right? Which I thought was pretty creative. And things are moving up that ladder where the AI technology is able to sort of answer a bit of human creativity angle. So we've actually seen companies which are working in synthetic music generation using AI, synthetic art. In fact, some art piece got sold also, I think, which was created by AI. And movies. We recently met a company which is trying to create mini stories using AI, given a little bit of a brief, right? So what is predictive, analytical in nature to what is creative in the human mind, as a technology, you are sort of moving there as well. With all this, obviously, will come some challenges as well in terms of privacy, in terms of biases, in terms of some of the things that I was mentioning. But the future definitely looks interesting in either directions that we think about. How the AI technology will become horizontal for a lot of products, and how, from a technology forefront perspective, it will solve more and more human creativity domain problems than just analytical problems.
Certainly looks very, very interesting for sure. Future looks very interesting. Thank you, Manish, so much for your insights on all the topics. Feel free to stay, if you have time, or no problem if you have to drop out.
Yeah, thank you so much. I would like to drop off. That is okay. Sorry about that, but thank you so much for having me on the panel.
Thank you so much. Yeah, thank you. All right, let's move on, guys. And Ajay, if I could come over to you now with why is this, if we talk of AI at scale so much, right? And so could you give your perspective on, from a future perspective, why is there so much talk of AI at scale, and what is in store?
Sure, Vikram. I think, first of all, I think, as my fellow panelists mentioned, we are at the tip of the iceberg. It's just a starting. But the most important thing is, more and more industry leaders are actually getting to the AI-enabled innovation across all their functions. And there are encouraging trends where you are actually looking at adopting the full cycle of AI, including the nuances from conceptualization to production and the management post that, and there is a focus on AI platform, focus on feature engineering, feature stores, doing ML operations, doing AI governance, and a good amount of investment is happening on the training and the monitoring infrastructure around AI. Before we get that, I think the most important thing is, why is AI, getting to adopt at scale, and why this is something which is going to be accelerated in the times to come. The first and most important aspect is that most organizations are seeing value with the AI ML based initiatives, and they're quickly graduating from AI driven, minimum viable product or a proof of concept that we create to basically make AI ML as a central piece to drive their innovation. That's actually the number one thing. The other thing is the leaders are looking at AI innovation, as I said, scaling across function. And what it means is, if I can extend the example that Raman mentioned, where he was looking at forecasting, for a supply chain use case. Now, it's basically a forecasting use case, and organization would look at not limiting them to supply chain, but also see how those models could be used in the area of finance, to improve their DSO, in terms of marketing, to understand the prospecting part of it, and in terms of even operations, in terms of the footfall and other angles that they may look from a forecasting perspective. So this is, from a business front and the thought process that is there. On the technical front, I think, Atul already spoke about PyTorch, which actually handles AI applications at scales and lets you do that. Now, the first thing is, there is a requirement to manage data at scale, and there are capabilities and technologies like Spark, and then Spark ML Lab. There are compute infrastructure coming as services from the cloud providers like AWS and Microsoft, looking at multi GPU computing, ability to sort of scale AI, scale AI application, and with the orchestration that is supported by the DevOps tool like Kubernetes and Docker. Okay. Also, as we are looking at designing and implementing AI models, may not be for perpetuity, but at least for the foreseeable future, you are actually looking at requirements of they being manageable, they being monitorable, they being retainable, and data drifts are basically looked at so that the accuracy of the model, the changes in the data that is fed to the systems, are basically being managed using model ops, ML ops, and tools around that. and when we look at AI at scale, obviously there is focus on the performance of model. It's not like it's done once because it's training itself. The input that it feeds, can have an impact on the outcome of the decision that is there. And I think a case in point has been COVID, where most of the retailers saw that there was a huge impact in their next best action, when they're trying to portray the customer behavior. And because of one event like COVID, the behavior pretty much started to change, and there is an enhancement in terms of the adaptive learning, and models that came in. So I think it's becoming very clear to organizations that if they have to drive a better ROI, AI should be scaling across functions. AI should be penetrating deeper to the foundation of the business stack, rather than they being a standalone AI applications, which is used as a showcase of the organization adopting AI.
So thank you so much, Ajay. In the interest of time, I'll very quickly move now to you, Atul. If you could give your insights on future of AI from a cloud perspective, cloud enablement.
Yeah, I mean, Ajay covered most of the points. I mean, we actually believe, with a day one mindset at Amazon, that the future is actually now, right? We have everything, all the tools to build. Future is now, as we knew it, right? When we grew up, we thought driverless cars and vehicles we would never see. It's now, right? We can drive driverless cars. I think the future of AI is really making it mainstream into our daily human experiences. Everything. I mean, today, if you order something from Amazon, Alexa will tell you that your package is on the way, right? The drone delivery will start soon. So we do not even know that unknown and unmet needs of those customers and what AI can deliver those needs. So the future of AI seems to be where we need to reach the unserved customer and human problems into the deep end, that long last mile of problems to the deep territories where we cannot reach, where it's very difficult to solve some problems. That's what I think the future of AI will come, which we do not know. But if I can share that AWS, our aim is to really allow for AI at scale, building in every product and service that we build in. And because we are talking about Electronics and Semiconductor Association here, the innovation which is happening at the infrastructure level in our Trainium chips and our P4D instances and Info1 instance, where the ML inference can be done in 7 seconds, 7 minutes, instead of 7 weeks and 7 years, 10 years ago, right? So the future of AI seems extremely promising. It's up to us, enterprises. Gartner predicts that by the end of 2024, 75% of enterprises in developing world and developed world will go from piloting to operationalizing AI, which is immense leap to basically just make it at scale, right? To using ML ops and AI ops and all the other stuff. So future of AI, I think it's unknown, but I think it seems big. We'll be able to innovate faster at a rapid pace and solve big problems faster.
So all those sci-fi movies and Star Trek's real, all that coming to life now, right?
Coming to life. Yeah, that's true. Exactly.
Yeah, Raman, if you could give your view on future of AI as well.
I think it's been covered by Ajay and Atul and Manish when you were there. I think it is going to move from, AI is, we are trying to simulate or bring intelligence to machines, what a human has got, but it is going to go and become augmented intelligence, right? It is going to be AI plus human intelligence in future, right? How AI is going to help humans for better predictions, for better decisions, and there are so many new things coming up. There's a whole world of metaverse right now, right? People are buying digital real estate, right? Their digital homes, digital assets. Students are living in the digital world, the gaming world. They are so cut off from the real world. So we don't know where the world is going in terms of the whole digital space. So this is just going to grow, and on both sides, on the infrastructure side, you will find more and more new innovations in scaling up hardware to for analytics, for processing, for management, and on the software side, newer problems getting solved with newer use cases, with newer apps. So it's going to grow. It's going to keep on growing. That's what I'm going to leave it at.
100% agree, though. So with that, we come to our final part, which is the concluding remarks. Thank you so much, everyone. It's been very insightful. I've made a lot of notes here, but I'm going to just read out maybe a few of the notes and then hear out other panelists on what their concluding remarks are as well. First of all, very happy that we have 100+ years of experience and knowledge compressed in 1 year, all from diverse background, but at the same time, all from AI for digital transformation background. So, there was a diversity at the same time, there was similarity as well in terms of the topic, right? I hope engineers as well as young entrepreneurs got some very valuable lessons as well as insights, as well as some great advice on, how to build their careers in these things, what to do and what not to do, right? Also, we got some very good insights in the, the landscape, how it is changing, how the businesses are getting transformed, and most interestingly, this is happening across sectors. So to me, the future looks very, very interesting. With that, let me pass it on to Atul for his concluding remarks.
Yeah, no, first of all, thank you for a very good session. I enjoyed the discussion with my panelists. I would keep it brief. I would basically say that the call to action is upon us, for the developers, for the enterprises to really take that AI first, ML first approach, innovate faster, think bigger, and build better with all the tools that is available to you, and really create the pioneering solutions for your customers. Take that day one mindset, be customer obsessed, and have bias for action to solve with the tools and technologies at your disposal. With that, I really thank you, Vikram. Great job.
Thank you. And Ramon, over to you for your final remarks.
First of all, thank you for inviting me for this panel, and then to you, Vikram, to Ajay, Atul, and Manish, my panelists, as well as to Srinivas and other people who are organizing this. It's a very, very relevant topic in today's day and age. As I said in the beginning, this is the information century. So if you're in this field, either you're having a career in this field or you're investing in this field, you're set for life. This is not going to go away. You can pretty much retire, or you can not you yourself. A few generations can retire in the field of data, right? So it's going to stay. It's going to expand. So thank you, and you all have a good one.
Thank you, Raman. Over to you, Ajay.
Thanks, Vikram. I think overall, I'm very, very excited personally with the digital transformation and AI's role in creating a massive impact to businesses. I think the most important thing is that the success and innovation around AI lies behind technologies. Technologies will come and go. There'll be low code, no code. There'll be a new definition of full stack, including data, AI, and other technologies, including mobile. But if at all you're embarking upon this initiative, where you're wholeheartedly embracing AI, I think it has to be an org level initiative, which enables a culture for you to proactively embrace this change and truly transform into a data-driven organization. That would be my takeaway from this discussion. Thanks a ton, Vikram, for this very, very fruitful discussion. Very huge learnings from fellow panelists, Manish, Raman, Atul. Thanks, Shini and the entire IESA organizing committee for inviting me again, and thanks everyone for joining in this panel discussion.
Thank you all. Thank you, Srinivas. I don't know if you have time, but if you have time, we have questions. Otherwise,
one question we'll take before we conclude. In fact, the question is from audience. So, what are your recommendations or best practices in reducing biasing errors in AI ML or developing unlearning AI ML algorithms?
Ajay, you want to take that?
Sure, I'll take that. I think it's a fantastic question and very relevant to today's era. I think if you look at human, human basically come from the experiences and learnings that you have. And even if you look at social media, there are echo chambers where people basically are looking at affirmative answers and stuff like that. Now, if that data is fed to the machine, the machine is obviously going to sort of look at that as a knowledge, and and we know the decision will be influenced with that, and that's where the biases and all will come in. The good part is, there is no right and wrong answer. If you look at some of the initiatives from Google, there are a lot of challenges around the around biases and the correctness of the morality and the correctness of the answers that you get around that. But I think there's no right answer. It's something which is a jugalbandi or symphony between human and machine, that has to go and look at that as a negative feedback, where you actually sort of correct each other. And over time, it will improve. I think that I'm 100% sure. Coming to learning and unlearning part of it, I think the most important aspect in AI governance is the monitoring and managing of the drift that happens on the model. Now, you got to understand that the model is a what you call a humification of what data has been fed today. Come COVID, the customer behavior changes. Obviously, the outcome will be very different, because the model has not seen those kind of data. Now, the ability to manage drift and from outcome to look at the input and see if there's a new set of data coming in, and then the ability to train the system in near real time. I think that's going to be the key to sort of be as real time and as adaptive and as responsive as you can. I think obviously it's going to take time, but with the kind of effort that's going on the infrastructure, the kind of automation that's going around the machine learning, the ease of use, I think it's just a matter of time, when we have all these results with us.
I have few questions, but in the interest of time, I will pass on, and probably we will address this offline. Vikram, I'll share it with you. Maybe we can get back to them offline. Yeah. So before I conclude, I would like to thank all of you. It was very insightful and interesting discussion. I think, Vikram, you're able to bring up all the relevant topics, right from opportunities to challenges to the future. I think all the points are deliberated, and the views from all the panelists very interesting, and I'm sure it'll be very insightful for all the audience. Thank you very much for all of you to join, and Raman, get well soon, and and Vikram, thank you for chairing the session and moderating and coordinating with all of them. Thank you.
Thank you so much. Thank you, everyone.
Thanks all.
Thank you. Bye-bye.
Thanks, everyone. Bye.
Thank you.
Good afternoon, all. So these were amazing panel discussions and keynotes. Now let us get back to our startup showcase. Today we have amongst us Mr. Jit Basak from Catalyst AI. He's based out of US. Catalyst AI is a drug discovery data science platform. We'll know more about it from Jit in a few minutes. Let me introduce you to Jit. He is the president and CEO of Catalyst AI. Previously, he was the transaction lead of corporate development at Shire and Takeda, and Innotek Pharmaceutical, following investment banking advisory roles. He was a FINRA registered investment banker and has led transactional work with increasing responsibilities at Ferghana Partners and Capstone Headwaters. Jit holds a PhD degree in synthetic organic chemistry from University of Illinois at Chicago and master's degree from IIT Kanpur. Jit, we are all eager to know more about your company, your medtech startup. The floor is all yours.
Thank you so much, Sridevi. Am I audible clearly to everyone?
Yes.
Okay, great. Thank you for this opportunity. I think the last session just made it clear. Data is the next frontier for us. It's now, and maybe 5 years ago, when I thought about starting Catalyst, was just the beginning. So thank you again, everyone, to listening into about Catalyst, the journey, the story. We are entirely focused in the life science market, and we have built a very unique competitive intelligence platform. Currently, we're focused on drug development. We can focus on medical device as well, but our current focus is to accelerate drug development. As it's evident from the name, we're using artificial intelligence, and we want to accelerate brains to market. Why we're doing this? First of all, there is too much data. If anyone who is dealing with the life science information know there's an information overload, and to process that data, there is labor-intensive, repetitive work, and we curate data and poor integration. So we're often missing out this information, or we are spending too much money. So our solution, what we did, we created an integrated life science database using artificial intelligence to extract information. So we have developed, actually invested last 3 years, a lot of energy, a lot of work behind this to find technologies that can perform human jobs. So now we can actually isolate information, finding needle in the haystack. We can connect those because it is a single integrated platform. And obviously, once we can get this structured, it's very easy for everyone to consume. So what did we actually do? So as I mentioned, we have developed method to collect and identify critical information from large documents. And we categorize that. And in addition to that, we have developed methods that can identify. Because we are doing all these things in the real time, we can convert them into alert. So in turn, what we did, we deployed bots to manage this overwhelming data flow, and we're reducing the human repetitive labor. Our bots takes unstructured information and it creates structured data points. And soon I'll show you some examples where this data coming from. I think it's very important to mention here, we are partnered with Zeltmark from the inception. In 2017, I had a call with Sandipan in the summer. Sandipan and I were high school friends. And in the summer of 2017, we had a discussion. It took us about 2 years to actually start this company as a catalyst. And now we have a fully operational data platform. I'll show you about that in a minute. But it's very important to inform you here that without this partnership with Zeltmark, Catalyst won't be there, but it is today. We have used a lot of resources of dedicated data scientists and life science experts to build it together. And behind the scene, there are a lot of ML and NLP work has been built. Very busy slide, my apologies, but I just wanted to give you an idea how much information we're processing on a daily basis and where those data coming from. We only use authentic sources and public domain information. As you can see here, all the way from the business side of information, such as SEC filing, to all the way to the scientific side of the information, we are covering all. These data are processed and granulated into actionable data points. I'm happy to talk about more on a later time, but because of the constant time, I'll keep it very simple here. So as I showed you different data sources, we use rule-based NLP and deep learning methods, and we convert them into different types of data points. And since all these things are happening in real time, once again, we can convert them into alerts. Whether somebody is doing a clinical trials or had an announcements of regulatory events or a corporate event, somebody hired a new CEO, chief business officer, we can find all those things in the real time without human intervention. And on top of that, what we do, we use curation of the data so that when you put this data in the database, they're curated and really clean for everyone to use. In addition to the scientific side, as I mentioned, we can track who is financing, who is doing venture financing, who is doing debt financing, all those information and the corresponding investors, we can extract that information. Moreover, we can also find out who are the partners who are acquiring, and these are all done in real time. So we answer critical business questions. Whether somebody is trying to figure out what is the new drug they should be working on, they're trying to figure out if they should in-license something or track timelines of their competitors, we have all those answers inside our platform. Indeed, what it does, it reduces cost because we do not, because we have this platform which is generated using artificial intelligence, we are reducing the repetitive human labor. And we're adding both in the top line and in the bottom line because we're increasing efficiency by providing accurate data with accurate reference. At the same time, we're taking away that unneeded work, which is adding to the bottom line of them, saving money for the company. Quick glimpse what's inside the platform. So far, we have launched only 2 parts of the company, 2 different sections, which is available for the customers. We have paid customers. It's a recurring revenue model. And we're very excited that we are in this journey since last couple of months as we went and launched this product. You can see a little bit here, what are the different types of ideas, whether it's a trial information or approval information or a company information or a drug development situations or a transaction. We have it all. And we collect all those things in real time. I'll show you a quick glimpse of the platform in a minute. Before that, just want to mention who is going to benefit. Of course, the biotech pharma industry will benefit a lot. Anybody who is advising, such as consultants, investment bankers, for transactions or strategy, they can use this platform as well. Most importantly, the investors who are trying to make the decisions, yay or nay for a particular investment, they will have more granularity and more information to make their decision upon. And finally, we also have to plan to get into the retail investor market, but currently we're not doing that. That is a plan in a long-term goal. Giving a little bit more glimpse, what's done so far and where we're going with this. Right now, we're anchoring primary customers. Very excited to report that we are actually a revenue generating company. We're no longer a dream. It's validated and customers are loving it every time I show them. We have been very slow in rolling it out specifically because we want to make sure it's robust and customers can really enjoy the platform. We are introducing functionalities going forward. As I mentioned, we have alerts and the platform right now. We are going to introduce additional functionalities such as on-demand search so that somebody can easily find information on their request. And we are also introducing interactive modules so that it's easier to visualize. Finally, we have plans to expand into more scientific products and integrate the stock market data and create an enterprise level platform. So those are going to follow as we go through this journey. We believe we're ahead of this competition of our competitors. As you see, this particular slide shows we are in a big league. We're not really in a small league here. Big pharma, big data providers such as Evaluate Pharma, Clarivate, or on the other side, PitchBook, S&P Cap IQ. We more overlap with the scientific side, and we also bringing in the financial data. In addition, we are probably superior to AlphaSense for biotech and pharmaceuticals because we are heavily focused in life science and granularity of our data. We believe what we started is just the tip of the iceberg, and there's a lot to come. We have a fully integrated platform which can provide access to customers. It's a web-based service, so they just log in and log out for their use, and we complement those data platform with daily alerts. I'll show you quick examples of that. Finally, I'd like to thank Sandeepan and his team, and of course, Nausad Avali, who have been involved in this project from the very beginning. COVID, we went through COVID. We employed 10 interns in the US through COVID, and the big team involved from Zilk side, and we are just starting this journey. We have many experts from the industry who help us guide, as you see there, this journey to go where we are. I'll take one quick second, and I want to show you the platform. Are you still able to see the screen?
Yes, yes.
Okay, so this is our alert system that goes out on a daily basis, whether somebody looking for information for FDA, EMA announcements or Japan announcement, or somebody looking for information for clinical trials. These are fully automated. Or if something is happening within the clinical event, we can isolate, identify all this information and send out an alert. If there's a regulatory event or transaction event, all these things we can map on a daily basis. Finally, this is our platform. I won't take too much time, but I just wanted to give you an idea that here there's a rolling news from today or yesterday, depending on the time when you're looking at. So it's a real-time information here, integrated with charts and everything else, whether somebody is looking into charts and in different sections. I'll pause here for the time, and I'll take any questions if you may have.
Thank you, Jit. Thank you so much. But unfortunately, due to paucity of time, if any questions are directed towards me, I'll write to you.
Okay, sounds good.
We will redirect the questions to you. Thank you so much for your time.
Absolutely.
Thank you. With not much ado, let us go to the next startup. This startup again is disrupting edutech and has more use cases in other sectors as well. Amongst us is Mr. Anand Sivaram, co-founder of First Sense. He's an innovator and entrepreneur with 20+ years of technical and business experience. He is a product developer with deep experience in IoT, video, and deep tech application platform. He previously worked with 5-Octave Solutions, Cisco System, Tandberg AS, Texas Instruments, and Hughes. He did his bachelor's from Puducherry University and master's from Johns Hopkins University. Well, as I said earlier, he's the co-founder of First Sense, which develops functional solutions using intelligence augmentation. Their solutions are developed for privacy-sensitive data by utilizing the power of edge computing and hybrid cloud. Their secondary focus includes automations in process control and industrial IoT by leveraging video analytics and machine vision IPs. Anand, really thank you for being amongst us today. The floor is all yours. We are eagerly waiting to know more about First Sense.
Thank you, Sridevi. I'm Anand from First Sense. I think I'm audible, right?
Yes, yes, you're very audible. Very much.
Maybe I think we'll start with going through the slide. Let me start presenting.
Yeah.
So you can see this, right?
Yes,
Hello?
Anand, we can see this. We can see this.
Okay. So first of all, our company name is First Sense. So that just to go back, it's around 1 year old, and we were just thinking how to name it. And then we thought we are having around 5 senses, and out of which is the most important sense, that is vision. So we thought that, okay, our company should be something to do with vision itself, so that because we are having so much of experience in that, and around 70 to 80% of information a person, a human being gets is through vision only, and all other things together will only add up to around 20-30%. So that's how we got our name First Sense. So, and this is the second slide. So going, so these are like First Sense, we 3 people are the co-founders, Kiran, Jijo, and myself. So like we were together for the last 12 years in multiple companies and startups, and going back to around 20 years before, we all started with that time very nascent in video technology. So it was like video was getting started. So we got with 264 encoding. Then things went ahead with voice and video over IP, etc. And later on, we all met during Tandberg and Cisco time, in which we were very much we were very instrumental in making the few codecs and camera systems and AI-based trackers. So that was for the high-end customers. And later on, we went to PyOctave together. And there we made our Sure Bell, which is a cloud-connected IoT-centric camera with a lot of intelligence inside. Then that we transformed that into PaaS cloud. So, and that was our journey in PyOctave. And later on, we got into FirstSense, and which is into completely visual intelligence. So with the help of SELP, now we are working in FirstSense. So now coming to the next one. So we just think about it. When we get a machine observer, or rather a humanoid, let us say that, how do we think? I mean, how do you think about visualizing different scenes? We know that human beings have emotions and they do different actions. So, and if you look if you look a simple observer, a simple machine, it will not be able to detect many things. Whereas if you analyze it as a holistic scene, we know that we have to do many different analysis together. For example, you look at a different scene in which you can see that top left and top, that top left and bottom left. You can just see that it's all like people standing and doing and jumping and all. But the way it is all interpreted is very different, because you know that in the downside, it's like a few children, they are being very happy with teacher, whereas even the other children who are standing, you know that they are very much like they are not sitting properly in a high school classroom. You know that it is the children are not very well organized. Whereas if you look instead of that, if you find people standing on the road and doing like that, you know there is some real crime or something happening. So a human mind is, even without we thinking, right? We know how to analyze a scene very well, because we know how to holistically analyze things properly. So we have to get the scenes properly and completely analyze it, and then only we will be able to get the outcome of it. So yeah, coming to the next one, right? This is going to be like a powerful machine observer. That's how we look things. You just think that there's a machine or a kind of humanoid sitting there, and that particular machine is able to get multiple data, different type of data. I mean, let's say that it's a multi-model data. I mean, by multi-model, what I mean is that it's not only video, multiple videos together, multiple audio sources, and there may be multiple other sensors together at different time epochs. So that the data which is analyzed has a lot of dependency on different things. And then we just get into a kind of we will infer the data, and from this different multiple implicit information, we want to get an explicit interpretation to that consumer. So that explicit information will be different, different charts or reports or different suggestions, or it will be like kind of you just say very generically, it will be for third party, some other integration, it will go to your direct other machines or anything like that. So, and it has to be rendered properly to the user so that they can interpret in their way. So the goal is to holistically take the different sort of implicit information, what you can gather, then analyze it and process it and get it so that it will be an explicit information. So basically the kind of mantra we were following is that implicit information to explicit interpretation. So this is until now it was like a kind of philosophy, implicit to explicit, but coming to this thing, you know that, right? We can have multiple use cases for finally we have to solve real world problems. So then we thought that education is going to be our first place where we will be testing. It will be the first testing ground for our hypothesis. So one of them is that class dynamics, and so if you look, right, I mean, things have changed in the last 2 years during all these lockdowns and all. People initially, nobody had any belief in online. Then they all suddenly over a night they are been pushed to online. Then later on, that now it became online plus offline, and now people say that okay, they have to go to offline and like that. So initially we thought about like having a class dynamics for the real class. But as and when things are going, we realize that getting an immersive thing is going to be a very good use case in which people were losing track in online education. So they have to really immerse into it so that it can be like for different use cases and different education, it will be very useful, especially like the kind of other sort of not the school sort of education, but you think about other coachings and like other entrances and all other sort of or tuitions and things like that, right? It will give a good value in having an immersive classroom experience. And what we want to do is that if just to club it along with Meta World and Meta Twin, so that it will be a good experience for children to go back and do relearning for what they have done. So considering all these things, we want to target all online, offline, and the real hybrid scenario. Hybrid, I mean, the nowadays it is getting turned to high flex. So that in the high flex scenario, to prove what we are doing, what we are getting is a kind of teacher studio or a teacher booth in which there will be a targeted booth in which all this there will be different multimodal cameras and audio input devices, and there will be a display in which the teacher can live see that whole meta of children, so that teacher can get an immersive feel, and not only the teacher, on the other side the sitting children also can get an immersive feel. So it can be, I mean, we are visualizing it. I mean, we don't think there is a requirement for VR, but of course later on, if it is required, we will get that too. So these are the 2-3 different scenarios in education we are targeting, and the other one is going to be a hybrid proctoring. So proctoring, we just don't need to think that it will be just for testing, I mean, automatically to make sure that nobody is cheating. I mean, of course, that is a part of proctoring. But along with that, we want to use it for self-evaluation and continuous evaluation also. So that you just think about a scenario in which children are going to some entrance coaching or some other mock tests and things like that. So they get the real feeling about taking that actual examination so that they can prepare very well. So that is what is the way we are looking by hybrid and high flex proctoring scenario. So this is, you can see that this is a bit different, but when we look from the angle of our initial thought of implicit information to explicit interpretation, the way we develop things can be very well adapted for many other use cases. And one of them, what we were also looking is in the case of airports, in which there are n number of use cases like avoiding jet blast, and then once a flight comes landed, from that time onwards, right, it is taking off. There are many things to be done. It has to be under process, and it will be, so it has to be followed. And this type of process automation itself has a lot of requirement, and it can be used for predictive maintenance, then apron management, and many things like that. So that is another targeted use case which we are working on closely. So, and going next, this is a kind of high-level overview of how we are getting our solution ready. So you just don't need to think that this is a classroom or anything. It's just you think that it's an observation area. The observation area can be a classroom, or it can be some other outdoor, just like what I mentioned about airport. So it's a series of multimodal data input. in which you will be getting multiple video streams and multiple audio streams and some other sort of sensor data and all the things together. We try to maximum analyze it in the edge itself, because it gives us two advantages. One is that it gives us that security, privacy is one side of it. The other side is that you don't need to take all this data to the cloud. And once we do that, once we gather maximum context from that edge, that then the remaining things are taken to our cloud, and there it will be transformed into for each and every use case. Depending upon that, it will get into a meta for that particular use case, and there will be second level, higher level inferences done in different containers. And for the case of education related things, there will be a conferencing management for this implicit data management, and that conferencing we can be used for, because of the class, right? It will be having the conferencing. And if you look, there will be dashboards and all other different API integrations and that explicit information with all the things for different people like teachers and the management, and of course for children's parents, etc. like that. So it will be there. The thing is that, right, what we want is that we don't want too much of difficulty in installation, so that it can be installed by any normal person who can install normal cameras and computers. So maximum calibration stuff, depending upon the scene, right? The maximum calibration stuff has to be done automatically. That is another point what we are taking care of. And and we don't need to go for some very specific hardware. Our goal is completely work with commodity hardware and commodity cameras and commodity audio capture devices, and use that kind of commodity analytics engines and hardware, so that it can be analyzed in on-premise itself. So yeah, so going that was a technology side. Going to kind of thinking what we are doing completely. So with our so much of background in different areas like computer vision and then that whole multimedia camera technologies and video related things, and we just have to combine all the things. And we don't want to leave each of them separately, but we want to combine it and get a multi-model technology also, so that we have a very good machine observer. So the machine observer is able to get all multi-model data, observe it locally, and with a lot of importance to on-premise analytics. And we do the edge maximum processing on the edge, so that our privacy and data privacy, especially that amount of data, the ownership of the data are not compromised, and get that condensed information to our cloud for things like education. We'll be having it in Meta Twin, and so that it will be presented with so that and the users get an immersive experience. So, and just going to next, the kind of offering what we are working on right now is that we want to have our data to be, presented from cloud, which will not be too much like one particular cloud centric. It has to be like agnostic, so that tomorrow you just say that, okay, instead of cloud provider one, we want to have it in cloud provider 2. We will be having, we should be able to do that. And that is one thing what we are focusing on. And as I told before, we are focusing on having on-premise things, so that tomorrow, for especially things like airline industry and all, they may not be confident in taking things to cloud because of security reasons. So that it will be do maximum analysis and consume data and do it on the private cloud itself, and customize the applications for the need of each and every customer, so that it will get a look and feel and everything according to what they want. So this way we will get a completely holistic data gathering to that interpretation, we will be doing in a completely holistic way. So yeah, so this is our website, firstsense.tech, and I am Anand. This is my email. So very nice giving an overview of what we were doing. Maybe like Sridevi, if you have any couple of questions, maybe I can answer.
Well, Anand, it's amazing to note that you're working in classroom management and airport management and single application applicable to both these kind of industries. I would like to understand if any other use cases are there. I personally, this is my question from my end. One of the participants also asked something similar. They were trying to ask any other use cases you have come across, and maybe at a later date you would like to do.
Yeah, see, actually, yeah, thanks, Sridevi. Actually, you know what, if you look from this thing, right, what we are doing is, I mean, as I told you, implicit information to explicit interpretation, that's what we are doing. And we thought that education has a big market, big potential, and it was going through a kind of churning during the whole lockdowns and things like that. But if you look that, you just think about in a way in which you keep a machine observer or a kind of humanoid which is able to gather all the information. So it can be used in not only education or this airline industry, and say, for example, facility management in a big kind of different infrastructures or buildings or anything like that, right? Wherever we think that, okay, it has to be kind of logistically, holistically analyzed from a machine observer point of view, and to get interpretation, explicit information interpretation, it can be used. And we just started off with education, and with a focus on main focus on education and the other thing on the airport thing. But we, while developing the whole system, what we are doing is that it has to be, we have this in mind, so that it has to be like a kind of modularized, so that each module can be tailored according to, tomorrow you say that, okay, this has to be used in some other XYZ use case. So that initial thing, if you look, right, that gathering, video gathering, audio gathering, all are a kind of known thing, and only thing that different interpretation part has to be changed, and the kind of the final that whole way in which it is displayed to you in maybe like web page or mobile app, and those things need a customization. So it's a part of kind of, you just say that the core platform or the engine remains the same, and you just modify the outer things according to a newer use case or industry.
Yeah. Thank you so much, Anand. Thank you for your time, and wishing you all the best in your future endeavors.
Yeah, very happy to participate. And if at all anybody wants, and just a quick thing, we are also planning to get a POC of our that classroom things I was mentioning, that that classroom studio and or the classroom booth one. So we are working on it. Our plan is to get a POC working in a month or 1.5 months. So in case anybody wants to kind of get to know more about it or a kind of collaborate, please feel free to contact myself. I mean, Anand at firstsense.tech, or we are available on LinkedIn and our page and everywhere. Okay. Thanks a lot for everybody for listening. Thank you very much. Have a nice day.
Anand. Bye.
Yeah,
Thank you.
Bye-bye.
Well, the day one of IESA AI Summit concludes now with this interesting startup showcase. We will be back tomorrow morning at 9 a.m. IST. So stay tuned for some more interesting keynotes and panel discussions. You can see them on our website in the agenda section. Thank you so much. See you all tomorrow.